John Smilga teaches this course about the practical applications of TypeScript. TypeScript is a strongly typed programming language that builds on JavaScript. This is an excellent course for people who want to learn TypeScript.
Hey, what's up? It's John from Coding Addict, and welcome to Practical TypeScript course, where we'll focus on practical applications of TypeScript so you can start using it effectively in your projects right away. During the course, we'll cover everything from setting up your development environment to deploying your TypeScript applications. The course consists of three major parts. First part, TypeScript fundamentals, where we'll explore basic types, interfaces, classes, generics, and the rest of the good stuff. Second part, React and TypeScript, where we'll integrate TypeScript into React projects, create typed components, and manage state with TypeScript. And the third part is where we'll put our TypeScript knowledge to good use and build a modern store application with TypeScript, Wcislo UI, and React Router. If you wish to explore all of the features of the store project, it's located at this URL, typescript-config-sloth.netlify.app. Again, the URL is typescript-config-sloth.netlify.app. Quick side note, during this video, we'll only cover parts 1 and 2. So if you enjoy the content and wish to work on the big project as well, consider enrolling in the full course located at codingaddict.io. Again, the full course is available at codingaddict.io. Okay, and first let's recap that JavaScript is considered loosely or dynamically typed because variable types are determined at runtime and can change as the program executes. This means you don't have to declare the type of the variable when you create it. And variable can hold values of different types at different times. So the following code is a valid JavaScript code. However, where are we going to encounter an error if we try to run this code? Correct, at runtime. And this is manageable if you have few lines of code. But the bigger the project, the more challenging it will be to spot such technically innocent bugs. And this is where TypeScript enters the picture because it is a programming language that builds on JavaScript by adding static typing. This means you can specify things like types of variables, function parameters, return values, and some other things to help catch errors early and improve the code quality. It is a superset of JavaScript. So yes, all of the JavaScript code is also a valid TypeScript code. Now, one way to think about it is as follows. By using TypeScript in our project, we'll still write the JavaScript we already know, but with some elements or sprinkles of TypeScript. And these elements will act as safeguards or constraints to help us catch potential errors more quickly and without the need for 10,000 console logs. When we introduce TypeScript to our project, we will write our app in the .ts, or in the case of React, in the .tsx file. There will be a compile or transpile step where all of the TypeScript code is transpiled to good old JavaScript code. And at the end, since it is a vanilla JavaScript code, we can run it anywhere. Quite often, you'll hear people say something along the lines of, well, once I built my first project with TypeScript, it was very hard to go back and build with just vanilla JS. And even though I was also very skeptical of such statements, I can verify that it was the same in my case. Yes, TypeScript still has learning curve, and yes, it involves more work. But at the same time, you'll notice how you're able to fix a bunch of the errors quickly at build time without running around like a headless chicken. Before we set up a brand new TypeScript project, I want to mention a few useful things. If you're confused about some topic or simply want to research a concept in more detail, a good place to start is TypeScript docs, which are located at typescriptlang.org. Again, the URL is typescriptlang.org. Also in there, under the Playground tab, you will find a nifty code sandbox or TypeScript Playground, which I might utilize from time to time during the course to underscore some particular point. It works as follows. On the left side, we write a valid TypeScript code and we get back the resulting JavaScript code. Now, you won't be able to build the entire project in there, but it is a very cool option if you quickly want to test something. As far as the code editor, I'm going to use VS Code, and since it's practically an industry standard these days, my assumption is that you'll use the same one. Since I record courses, I use the very basic default theme, and when it comes to my extensions, I will mention some useful ones once there's a need during the course. In order to work with TypeScript, you will need Node installed on your machine. Again, something I assume you already have done. But if it's not the case, please visit nodejs.org. Again, the URL is nodejs.org. Pick your operating system and follow the install steps. Also, during the course, I'm going to reference the main course repo, where you'll find source code, challenges, notes, useful references, and tons of other useful stuff. So I highly suggest getting a hold of the repo before you continue with the videos. Just look for my GitHub profile, and under the repos, search for TypeScript course repository. There are a few ways how we can add TypeScript to our project. Since it's available as an NPM package, we can install it globally or on the per project basis, set up the configuration, and run the compile step manually. This is definitely an option, but we're going to take a different approach, which is going to be pre-built template. Because at this point, at least in my opinion, it's a more realistic scenario. Chances are, whether you want to build a Next.js or Remix or a good old React app, there will be already a template that contains the technology you want to use, as well as TypeScript configuration. So more often than not, your job will be to write a valid code instead of losing your sleep over correct configuration setup. For this course, I picked Vite, since it's one of the most popular build tools out there, but please keep in mind, as far as the TypeScript logic is concerned, it's the same if, for example, you're going to use Next.js with a TypeScript template. Now, we want to run one command in order to set up our template, and I'll show you two places where you can get the command. First option, you can navigate to Vite docs, which are located at vitejs.dev. Then click on getting started. Pretty much you're looking for this command, and then we just need to pick the template. And since my NPM version is bigger than 7, I'm going to run my command with the double dash. Now, as you can see, we have tons of templates available. And the idea is following. We go with npm create Vite latest, then the project name, then double dash, go with the template one, and pick the template. As you can see, we can go with React.js as a side note, something we're going to use in the part 2 and 3. We can also, for example, set up the view with TypeScript. And we're actually going to start the course with vanilla TypeScript template. So this is just going to be an application built with vanilla JavaScript. We're not going to use React. And to tell you honestly, we don't really care about the template. We just want to use it in order to learn TypeScript. So pretty much most of the first part of the course we'll spend in one file. And you'll see what I'm talking about in a second. Now, remember in the previous video, I mentioned the main course repo. Navigate over here and then look for TypeScript tutorial. And under this directory, look for README. And here you'll right away get the command. And as I know, this is something that I'm gonna copy in literally a few minutes. And I suggest actually doing the same, because in here, Again, you'll find all of the notes and challenges and all that cool stuff. So if you want to save yourself time on typing, just navigate over here and grab the command. Again, npm create vt at latest. Then, at least in my case, the project name is going to be TypeScript, then double dashes, then template, and we're going to go with vanilla ts. So let me grab the command. Let me navigate, I guess, to desktop, and I'm going to zoom in. Then let me set up my command. And once I have successfully installed the project on my machine, I want to open up my text editor, drag and drop the folder, and up next, we'll take a look at the files and folders available in this template. As far as the files and folders, we've got over here a public one. So this is where we can place the public assets. Then we have a source one. Essentially, this is where we'll do all of our work. A git ignore, where we specify which files are going to be ignored by the source control. Then index.html, which is actually going to be our homepage. Also a package JSON, something we're going to cover in more detail in a few minutes. And also a TS config, which we'll cover in greater detail later on in the course. And before we take a look at the specific files and cover the build step, here are a few things I want to do first. Since it's a Node application, we do want to install the dependencies. So effectively just open up the integrated terminal and run npm install. Now also, again, I highly suggest getting the README, since in my opinion, you will find it super useful as you're following along. So just navigate back to the project and somewhere create a README markdown one and just paste the contents over here. Save it. And once we install dependencies, now we also get the Node modules. So this is where all of our dependencies are located. Then we want to go with npm run dev, which is going to spin up our project in local development. And we're looking for localhost 5173. And this is what we should see on the screen. So essentially, there's some images over here, a text, as well as the counter. Now, if I'm being perfectly honest, like I mentioned previously, we really don't care about the actual vanilla JS application. I believe towards the end of the first part of the course, yes, we will build a tiny app, but most of our time we'll spend over here in the source one in one specific file called tutorial.ts, where effectively we will just learn all the TypeScript fundamentals. Now, if we take a look at the package JSON, we see that we have the dev one. This is the command we just invoked. And also there's a build one. Now, before we run build, I do want to create a file and showcase how our setup is going to look like. Now, one interesting thing that I do want to point out, notice how before the build command, they actually invoke TS and C. So notice how TypeScript is a dev dependency. So before the project is built, first it's compiled. So that's the step I mentioned previously, where we're going to write all of our code in the files with TS extension. And once we perform the build step, it's going to spit out the vanilla JavaScript code. So if we take a look at the index.html, like I said, this will be our homepage. So for example, if you want to change the title, it's definitely an option. Then they have over here this div with an ID of app. And effectively in a second, you'll see how in the main TS, they inject the images, the divs, and all that into this app one. So now let's navigate to the main TS. In here, they import the styles. Again, something we're not really concerned with. Also two images, the TypeScript one and vt one, and also a counter. And then they select div with an ID of app. And like I said, they dynamically inject the elements into the DOM. As you can see, there are some already sprinkles of TypeScript, and essentially this is something that we're gonna cover during the first part of the course. But most of the logic should look very familiar, correct? Because this is straight up JavaScript, again, with just sprinkles of TypeScript. Now, if we take a look at the counter, it's going to be same idea. This is straight up JavaScript with the only difference that now we're looking for element, and actually we specifically say that the type is going to be HTML button element. Now, how is our setup going to look like? Since I said that, I mean, we really don't care about this code. And to tell you honestly, we're not actually going to look too much in the browser either. Most of the time we'll spend in the editor. Well, in here, in the source, I want to create a new file. In my case, I'm going to call this tutorial TS. The name is totally up to you. Just make sure that you add the TS extension. So we're going to go over here with tutorial, then TS, we create a new file. And for now, I just want to log, just so I can see that everything works. And I'm going to go with TypeScript and then tutorial. Let me save it. And then in order for this code to run, we just want to navigate to main TS and we just want to import the file. That's it. We're not going to do anything else. We'll simply go with import. And now we're just looking for our TS file. So tutorial and TS. And the moment we do that, once we navigate to the browser, if everything is correct, we should see that console log. And if that's the case, we're in good shape. And before we move on to TypeScript fundamentals, let me show you the result of the build step. Again, let's just recall that before Vite, our build tool, builds the production ready application, it's actually going to compile our code, which essentially just means that all of the TypeScript elements we're going to have in our code are going to be transpiled to good old vanilla JavaScript. And essentially during this video, I just want to showcase that. So don't worry about the code I'm going to write. In fact, you don't have to follow along. I just want to showcase the end result. So let's say if we're going to add something TypeScripty, for example, interface, of course, something we're going to cover during the first part of the course. And I'm going to go with name string and ID number. And as a side note, essentially it's just a shape of an object. And then I'm going to create the object and I'm going to go with some value. So I'll add the type over here. And now I just need to provide name, which has to be a string now. So I'm just going to go to random and comma. And then we're going to go with ID and then 1, 2, 3. And then let's also log. So let's go with some object. So once we navigate right now to a terminal, we have a few options. If you want, you can always stop the dev server. And essentially you do that with Control-C, or you can just open up a new terminal window. And that is going to be my approach. So essentially now I want to go with npm and not dev, but we're actually looking for build. So we run this command. If we don't have any TypeScript errors, we're going to be successful. And now notice we have this dist folder. So this is our production ready application. We still have index.html. Okay. Everything is beautiful. And then in the assets, we'll have the index.js. So this is essentially our application in vanilla.js. And if we take a look at our code, so notice I have this console log TypeScript tutorial. So I clearly know that it's coming from our file. Notice there is no interface anymore. Again, there is some kind of minified object over here. And effectively, we also console log it. That's it. So there is no interface. There is no type string or type number, or in fact, any of the other stuff that we have here as far as the TypeScript elements. So again, essentially we'll write all of our logic in the files with DS or DSX extension if we're working with React. And then once we build our project, we're going to get back our good old vanilla JavaScript code, which essentially we can run anywhere. So hopefully it's clear what's happening during the build process. So now let me clean up our project. First, I want to remove the dist folder. Then also I'm going to remove my second terminal window. And at the very end, I just want to remove this code from tutorial. Yes. So this is going to be our starting point, where essentially we have console log in tutorial. Yes. And if we take a look at the browser, we should see over here TypeScript tutorial. And if you have the same result, now we can move on to the next task. Okay, and let's start our TypeScript journey by discussing type annotations, which allow us to specify the variable type. So let's say in my project, I have a variable by the name of awesome name. And if you have watched any of my courses and tutorials, you know that the most awesome name ever is shake and bake. Since I'm working in a TypeScript project, I can actually explicitly set up the type. And the syntax is following. We go with colon, and then since I want this to be a string, I type string. Now there are quite a few types, and I'm not going to list all of them. I really find it pointless. Essentially, the most straightforward ones are string, number, and Boolean. And again, the syntax is going to be the same. So we just go over here with the colon and then the type. And of course, as we're working through the course, we'll get to know the other types as well. And the moment I set this type for my variable, I get two things out of the box. Essentially, it can never be something else. So I cannot go to the next line and set it equal to a function. And also, I'll right away get the methods that are associated with this type. So in this case, it's going to be a string. So just to demonstrate that, if I go to the next line, and if I set it equal to a value of something, this is still valid. Why? Well, because type is string, so everything's correct. Also, I can go to next line and set it equal to awesome dot, and notice right away I get only the methods that are associated with the type string, which again is super awesome because essentially I avoid some unnecessary bugs. So in this case, I'm just going to go to uppercase. And now if I log this value, if I go with awesome name and take a look at my console, if everything is correct, it should be equal to a something. So we set it equal to different string value, and then we ran the to uppercase method. Now, one thing we cannot do is something like this, where I go with awesome name and set it equal to 20, which is a different type. So notice immediately TypeScript starts yelling at me. Type number is not assignable to a type string. And I want to repeat the same thing for the number as well as the Boolean. So just so it's clear, we're going to start with some kind of variable. In my case, I'm going to go with amount. I'll set it equal to a number. And again, I can do anything that's allowed with the numbers. For example, I can set equal amount 12 minus 1, something like that. But I cannot set amount equal to pence. That's not going to work. Right away, TypeScript is going to be super helpful. It's going to say, hey, listen, you said this is going to be the number. So yeah, you can run the number methods. You can do calculations, but you cannot just reassign it to something else. And lastly, let's take a look at the Boolean. Pretty much same deal. We're going to go with is awesome. We're going to add a colon, set up a Boolean type. For start, it's going to be true. Then we're going to set is awesome equal to false. And then let's try to set it equal to shake and bake. Again, the most awesome name ever. So we're going to go with is awesome. And let's go with shake and bake. Again, cannot do it because the type is Boolean. And essentially in the process, we're just avoiding this entire debacle. where initially it can be one value, then 3 lines later, it's something else, and then we're turning into a third thing and then start running some methods on it. Essentially, this is static. So now we say, hey, listen, this is going to be string and string only. Same goes for number, Boolean, and in the process, we just avoid a bunch of unnecessary bugs that come from typos, that come from just using wrong methods, and that sort of thing. And before we work on our first challenge, let me quickly mention something. TypeScript is actually really smart and can infer the type of the variable based on the values when it's defined. Now, the fancy name is type inference, but essentially for us, it just means that we can remove all of these type annotations and we'll still get all of the goodies that I covered in a previous video. So now if I hover over the awesome name, notice how based on the value when the variable was defined, TypeScript can nicely infer the type. So in this case, it's string, then it's the amount, and then when it comes to is awesome, TypeScript knows that it's a Boolean. Now, don't dismiss the type annotations. We're still going to use them, but most likely not for such straightforward variables. Type inference also has some gotchas, especially when we start working with more complex values. So yes, TypeScript is always going to try to help you when it comes to functions, when it comes to variables. It will try to kind of get the type based on the value. And obviously it's super awesome because it saves us time. Notice I don't have to go to every variable and just make sure that the type is set. But there are some gotchas we need to be aware of, and don't dismiss type annotations because we're still going to use them throughout the course. Just not for variables like this. Okay, and now it's time for our challenge. And since it's our first one, I will cover the steps as well. But with the future challenges, just so we can save a little bit of time, I will most likely right away start working on the solution. Also, since it's our first one, it's going to be extremely straightforward. I just wanted to get the ball rolling, just so we get used to this idea that we learn some stuff and then we work on some kind of challenge. So I want you to create a variable of type string and try to invoke a string method on it. Then the same is going to be with a number, create a variable and try to perform a math operation. Also, I want you to create the Boolean one and perform the logical operation. And then try to just assign some values to those variables that are different types. So just try to come up with something that shouldn't supposed to work and see whether TypeScript complains about it. Now, you can use the type annotation, or you can also use the type inference. That's totally up to you. Again, super straightforward challenge where I just want to navigate the tutorial. I want to come up with some kind of variable for my string. In my case, I will use the type annotation. Don't ask me why. Just think that it's going to be better in this case. So I'm going to go with hello and then let's go with TypeScript. Okay, beautiful. Then let's run the two uppercase. So greeting is equal to greeting dot, and then two uppercase. Let's invoke this. This should work. We should have no issues. And as long as I don't have the red squiggly lines, I'm good to go. So TypeScript is not yelling at me. Then also let me set up the age. So in this case, it's going to be a number. I'm going to set it equal to 25. Then let me add a 5 to it. Okay, also works. Everything is beautiful. And then we want to go with is adult. So that's my Boolean. Let's add a type annotation here. Age is, let's say, bigger or equal to 18. Now this should be true. And you know what? This is the case where I will log it. So let's see, is adult is true? Yep, that's the one. So now let me just set it equal to the opposite. I'm going to go with is adult is equal to opposite is adult. Again, let's log it, and now it's going to be false. And then somewhere here, let me just try to set the greeting equal to 10. That shouldn't work. Also, we can go with age and set it equal to 30. So string, again, we're going to get the error. And lastly, we have the is adult, and I'm just going to set it equal to yes. And as you can see, all of them result in errors. So again, we have one type, and TypeScript is not happy when we just randomly decide that our variable is going to be of different type. All right, and before we continue with the tutorial, let me show you something interesting about the setup. You see, even though we have these TypeScript errors over here, we're going to be able to run our project locally. So what am I talking about? Well, if I go here and set up the console and log, and in my case, I'm just going to look for all three values. So greeting, age, and is adult. If we navigate to a console, you can see, first of all, that all of the variables have the values that they're not supposed to. So TypeScript is complaining, but it still works. And also notice how our project didn't crash. We're just getting these TypeScript errors, correct? So here's the deal. When we're working with TypeScript, actually, project is going to work even with the errors locally. But whenever we want to host the project, what do we need to do? Well, we need to build it. That's usually the setup. And in order to build it, we'll have to pass the TypeScript checks. So if we try to build with TypeScript errors, we're going to fail. And as a result, we won't be able to host the project. Let me show you the package.json. Notice over here. So we have dev command, which essentially just spins up the dev server. And we also have the build command. And remember, before we even run feed build, we actually compile this with TypeScript. And again, if we have some errors, we won't get the, I believe it was this folder, where we have the static assets, which in turn are going to be used to host our project. So let me showcase that just so we are on the same page. First, I want to stop the dev server. Let me run npm run build. So at the moment, I have the errors, TypeScript errors, and immediately I just get back these error messages in my console. So in order to fix it, what do we need to do? Well, in this case, it's sort of simple where I can just comment them out, delete them, whatever. Doesn't really matter. Again, let me clear everything here. Let me run the last one, npm run build. And now, since I don't have any TypeScript errors, notice I have this folder. And this is where I have my production ready application. So again, locally, even with TypeScript errors, you'll be able to run the project. However, you'll have some issues once it's time to deploy it, once it's time to build the production ready application. And up next, let me introduce you to a union type, which allows a variable to hold a value of multiple distinct types. For now, we're just going to take a look at some basic examples, but since union types are super powerful, it's not the only time you'll see them in the course. So once we start working with functions, arrays, and all that, yep, we're going to use the union type as well. So let's imagine I have a variable by the name of tax, and typically it's a number, correct? So I can set it equal to 10. TypeScript can nicely infer the type, and I'm good to go. But let's imagine that whether I'm getting it from the API or whether user provides that value, it can also be a string. I can go here, set up my colon, then go with number. So it will definitely be a number. And I can use this pipe operator. And then I can just add another type, which in my case is going to be string. Now, please keep in mind, you can add 10 another types. But I mean, in our case, we're just going to stick with 2. But yeah, you can go here and add, for example, Boolean. It's definitely an option. So now I can go to a next line and I can set it equal to 100, and TypeScript is not going to complain because yeah, one of the types is actually a number. Now I can also go here and set it equal to a string. And in my case, I'm going to go with, let's go with $10 over here. So both of them are valid because now I have union type where it can be either a number or a string. Now, once we start working with more complex examples, yes, we'll have to do some checks and all that. So all of that is coming up, but this is a super powerful concept where essentially we can say to TypeScript, hey, this is going to be either this or it's going to be the another type. Now, also something that I was blown away is the fact that we can set up the literal value type. So that's the fancy name. Essentially, it just means that I can provide the literal values. Let's imagine we have a request status. So that's my variable. Now, what are the typical values for the request status? Well, quite often it's pending, success, and error. So for starters, I can just go here with pending. So that will be my initial value. Then go with a colon. And now I can just provide the potential string values, which are going to be pending. Then again, I use the pipe operator. I provide success, then another pipe, and I'm going to go with error. And what's super, super cool is the fact that whenever I work with this request status, notice I right away get these suggestions. So it can either be error, pending, or success. And again, it helps me to avoid errors because it's way harder to mistype something. And also, I kind of just go here and say random. I mean, first of all, it doesn't match my suggestions. And second, right away, TypeScript is going to complain. So I don't have to find out about this bug in the runtime. I actually can see it right away as I'm building the project. So let me go here with success. Error is going to work. So there's nothing wrong with that. But if I'll try to set it equal to random, as you just saw, I mean, TypeScript is not going to be happy about it. Topic we're going to come back to when we set up more complex examples. And again, union types allow us to set up multiple types for the same variable. And while we're still on a roll, let's also cover type any, which allows us to opt out of the type checking. So I'm going to create a variable and I'm going to name it not sure. So not sure. Now I will set it equal to 4. And since we already covered that TypeScript can infer the type, we'll see over here this number. But I can also go with colon and set up any over here. Now any means exactly what the name implies. This can be anything. I can set it up equal to function, string, Boolean, whatever. So in the next line, I can say, you know what, not sure is actually going to be a string, maybe a string instead. Then on the next line, I can set it equal to false. And as you can see, TypeScript is not complaining. Now, as you're looking at it, probably the first thought is, well, wait a minute, that's how variables behave in JavaScript, and you're absolutely correct. Now, as with everything in programming, there's a bunch of fights over it, whether you should use any at all. As far as my 2 cents, be very careful when you introduce any to your application, because it can spread like wildfire. So you started off with setting up one variable, type any, and then next thing you know, you have any all over your application, because, for example, when you return any from the function, then the result is any, and on and on and on and on. So definitely have a good reason why you want to use any. And as I note, any is something you'll see quite often when TypeScript is trying to come up with a type, but we haven't provided any clues. For example, if I'm just going to go with some random and I'm not gonna set up the value. As you hover over it, notice now this is going to be type any. So this is something we quite often get by default when TypeScript is trying to get the type, but I mean, I haven't provided any clues what this value is going to be. And this is essentially something that we'll constantly try to fix, where, for example, for functions, implicitly it starts with any, but we don't want it to be any. We want it to be some kind of type. So just be careful when you use it. It's definitely an option. It's useful if, let's say, you want to test something. It's also useful if you have a pretty big code base and you just slowly want to introduce TypeScript. So you still want to run the project, but you slowly want to add it to your project. Yeah, it's definitely the case. Just, again, be very mindful when you set something any, because next thing you know, it half of the application is going to be any. And then at that point, I mean, it kind of loses the sense to use the TypeScript in the first place. Again, those are just my 2 cents. If you go to Google, you'll find definitely way stronger opinions, but let's just leave it at that and let's move on to the next topic. And next, let's see a practical application of type annotation, where essentially I have a list of books. So I just have some strings over here. And I also have a variable, which at the moment is undefined and there's no type, since, again, I want to showcase what type is going to be set by default. And I want to set up a loop where I iterate over, and then if it matches one of these titles over here, then I'll set the variable found book equal to that title. So first, let's set up the loop. I'm going to go with for off loop. So let book of books. Then we're going to set up the condition. So if book, and I think I'm going to go with the first string over here. So I'm going to go with 1984. If that's the case, then found book is going to be equal to a book. And we're also going to break out. So let's add the break keyword. Let's save it. If everything is correct, this should be equal to a title. So we can nicely go with log and then found book. Let's take a look at the console. Yep, we are good to go. Now, everything's awesome, but let's take a look at the type we have over here. By default, it's actually set to any, which leads to problems because anywhere, whether that is in the loop or over here, I can do something like this. I can set it actually equal to 10. So TypeScript is not stopping me. And this is the behavior which I don't want, because I actually want this to be a string. Otherwise, yeah, in here it's going to be a string if I'm successful inside of this loop. But then eventually it might turn into a function. Again, good old JavaScript variable behavior, but I don't want this. I want this to be a TypeScript project where I explicitly know what is the type. So what's the solution? Well, we can navigate back over here and we can set it equal to a string. But now we have another problem. So let me remove these console logs. How do we know that for sure it's going to be a string? Because keep in mind, this runs when? At runtime. So if, let's say, I set it equal to 1983, well, this found book is not going to be equal to a book. What is it going to be equal to? Well, remember, by default, variables are what? Undefined. So if you'll try to set up some kind of logic over here, assuming that it's a string, TypeScript is going to yell at you. It's going to say, hey, listen, you are using it before there's even any kind of value, because again, TypeScript is not going to check whether at runtime this will be equal to a book. So yeah, we can set up the logic over here where I can say, if for sure the found book is equal to a book, TypeScript knows that actually these are strings, so we can run the method on it. For example, again, let's go with length. So this is going to work, but we cannot do it outside of the loop, because in here, there's no guarantee that actually this will be a string. So we need to set up the union type, where I'm going to go with, okay, it potentially could be a string, but by default, actually, it is undefined. So it's another type that we can use. So now by default, it's going to be undefined. If we're successful, it's going to be equal to a string. And what's super, super, super awesome is the fact that TypeScript is going to be extremely helpful. Where if you try to, again, go with the good old length, notice how it will immediately add this optional chaining. Why? Well, because it can be undefined, and we can see that if we take a look at the error message. If you just add a dot, notice found book possibly can be undefined, and therefore TypeScript is going to add that optional chaining. So now we only run this length if it's actually equal to a string, if we have some kind of value. So if we won't be able to find a book, which is the current case, then this actually won't trigger the runtime error. Now, if we're successful, then we'll be able to nicely see the length of the book. You know what? I will change this one around. I'm just going to go here to found book and set it equal to uppercase. Let me do it this way. So we're going for uppercase. Let's invoke that. And then this one, I'll just log it. Again, it really depends whether we're able to find the book or no. So now let me move this found book, set it up here in my console, and let's see what is going to be the result. So I'm going to navigate over here. If everything is correct, I'm going to get my 4. If I'm not successful, then essentially it's just going to be undefined. But I won't have that runtime error where I'm trying to access the property on undefined. Hopefully that is clear. Okay, and before we move on to the next topic, let's work on a small union type challenge where first we want to create the order status, and in there we'll set up the literal types, and also we want to set up the discount, which can be a number or string type. And you know what? Just because I like to break the rules, I'm going to start with the second one. Doesn't really matter. I'm going to go with number or string. By default, I'll set it equal to 20 or any other number value. And I also want to test it whether I can set it equal to 20%. Now this works, but if I'll try to set up discount equal to true, essentially a Boolean, TypeScript will yell at me, which is exactly what we expected. And also let's set up that order status. So order status variable by default is going to be equal to processing, but we want to set up those literal types. So this variable can be only one of these values. So we're going to start with processing, then we'll set up our pipe, and we're going to go with shipped. And also we want to add delivered over here. So now we can go to the next line, set it equal to one of these ones, and everything is going to work. But if I'll try to set it equal to canceled, again, TypeScript will yell at me. So let me just set this one up quickly, where if we go with order status, I just decide that I'm going to pass this value over here. I'm not going to be successful since I can see this red squiggly line. Let me comment this one out. We're done with the challenge. And up next, we're going to discuss arrays in TypeScript. And as far as the arrays in TypeScript, the general idea is following. Let's say I have prices array, and it's all numbers. So we're going to go over here with 100, 75, and then 42. If I want to set up the type, which is something I want to do, again, same deal. We go with colon, then we go with type, in this case, number, and then we set up the square brackets. So now I'm essentially telling TypeScript that this array will only have numbers. So if I add a number 34, everything is fine. If I'll try to stick hello, I'm going to get the error because this one is type string. And I explicitly told TypeScript that this is actually going to be an array of numbers. And the same is going to work if I will try to invoke push. So if I'll try to add the item, number is fine, string will cause the error. So let me comment this one out. The same works with string array. Let's say we have fruit, and this is going to be equal to apple and orange. We want to set up the type over here. In this case, it's going to be a string, and the same rules apply. If we'll try to add the item that doesn't match the type, we'll get the red squiggly line. Now be careful with the empty square brackets. So if we go here and just come up with random values and set it equal to empty square brackets. So if we won't provide the type over here, TypeScript just assumes that this will always be an empty array. So if I set it equal to my array and start adding items, TypeScript will immediately complain. And notice as we hover, it says, well, type string is not assignable to an empty array. So be careful with this one. I know it's tempting. Also be careful when you don't explicitly set up the type. So if I were to create an empty values array, TypeScript will get the type, but check it out. Now the type is any. So just like before, we'll run into those issues because now we can change these values any way we want. So we can take the string, then it turns into a number, and same deal. So be careful. Yes, TypeScript will infer the type, but most likely you don't want to set it equal to any. So this is the case where we want to create the empty array, but we explicitly want to say, yeah, this is going to be type number or string or Boolean or whatever. Now, also, while we're still on a subject of TypeScript inferring the type, let's take a look at this example. Let's say I have the names array and I add over here Peter and Susan. So if we hover over the names, everything is correct. TypeScript sees that we have over here a list of strings, and it correctly says the type for this array is string. But here's the gotcha. Since TypeScript is inferring those values based on what we have over here in the array, it doesn't stop me from doing this. And now if we hover over it, we can see that actually we have this union type. Like I said, we'll be coming back to this topic. And now we have string or number. So essentially now I can add numbers as well. Therefore, be careful when you're relying 100% on TypeScript to set the type. It's not going to stop you from adding different values to the particular array. And in that case, well, the type also is going to change. Now we can explicitly set up the array to be one or the other type. So I can go with array, for example, and I can say that, you know what, this array is going to have either string or a Boolean. Again, we still set up the square brackets over here, and we set it equal to an array where we set up those two values. So we can go with apple, then true, which is a Boolean, then the same deal, orange, and let's set the false one over here. And with this in place, we can start working on our next challenge. Okay, and once we're familiar with arrays, now let's work on a tiny challenge where we want to set up the temperatures array, which will be type number, and colors, which is going to be type string, and then we also want to set up the mixed array. So let's start with temperatures, essentially our array of numbers. Now this one probably going to be the hardest as far as the spelling. Yep, notice over here. Let me fix that one. Okay, good. That took a while. Then I want to set up my type number, and we're gonna set up 20, then 25, and then 30. And let's try to push, I don't know, a string of hot. So let's access, then go with push, and let's try to pass in a string, and we won't be successful. So we can nicely comment this one out. After that, we have colors one. So this will be actually type of string. And in here, we're going to go with red, green, and blue. Let's save it and let's try to add a Boolean. Why not? So colors here, dot, then push, and we're looking for a Boolean value, which is not allowed. And then let's set up the mixed one. So we're gonna go with the variable. In this case, I'm gonna call this mixed array. And this one will be either a number or a string. So number, pipe, and we set up a string. So let's set it equal to our array. And in here, you know what? Just to make it interesting, why don't we try to add true? So Boolean. And notice right away, I'll have my error. So let's go with 1, then 2, and then we want to add 3. And with this in place, we can move on to the next topic. And up next, let's discuss objects in TypeScript. In order to do that, I'm going to create a car. And here, I'm going to set up the brand. That one will be equal to a, let's say, Toyota. And also, I'll set up the year. So first, let me set up the string over here. And then let's go with year, and we'll set that one equal to a number. And if we want to set up the type annotation, it might look a little funky, but we want to do it this way. Where again, we go with colon, then we go with curly braces, and then one by one, we set up those properties over here. So I have a brand. Now, what is the type? Well, it's going to be string. Then also, I have a year. And what is that one? Well, that's a number. So again, either if I try to add some property manually here, where I'm setting up the object, or for example, if I do it dynamically by going car dot and then the property value, unless this property is in the type annotation, it's not going to work. I think I'm just going to use the color example. So let's say I'll set up the color and it's going to be equal to blue. Notice right away I have the complaint because the property is not in my type annotation. And the same goes if I go with car and brand. Yeah, I can set it equal to Ford since that's the correct type. But again, if I go with car and color, it's not gonna fly. So TypeScript will immediately complain. Now, if you're looking at it and you're thinking to yourself, well, boy, this is super clunky over here. I have this object and then actually this is going to be my type annotation. Don't worry, this is just essentially the most basic setup, but I wanted to cover it since I wanted you to understand how everything works under the hood. But eventually we will cover something called type aliases, where we'll nicely be able to set up this shape somewhere separately and effectively just reuse the variable. So again, you won't have this clunky code. Most likely you won't use it, but I definitely wanted you to kind of see this type of syntax. So now once I have my first car, well, I can create another one. In this case, it's going to be a car1 since I'm already using the car variable. And then I'm gonna go with a different brand. And also I'll change the year. And I don't think it's necessary for me to repeat all of the steps. Hopefully it's clear. Whatever we set up in this type annotation needs to match what we have in the object. Otherwise, TypeScript is not going to allow us to compile essentially our code. And now let's tie two things together. I want to tie the arrays with the objects. And in the process, we'll also cover how we have read only option with the TypeScript, as well as the optional properties. So first, I want to create three objects. I want to create book, pen, and notebook. And I want to add them to the items array, which by default is going to be, let's say, empty, but we'll set up the types in a second. So first, let's just go with items. I'm not going to place anything inside of it. And then let's create those three variables. So in here, we're looking for a book. It's going to have two things. We're going to go with title. We'll set it equal to book. and we'll also have cost. Okay, I'll set it equal to 20, and then I'll change this one around to pen. Okay, and the cost, I mean, again, totally irrelevant. I'm gonna set it equal to 10, I guess. And then I want to go with notebook, but for notebook, I actually want to remove the cost. And like I said, now I want to store all of these three values over here in the items. But here's the kicker though. I do want to make sure that all of them have the same shape. Now, as we're looking at it, we can clearly see that it's not the case with the notebook, but let's imagine that we don't know that. And at this point, we have two options. We can either repeat the same steps like we did for the car. So effectively, I can just set up this type annotation for all three of them, one by one. Or since I have an array, and I can also set up the type for array, I can do it in one place where I have the items. So far we know that we can set up the array to be equal to a string or a number or a boolean, correct? And we also cover the type union. But we can also do something like this, where I can say, yeah, this is going to be an array of objects, and that each object needs to have this particular shape. Now, what is going to be the shape? I'll say title is equal to a string, or I'm sorry, I don't know why I'm placing this in the quotation marks. And then also I want to set up a cost. So we're going to go with cost, and we'll set it equal to a number. And now one by one, as I'm adding these items to my array, once I get to a notebook, check it out. Now TypeScript is like, hey, listen, this notebook that you're adding, well, notice it only has the string. It doesn't have the cost. So whatever type you set up over here, well, it doesn't match. So again, super useful, where instead of setting them one by one, if we have an array, we can set it in one place because we also can set up types for array. Now, what is the solution? Well, technically we can go back and add cost over here, but we also have this option of adding optional properties. Now, please keep in mind, you can use the same optional property over here as well when you're setting up the type annotation for an object. I'm just doing it here in the array since this is where we're currently working. Hopefully that is clear. And now I don't have the error because when I set up the cost to be optional, well, it could be there or it potentially could be missing, which is the case for a notebook. And what's also really interesting is that with TypeScript, we can set up the properties to be read only. Again, same deal. Of course, we can set it up over here. But in my case, I'm going to do that for the title, where right before I set up my property, I'm going to go with read only. So now if I go with items and I access, let's say the first one here, and if I try to overwrite the value, so dot title is equal to a new book, for example, it's not going to fly. So now TypeScript is immediately complaining that, hey, listen, title is read only, so you cannot change this value over here. So let me comment this one out. This concludes the object fundamentals in TypeScript. And now we can start working on the next challenge. So now let's work on the objects challenge, where we want to set up the bike. We want to set up the laptop. Then we'll create some products and we're going to store it in the array. So let's start with our bike. That will be my object. Let me come up with some kind of values over here. Then we also want to add the year. And now let's set up our type annotation. So we're going to go with colon, then brand will be equal to string. And also we'll have the year and we'll set it equal to a number. That should do it. Now we just want to change it to a laptop. So let me copy this one, change the name, then brand stays, year stays. We're just going to add a different string value. In this case, it's going to be Dell, and we'll also change the year. And now let's see some errors. So if I'm going to go with bike and year and set it equal to old, it's not going to fly. Why? Well, because year is set to be equal to type number. And the same is going to work if I'm going to create a second laptop. So I'm going to go with laptop 2. And it's only going to have a brand. So we're not going to have the year. So if I'm going to set it like this, notice we get our red squiggly, which means that there's some kind of error. And now let's set up those products. So we're going to go with product 1. That one is equal to title. Let's go with shirt. And let's set up the price. That one will be equal to a 20. Then let's copy and paste. We're going to go with 2. This one will be equal to a pants one. Why not? Pants are awesome. Now we don't want the price, so we will need to set this one up as optional. And let's create the product array. Let's right away set up our type. By the way, this was supposed to be square brackets. We want to go here with title. That one is equal to a string. And then also we want to go with price. This one will be optional and we'll set it equal to a number. So now in the array, we can nicely store product 1 and product number 2. Now it looks like TypeScript is complaining. Why? Well, because I forgot the square brackets. And at the very end, let me just showcase something interesting. Where if I go with products and then push, provide the object, set up a title here. In my case, I'm going to go with shoes. Even though price is optional, we still need to provide the correct type. So let's say if I don't provide anything, notice how TypeScript is not complaining. Effectively, this is optional, the price one. Now, if I do provide the price, it has to be a number. So if I go here with price and set it equal to a string, TypeScript will immediately complain. Yes, it's optional, but if I do decide to pass the value, the type needs to match whatever I have here in the type annotation. Beautiful. We have finally arrived at the functions in TypeScript, and I'm super excited to cover this topic for a few reasons. First, our examples are going to get more complex because we'll start tying together all of the concepts we covered previously. And also, once we start working with functions, we absolutely have to start using TypeScript, and you'll see what I mean in a second. So let's say I have a function of say hi. Why not? Let's set it up, say hi. For now, we're not going to pass any parameters, and as far as the functional logic, we'll just leave it empty. Now, say hi is looking for what? Well, probably some kind of name, correct? And in a function body, we can nicely log it. So the moment I type over here any parameter, in my case name, notice right away I'm getting these red squiggly lines. And this is what I'm talking about. At this point, we absolutely have to start using TypeScript. Otherwise, TypeScript won't compile our code. So if we hover over, we notice parameter name implicitly has any type. And essentially, TypeScript complains about it. So that's not allowed. Yes, by default, implicitly, it sets it up as any, but we need to fix it in order for TypeScript to compile our code. And at this point, essentially, we have 3 options. First, we could set type any ourselves. That's definitely one option. Also, and you know what? Let me just comment this one out. Also, we can navigate to tsconfig, and we can actually change the configuration, something I'm going to showcase in a second. Or the best scenario is for us to actually set this one up with a proper type annotation. So in this case, I'm looking for a string, most likely. So I'm going to say type. Okay, so let's try it out here with any. What's the issue here? Well, just like we covered before, any is anything. So everything that we can do in JavaScript pretty much will be able to do with the name here. And actually, I believe in 2 videos, I'll showcase the any gotcha that we need to be aware of. So this is not going to be approach. Yes, technically you can do it, but I mean, at this point, we kind of lose the benefits of TypeScript. Now, second option, we can navigate over here to the package JSON, or I'm sorry, why am I going to package JSON? We're going to tsconfig. And notice over here, this strict rule, technically, we can change it around. I can set it equal to false. And at that point, TypeScript won't complain about the fact that parameter by default is left as any. So you can definitely try it out. You can set it equal to false, and you'll see that actually code works. Everything's fine. But in my case, I'm going to skip that. I'm just letting you know that technically this is an option. So we have finally arrived at the option we're going to use, and that is setting name explicitly to the type we're going to use. And just like before, we simply want to go with colon, and we want to come up with the type. In my case, that is going to be string. And again, I know you're probably sick of this method, but I'm just going to use two uppercase. Essentially, I want to set up over here a log. Then I'm going to go with template string, and we're going to go with hello there over here. And now I'm going to access the name. So the moment here we set up a proper type, let's say string, number, or whatever, two things are going to happen. First, when we call this function, every time we'll pass in a wrong type, TypeScript is going to yell at us. And second, within this function body, we can only perform functionality that is allowed on this specific type. So in here, yes, let's go to uppercase, let's invoke it, and let's try invoking say hi. And let's say I'm going to pass in John, and also in the next line, I'm going to pass in 3. So if everything is correct, we should get an error over here. We can nicely see that we can only grab the string methods inside of the function body. And if we inspect the console, we should see John over there. And lastly, if we try to pass more parameters than what we have specified, we'll also get an error and TypeScript won't compile our code. And with this in place, now we can move on to the next topic. Okay, and up next, let's talk about function returns. So first I'm going to create a function, and I'm going to call this calculate discount. Discount over here. It's going to be looking for price, and I know that the type is going to be number. For now, inside of the function body, I simply want to go with the return, and we're going to go with price. Again, since this is a number, once I press dot, notice I'm only getting the methods that are associated with the type number. And if you're sick of me hearing this, I'm sorry, but I'm going to keep on repeating that because, again, I find this truly helpful. And let's say I'm going to multiply this by 0.9. So I'm going to go over here, 0.9, okay, good. And then I'm going to set up a variable. So I'm going to go with const final price. And I'm going to set it equal to calculate discount. I'm going to pass in 200. And I don't think I need to log the value. I don't think it's necessary. So if I hover over the final price, I can see that it's a number. Now, why is that a case? Because, again, TypeScript is inferring the type. TypeScript says, okay, so this is a number here. We're returning a number multiplied by something. So whenever we hover over this calculate discount, we can nicely see another set of colon and a number over there. And I know that it might look a little funky over here, but yes, essentially the syntax is following. In order for us to set up the type for the function return, we need to go after parentheses, we need to set up the colon, and then we explicitly need to go with the type. Now, again, you can make a case, well, why do we need to set up the type if TypeScript is already inferring the type? Well, for essentially two reasons. First of all, if I set up over here a number type explicitly, as I'm working in this function, if for some reason I forget to set up the return, or if I set up a return which doesn't match what TypeScript is expecting, well, I'm going to get an error. So it's going to be super helpful. Let's imagine this. I have some kind of has discount variable over here. And I'm going to just set up has discount. So essentially some kind of condition. And in here, instead of returning a number, I'm going to go with discount and applied. Notice right away, TypeScript is complaining. Type string is not assignable to type number. As we're working in the function, TypeScript is kind of watching over us. And if I return something that I'm not expecting, well, essentially TypeScript just starts yelling at me. Because again, yeah, it's trying to infer the type. But once I remove my logic, well, essentially now it could be a string or it could be also a number, correct? So now if we hover over this, notice we either have a number or it's going to be discount applied. And the same goes over here. Either it returns a number or discount applied. So even though it's technically optional, it's a good practice to set up the return types explicitly, since it helps us tremendously as we're setting up the functionality. So now let me comment this one out, and I'm just going to go with price, like so. And with this in place, now we can move on to the next topic. And next, I just want to show you why we want to be careful with type any. But this is one of those videos where you don't have to type along if you're not interested. Essentially, you can just sit back and relax. So let's imagine I have a function and the name is add3. So it's looking for one parameter, which is a number. And don't ask me why, but I'm just going to set it equal to any. So I'm not sure what would be the use case, but let's just go with it. Then inside of the function body, I'm going to create another number. In this case, type will be a number. So I'm going to be explicit. And then as far as the return, let's just go with the return number plus another number. Why not? And then let's set up two variables. One is going to be result, and then we'll also set up some value. So let's try it out. I'm going to go over here with result. That one is equal to add3. So as far as the value, you know what? Let me just pass in 3. So 3 plus 3. And then also we want to set up some value. So that one will be equal to a result. So now, Mildar question. And no, I'm not asking what is going to be the result. I'm more interested, well, what is going to be the type? So if we hover over some value, notice something interesting. How essentially it's any. And what that means, well, go with some value and my method. And technically it's going to be valid as I'm typing the code, but hopefully it's clear that it will lead to some errors since there is no method, my method. And as you can see, everything starts with this innocent any. And notice how it trickles down. So we pass number, that is type any. And even though this is a number, and technically this is a math operation, TypeScript should infer that we're returning a number. However, if we hover over, notice over here, we're expecting any, we are returning any. So result is any, then some value is any. And as I mentioned before, be careful when you introduce any, because it can slowly trickle down or spread like wildfire, whichever term you want to use. And next thing you know it, you're going to be unintentionally or intentionally running some methods or setting up some kind of functionality, which doesn't make sense. And at that point, you'll again need to start chasing those bugs at runtime, not as you're writing the application. So now if I navigate to the browser, notice over here, some value that my method is not a function. An error, which we can expect since there is no such method on some value. And with this in place, now we can work on our next challenge. Beautiful. And once we're familiar with the fundamentals, let's work on our next challenge. And you know what? I actually changed my mind. I will list out the steps for a few reasons. First, the challenges are getting more complex, and also I want everyone to be on the same page. Let's say someone is not reading the README, we're utilizing the README. I still want them to kind of have an idea what I'm trying to build. So effectively, I want to create the array of names, and then I want to write a function that checks the name, whether it's in the array. So this function should take name as parameter, and it should return a Boolean, whether the name is in the array or not. And then we want to set up one or a few checks and essentially just test out some names. So let me go to my file. First, I want to come up with a value, and I'm going to say that it's going to be an array of strings. And let's just provide some random values. So I'm going to go here with John. Then I also want to go with Jane. Let's set up Jim. And also we'll place a Jill over there. I don't know why I set all of them starting with J. Must have been a bad day in the office or something like that. Then let's come up with our function. So in my case, I'm going to go with isName in list. And this function is going to be looking for a parameter. The type is going to be string. And I'll right away set up that I want to return from this function a Boolean. So whether the name is in the array or not. And therefore, I'm going to set up my type over here. And then right away, let's set up the return. I'm going to go with names. So that's the array. And I'm just going to use the includes method. And in here, I'll pass in the name. So I pass the string over here, and then I pass the same one into includes. And essentially, this is just going to return true or false. Then let me set up a variable name to check. Now, technically, I mean, we don't have to do it. We can just pass it in, but you know what? Just to make things more interesting, I'm going to go with name to check. In this case, you know what? I will rely on the fact that TypeScript will infer this type. So let me type over here Jane, and let me set up if and else. So I'm going to go with isName in a list, and I'm going to pass in name to check. If that's the case, I'll have one log. If not, I'll have something else. So now let's set up those logs. So in here, we're looking for a name to check, whatever it might be. So now let me access this as a variable. So name to check, and then let's say in the list. And now pretty much let me just take the same console log and add not in the list. Okay, good. And now let me save the file. Let me navigate to the browser. And if everything is correct, Jane is in the list. So if I'm going to set it up over here, a value of Peter, now it's going to say Peter is not on the list. And with this in place, we're done with the challenge. And we're ready to move on to our next topic. Up next, let's discuss optional and default parameters in functions. Essentially, how we set them up from the TypeScript perspective. I'm going to start by creating a function calculate price. It's going to look for two variables, price, which is going to be number. And for now, I'll set discount as a normal parameter. So I'm not going to set it as default or optional. So let me go with discount. Let me set it up as number. Then inside of the function body, I'm going to go with return. And we're going to look for price minus the discount. Okay, good. Makes sense. I mean, if we want, we can set up over here a number as a return as well. That's definitely an option. And then let's go with price after discount. And that one will be equal to calculate price. And I'm going to pass in some even numbers just so we don't need to log it. So essentially, I pass in 100 as a price, then 20 as a discount, and then the result should be 80. All right. But what if I want to make this one optional? What if sometimes I'm going to provide the value and sometimes, well, it's not going to be available. Well, the syntax is following. We want to go to the parameter and we need to add the question mark. But notice right away, TypeScript is complaining. And the reason for that is because possibly discount can be undefined. And in our case, we already have a math operation where we take the price and then we subtract the discount. But if this is undefined, I mean, it doesn't make sense. So the key thing to remember about optional parameters is that a function with optional parameters must work when they're not supplied. And as far as the fix, well, we just need to provide the fallback value. So if this is undefined, the discount one, well, then we'll have some kind of number value. And the way we do that, we just set up the OR operator. And in this case, I'm going to go with 0. That's how we can work with optional parameters in TypeScript. And while we're still on the topic, let's also discuss the default parameter. Now, for this one, I think I'm going to create another function. Why not? Let's just keep on practicing. This one is not going to be calculate the price, though. We're going to go with calculate score. We're going to pass in the initial score, which will be a number. And also, we're going to go with penalty points. And same deal. For now, we're just going to set it that it's actually a number. I mean, it will be a number, but we'll just set it as a default eventually. Now, as far as the return, again, same deal. We're going to set it equal to a number. And when it comes to logic, we want to go with the return initial score minus the penalty points. And once I have the function in place, now let me set up 2 variables. So we're looking for score after penalty. And I'll provide over here calculate score. And again, I'm going to go with some even values. So I'm going to go with 120. And now I want to set up another variable. Oh, in this case, I'm going to go with without penalty. And I'll just provide the first one. So that will be my initial score. And notice right away, TypeScript is going to complain. So here's the deal. If we set up a parameter and we don't provide it, or we provide one too many, well, then TypeScript will complain. So this is something to keep in mind. And how we can fix it? Well, we can either go back to this optional parameter, which we discussed in the previous video, or we provide some default for this one. So we make penalty points as a default parameter. And the way we do that, just like with JavaScript, we just add the equal sign over here and come up with the value. So in my case, it's going to be 0. So now, if it's provided, awesome. We're going to use the penalty points value. If not, well, then we'll just revert back to the 0 because that one is the default one. And here's the key difference. If we use optional parameter, we do need to set up this logic. If we have a default one, it's not the case. Then we'll just use whatever value is provided. Okay, and up next, let's discuss how we can work with REST parameter in TypeScript. And also, let me showcase one more time how smart the TypeScript is. Let's say we have a function and the name is going to be sum. Now, for now, I'm not going to pass any parameters. I'm not going to set up any return type. Simply want to have my function, and I'm just going to invoke it and show you what arguments I'm going to provide. So this one will be equal to result, and in here I just invoke the sum, and effectively in here I want to provide 2 arguments. So I want to provide a string and a list of numbers. So string is going to say, well, the total is, and then whatever numbers I provide, they're going to be added together, and that will be my sum. So in here, let me go with the string, and let's say total is, then we're going to go with the colon, and then we have a list of parameters. So this is where we'll need to implement the REST parameter. Otherwise, I mean, one case I might add 5 numbers. In the next instance, it might be only 3. And hopefully you see where I'm going with this. So it's not always going to be 1 or 2 numbers. It's going to be a list of numbers. So in this case, I'm going to go with 1, 2, 3, 4, and 5. Now, TypeScript is complaining since we haven't set up those parameters over here. So let's start with a message. In this case, it's going to be a string. And now let's see how we can work with such a list. And essentially, the syntax is similar to JavaScript. The only difference is that we need to provide, well, what type of array it's going to be. So in JavaScript, we use this syntax, 3 dots. Then we come up with a name. In this case, I'm going to go with numbers over here. And this is the rest parameter. And essentially, JavaScript treats this as an array. So in here, we want to go with number, because I need to let TypeScript know what kind of type it is, and then the array. Now, please keep in mind, if you have strings here as well, essentially, you just go with number, then use the type union, and essentially set up a string there as well. And now pretty much all of the arguments that are past the string are going to be collected in this numbers array. Now, I also right away want to set up what are we returning from this function. And essentially, it's going to be a string. Now, before we set up the logic, which we're going to do with reduce, I also want to showcase how smart TypeScript is. So I'm just going to create the doubled variable, and I'm going to set it equal to numbers. So that's my array. Then let's invoke map. Then we're going to go with num, and let's just return num times 2. And again, let me just log, I guess, here, just so we can see that the functionality works. But what I want to showcase, though, is this. Notice as we hover over, TypeScript immediately knows that it's a number. So let's say you have some kind of callback function that you pass into the map, into the reduce and all that. TypeScript is going to see what kind of type array it is if you have supplied those values. And it will immediately know that as we're iterating over, this is a number. Now you can explicitly provide the value. I mean, no one is stopping you to go here and say number, but in general, TypeScript is super helpful. And we also have right away this useful error where the type should be string as far as my return. But at the moment, well, I'm not returning anything. So let me set up that functionality as well. And this is the case where I will use the reduce, and then I'm just going to return the message, the total is, and then I'll sum up the values. So I'm going to go with let total is equal to numbers. Then let's provide reduce over here. I mean, we can call this accumulator and total or current, however you want to do it. In my case, I think I'm going to go with previous over here and the current one. And then as far as the logic side of the function, let's just return previous plus and then the current one. And the same deal. TypeScript knows that it's a number since I have array of numbers. Now, since I'm using reduce, I also want to provide the default value, which is going to be null. And then from this function, I want to return a string. So I'm going to set up the template literal. We'll provide the message, and we'll also provide the total over here. So now let me just see what the result is, I guess. So let me just log the result. And also we should see that doubled one in the console. So notice this functionality works over here, and the total is 15. And in the process, we covered two important things: how we can work with rest parameter, which essentially collects the list of values if we don't want to access them one by one, and also how smart TypeScript is. In the callback function, we don't need to explicitly say, well, what type it's going to be. TypeScript already knows. And up next, let's discuss what type we should return if we're not returning anything from the function. And a good old example is just having a console log. So let me go with function log message. As far as the parameter, we're looking for message. and that one will be equal to a string. And then in here, let's use our good old console log, and let's just log the message. Now I do want to invoke it, and I want to provide some kind of value. So in this case, I'm going to go with hello and TypeScript. And since we have nice suggestions, if we just hover over the log message, we can see that TypeScript inferred the return type as void. And void is a special type that represents the absence of a value. And when we use it as a function return type, void indicates that the function does not return a value. Now, $1,000,000 question, do you always have to set it up? I mean, it really depends on your approach, but it is super helpful, especially if you consider this. Once we add this void over here, even if I set up some kind of return, and I'm going to go with hello world, notice how TypeScript right away says, well, you cannot assign string to a void. So if we decide that this function is not going to return anything, and we set up the keyword, even if later on we mess up something and start returning some values from the function, TypeScript is going to stop us from doing that. And up next, let's discuss union types as function parameters and what the type guards are. Now, I did set up this topic as a challenge, just so you can see firsthand the type of issues we will face. So here's the task. I want you to create a function called process input that accepts a parameter of union type. So it can either be a string or a number. And when it comes to functionality, if the input type is number, we simply want to multiply it and log it in the console. And if it's going to be a string, just use one of the methods. So in my case, since my favorite method is the uppercase one, most likely I'll use that one, but it really comes down to the preference. So I'm going to navigate to my tutorial, and I want to come up with a function. So I'm going to go with process and then input. And I believe in one of the previous videos, when we covered the REST parameter, I mentioned that you can still use the union type. I mean, it's not a big deal. Here I can go with input and then just say string or the number. However, once we set up the functionality, this is where we'll add additional logic, since now we have two potential values, correct? So first, let's go with process input and pass in 10. This should work. And also, let's pass in the hello. Now, what about the logic? If we simply log, we should be good to go. So if I type input, notice there are no issues. But now what if I want to multiply this? What if I want to say times 2? Notice immediately TypeScript is not happy. Why? Well, we have a type string, and we're multiplying this by 2. Now, TypeScript doesn't know that in here we're passing in 10, and in here we have the hello. So we need to set up something called type guard, where before we do any functionality, we actually make sure that the type is correct. Essentially, if I want to run a string method, I want to make sure that it's a string. If I want to multiply, I want to make sure that it's a number. Again, the fancy name for that is type guard. Now, we will look at multiple type guards. The most straightforward one is just type of keyword. And then we look for specific value. So inside of the function, I do want to set up a check. So there's going to be a condition, and I'm going to go with type of. Then I'm looking for my parameter, and I'm going to say if it's equal to a number. And notice how immediately TypeScript was helpful and provided a bunch of options. If you didn't, let me go back. Notice these are the values that we can use. And in this case, we're looking for the number. If that's the case, what do I want to do? Well, I'm going to log times 2 over here. Now, if it's not the case, TypeScript is also smart. it knows that, listen, if it's a number, we're going to do this functionality. What is the alternative? Well, the alternative, it's a string, correct? So in here, we simply can go with else. Then again, we're going to go with log input. And you know what? Just so people are not upset with me, I'm just going to go with 2 lowercase. Again, the official name for this one is type guard, and we use it to check the parameter at the runtime. And while we're still on a roll, let's also see how we can work with objects as parameters in our function. So I'm going to set up a new function. Let me call this employee. And in here, I'll pass in the object with the ID property. And as a side note, the second example, which we're going to cover, is going to use a little different syntax. So in here, essentially, I'm right away destructuring the ID. I'm saying, yeah, there's going to be an object with the ID property, and I right away want to access it. Now, as far as the TypeScript, same deal. Just like with regular objects, we want to set up this type annotation, and we want to be specific. Well, what are we going to be getting here? So is this a number, string, or whatever? And in this case, I'm going to set it equal to a number. As a side note, yes, in like, I believe 3 videos, we'll cover type aliases. So it's not going to be as clunky, because at the moment, I fully understand if you're looking at it and you're like, whoa. So I understand this part, but does that mean that every time I'll have object with like 10 properties, we'll have to set it up over here? No, there is a better solution, and it's coming up. And also, just like with parameters, we can also set up the return type as an object. How does that look like? Well, same deal. I just say colon, then I provide the curlies, and what are we returning from this function? I'm going to go with ID, which again is going to be a number, and also there's going to be is active in this object, and that one will be a Boolean. And again, we set up the curlies. So we have 2 sets of curlies over here, and we also have 2 sets over here, because we have 1 for return and 1 for functionality. And as far as the logic, I just want to return an object from this function, and I need to make sure I follow this pattern, correct? I need to make sure that I return a number and a Boolean. So in this case, I'll just right away grab whatever I have over here. And also, as far as the is active, I'm just going to do some basic logic. I'm going to say ID, and then I'm going to use the modules operator. Essentially, if ID modulus 2 is equal to 0, then it's going to be true, which means essentially that it's an even number. If not, then it's going to be false. So now let's try it out. We're going to go with const first, set it equal to create employee, and then let's pass in our object. So in this case, it's going to be 1, then copy and paste. This will be equal to a second over here, and then we want to log both of these results. So let's look for first and second. Let me navigate to a console, and for some reason, it says false because, yep, I didn't change this one. This should be equal to 2. So now the first one is active is false, and then the second one is active is true. Again, we really don't care about the functionality. I mean, we can definitely hard code over here. Doesn't really matter. So hopefully it's clear. If we have an object, we nicely set up right away the annotation, at least with the current knowledge we have. Now, also we have alternative approach where we can give some kind of name to this object, and then we can just use it inside of the function body. Again, please keep in mind the general idea as far as TypeScript doesn't change, but I do want to make sure that we understand that we have multiple approaches. So let me call this alternative over here. Then we will go with function, create student in this case, and I know that I'm going to get the object, and I'm just going to give it a name of student. So this still will be an object, but I'll just access it with student dot student dot. And same deal. I want to go with my annotation. I'll say that ID will be a number and name will be equal to a string over here. And then as far as the function body, I'm actually going to go with void. So we're not going to return anything from this function, and we're just going to log stuff. So let me scroll down a little bit. Let's set up the template literal. Welcome to the course, I guess. And let's access the student, where we go with student. And notice we right away get the suggestion which properties are on this object, since this is what we specified in our type annotation. And in this case, I want to go with name and then to uppercase. Also, please keep in mind that yes, we can the structure right here in a function body as well. That's totally an option. So now let me call it with the new student. So in this case, just to again showcase that we have multiple approaches, we want to go with student. We want to set it equal to an object. I'm going to go with 5 over here, and name is going to be Anna. And I'm just going to rely on TypeScript to infer the type. And then we'll go with create student, pass in the new student, and if everything is correct, we should have the value in the console. And with this in place, we can move on to the next topic. Okay, before we move on and start working on our next challenge, let's also cover the access property check gotcha. And for this one, actually, we don't need to create too much code from the scratch. I'm just going to remove my first function from the previous video. I'll leave create student as it is, and I simply want to invoke it right below. And in this case, I will pass everything in line. So unlike previously, where we set up the object, now I'll provide all of these properties one by one. Let's start over here with ID. I'll set it equal to 1. As a side note, it's totally irrelevant what we pass in here. That's not the gotcha. The gotcha is following. If we add here extra property, what do you think is going to happen? Well, we have a type annotation for ID in string, correct? So, I mean, logic tells us that if we add here email and we set it equal to bobo@gmail.com, TypeScript is going to complain. And you're totally correct. Essentially, it says, hey, listen, you didn't specify that there's going to be an email while you're adding this to the object. So this is something we expect. However, notice this interesting behavior where I can go here with an email and essentially pass in some kind of value. And you know what? It's going to work. TypeScript is not going to complain. So yeah, this is this interesting behavior where when we pass in object properties in line, TypeScript expects to match this exactly. So if we'll add some extra properties, TypeScript will immediately complain, because in TypeScript's mind, we have a full control of what we're adding in line. However, if we're just referencing the object and there's an extra property, the only thing TypeScript cares about are the properties that are in the type notation. So if there's 120 extra properties, TypeScript is like, okay, do you have an ID and name? If yes, we're good to go. If not, then of course, there's still going to be an issue. Hopefully it's clear. Just remember this gotcha and you'll be good to go. All right. I think we're ready for our next challenge. And at least in my opinion, this one is going to be super interesting because we'll combine multiple things from the previous videos. So we want to create a process data function, which is going to accept 2 parameters. First one is going to be input parameter, which can be a string or a number. And second one will be a config object. And instead of that config object, we'll have the reverse property, which is a Boolean. So if we pass in a number, we just want to multiply the number with its own value, essentially input multiplied by the input. However, if the input is the string, our second option. And if the reverse is true, we want to reverse the string and set it uppercase. Now, if we provide a string, but the reverse is set to false, well, in that case, we'll simply set up the string to be uppercase and just return it. So let me navigate to my tutorial. I think I'll just remove all of this logic. And you know what? For starters, I want to set up a function. In here, I'm going to call this process data. I'm not going to set up any parameters yet. Same goes for functionality. And I simply want to log it in 3 places. Essentially invoke it and then log it. So in the first case, I'm going to pass in 10. And then I'll set up 2 more hellos. So these are going to be instances where we pass in the string. And now, as far as the process data, like I said, we have input over here, but we want to use the type union. So either it's going to be a string or it will be a number. So that will be our first parameter. Now the second one is the config one. If we pass this config, in there, there's going to be a reverse property. And as a side note, I actually forgot to do that. So first one is hello, and then we want to go with our config object. And I will set the reverse equals to true. So let's navigate to our parameters. And let's set up the second one. So I'm going to call this config. It's an object. And in there, I'll have the reverse property. So I'll set it equal to a Boolean. Now, here's the kicker. What if I pass in the number? Do I really care about that reverse one? And the answer is no. I only care about it if it's a string. Correct? Only then we'll check. But if it's a number, I mean, it doesn't really matter. And therefore, I can actually set this as default reverse false. So I'm not going to have to do that additional check. Basically, once I pass in the number, I don't have to pass this additional config object. So in here, let's go with default one and set it equal to reverse and false. Now let's also set up what we're returning from this function. So either it's going to be a string or a number. And now when it comes to logic, well, we have 2 options, correct? So we can have a string or a number. So we do need to set up a type guard if we want to multiply it. I want to make sure that it's actually a number. So let's go with if, then type of, if the input is equal to a number, well, that's when we want to multiply and return. So let's go with return, then input times input. And it looks like I have a tiny typo over here. This should be return. And also we want to set up the else. And in here, we're going to go with the return. Then we'll check the config reverse. So by default, it's going to be false. So if it's true, then we want to set it to uppercase, split, reverse, and join. If not, well, then we'll simply return it with the uppercase. So let's set up over here a ternary operator. We're going to go with input, then to uppercase. Let's invoke that. Then we're going to split it. Then we'll call reverse on it over here. And then lastly, let's use join method. Let's do this. And if it's false, which is the default one, we're going to go with input, then to uppercase, and we're going to invoke it. So now let me navigate to the browser and let's see. So I have 100, then I have straight up hello, just to uppercase, and then I have the reverse value. Again, in my opinion, the biggest gotcha is over here. You see, if you're not going to provide this default value over here, then pretty much every time you'll invoke this process data, it's also expecting this object over here. And if that's the functionality you want to go for, it's definitely an option. But in my opinion, it's super useful to add this default one. Because in that case, well, if it's a number Or if I don't want to actually reverse it, well, I simply don't provide that argument. At least that was my logic. And with this in place, we're done with the challenge and we can move on to the next topic. All right. And we have finally arrived at the type alias. At least in my opinion, one of the most exciting topics, because once I learned the topic, I was super, super excited since it just eliminated a bunch of clunky code. And for this one, I actually want to start with the code already present because I want to cover some stuff, and I highly encourage you to do pretty much the same. There's really no need to type this from the scratch. So grab it from the README and then let's go line by line. So we have two objects and we nicely set up over here the type annotations where ID is a number, name is a string, and is active is a boolean. So if I'm setting up some wrong values, TypeScript is going to be super helpful. And then we have a function, which again is looking for a user, and that user must have this particular shape. ID is a number, name is a string, and is active is a boolean. Okay, beautiful. And not only that, but from this function, for some weird reason, we return the same thing. We return the same shape. We return ID, name, and is active. And as far as the functionality, we just set it to uppercase and then return the user. And I can tell you right away that there's nothing wrong with this code as far as functionality. All of this works. But what is the biggest issue? I mean, we have code over here, same code over here, same code over here, and then we have the return. And this is just one file. What do we have? Like 20 lines of code? And pretty much we just constantly keep repeating this. So without further ado, I want to introduce you to a type alias in TypeScript, which again, in my opinion, is extremely helpful feature. Now, before we continue, let me just make sure that we are all on the same page. You see, a type alias is just a new name or a shorthand for existing type. And in this case, we're talking about this type over here, this type annotation. So nothing is actually going to change as far as this syntax is concerned. However, with type alias, it's going to be easier to reuse this one. So again, please keep in mind, we're not creating a new type. It's just an alias and all of the same rules apply to the alias one. That's why I wanted initially to cover how we set up such inline type annotation, because nothing is going to change as far as our functionality, including the optional property and read-only modifier. The only difference, well, now the code is going to be in one place. So if we ever want to change something, we will only need to do that in one specific place. And also our code is going to be less clunky because we'll just use that name. And once I'm done with my long and boring monologue, why don't we set it up? And essentially the syntax is following. We want to go with type. That's the keyword. Now the convention is to go with the uppercase, but you don't have to. I mean, you can call this also like this, but in my case, I will go with user. And like I said before, the syntax is the same. So I simply want to take my first instance and set it equal to my user. So now all throughout my file, document, project, whatever, I can use this user, and this will mean the same exact thing. So in here, I can go with, yeah, John is going to be object and a type is actually going to be user. Same is going to be over here. Susan is going to be a user. Now, when we're creating a user, what is a type? Well, it's a user type. And you can probably already guess the same is going to be over here. So we can go with user. And now $1,000,000 question, which one is easier to manage and read? And if you said the second one, you're absolutely correct. So I can mess with you and say that, you know what? No, actually, this one was easier to work with. But in reality, we can clearly see that this is definitely easier to work with. And I'm skipping a little bit ahead, but we can actually also export this one as well. So it's definitely an option. So let's say we set it up in one file, and then if we ever want to use this type alias somewhere else, we can nicely export it, import it in the file, and we're pretty much good to go. Okay, before we move on and start working on our next challenge, I also want to quickly showcase that we're not limited to using type alias for object. So it's definitely an option. It's definitely something we're going to do, but you can also do it for our previous examples as well. For example, I can go here with type. I'm going to call this string or number, and I'll set it equal to string, then use the union type and set it equal to a number. So now anywhere in my project where I want to use the union string or number, I can use my type alias instead of this hard-coded value. So let's say there's a value. This one will have a type string or number, and then we can go with value hello, and also we can set the value equal to 1, 2, 3. Now, is this something you're going to see often? Most likely not, but still, I definitely want to make sure that you know that it is a possibility. Now, something that you will see quite often, at least in my code, is this. I'm going to set up an alias, but in this case, I'm doing that for the literal type. So I'm going to go with light or dark. So this will be my theme, and those are the values. So it can be only light or dark. And now, if I have a theme variable, I can go with type theme. Then let me just change the values here. Notice how I right away have only these two options, something I have discussed already quite a few times. And in this case, I'm going to go with light. And what's also super, super awesome, that I can use the same theme one in the function. So if I go here with set theme, it's going to be looking for a parameter by the name of t, and the type over here is actually going to be a theme. And now I want to set my theme variable equal to whatever parameter gets passed in. So now when we invoke the theme, same deal over here. Notice how we can only use these two values. Again, super, super helpful, especially as your project grows bigger. So we can nicely set up this alias and then use it when we set up the property or when we pass some parameter in the function. And up next, let's work on another challenge. And during the challenge, we'll cover a few interesting things. We'll cover how we can set up type alias with the array, how we can set up type alias with type union, and how to set up a type guard if we're working with the object. So here's the challenge. We want to set up two types. One is going to be the employee type, and second one will be a manager type. Now, for employee, we'll set up two instances, and then I guess manager will set up only one. Now, the key difference is that for a manager, there's going to be employees property, and it's actually going to be an array of employee types. So this is where we'll combine the alias with the array. And then we want to set up a function, which actually is going to accept both types, whether that is the employee or the manager. And if the instance is the manager, then we just want to showcase how many employees they have. And if it's not the case, then we'll just log in which department the employee is working. So let's try to set this one up. I'm going to go with my alias first, and I'm looking for employee. So this one will set it equal to an object. There's going to be an ID property, which is a number. Then we'll go with name. I'll set that one equal to a string. And then also there's going to be a department. And for some reason, I have a hint that this is not correct typing. So let me fix that. So we're looking over here for department, which is a string. Now, there's also going to be an alias for manager. for this one, same deal. ID, number, name, string. So let me just copy them in order to make it faster. And now I want to set up the employees, which is going to be an array. But an array of what? It's not going to be an array of strings or numbers. And if you remember in one of the previous examples, we actually covered that we can set up type to be an object. Only in this case, we already have the type alias for that. So I can simply say, yeah, it's going to be an array, but it's going to be an array of employees. Okay, good. Now let's set up those instances and then we'll work on a function. So for starters, there's going to be first employee. We'll right away set up the type just so we don't mess up anything. ID1, then name. Let's set it up. And also let's come up with the department. In my case, I'm going to go with sales. Let me copy and paste. Now I want to change the variable name. So in here, we'll set up as Steve. Same deal over here. And then as far as the department, let's go with HR. Then let's set up our manager as well. So this will be Bob. The type will be manager. ID 1, name, Bob, or Bobo, even better. And then we'll go with employees. And this is our array, correct? So now I want to grab Alice and Steve. So let's set these two up. And now let's invoke the function, the print staff details. But of course, before I can invoke it, it would be useful if we would have this function in the first place, correct? So let me come up with the function. I'm going to call this print staff and then details. But here's the kicker. How are we going to pass this in? Because at the moment we have two types. So are we going to pass in just employee and then set up another function for the manager? Or we can somehow, somewhere combine the two. And the answer is, well, we can use the type union. So essentially I can go with type and then staff and set it equal to employee, or it's going to be a manager. And now this is our type. So now I can nicely go to print staff details and say, okay, there's going to be an object. And as far as the type, it's actually going to be equal to a stat. Now, I do want to set up the void over here since we're not going to return anything. And now another $1 million question. Well, how we can check whether the staff object is the employee or the manager. Because if it's a manager, then we do have an array. But if it's the employee, that's not the case. And we cannot go with, well, is type of equal to an object? Well, both of them are equal to an object. So that's not going to make much difference. Here's what we want to do. So we want to go with our condition, and then we need to pick a property which is specific to the object. So in this case, that's the employees, correct? So we go here with the property and we say in, and then our object over here. So that's the staff. If it's the case, well, then we know that it's a manager. If not, then we know it's a staff one. So let's go and log something here. We're going to go with staff name. So let me access this one, staff name, and then we'll say is an employee in the specific department. So in here, we want to access, again, the staff one. And now we're looking for department. Again, a property which is not on a manager. And again, TypeScript is smart. It knows that if there's an employee, this is going to be a manager. If not, well, that's the staff then. And I can access the department. So let me add this one. And now I want to just grab this console log and we'll just change a few things around. It's still going to be a console log, but we're going to go with manager. And notice how right away TypeScript is correcting us. Essentially, it says, well, department does not exist on type manager. So now what do we want to do? Well, we'll remove this. We're going to go with employees and we're looking for length. And let's just type employees. Okay, good. Let's try it out. I'm going to navigate to the bottom, and we're going to go with print staff details. Let's pass in the first one, and then let's also pass in the Bob. Once we navigate to the browser, we see that Alice is the employee and Bob is the manager. So this is how we can combine multiple features. This is how we can set up type alias with the type union. This is how we can start using type aliases with the array. And this is how we can set up a type guard if we are working with the object. Up next, let's discuss the intersection type in union, which is a way for us to combine multiple types into one. Let's imagine this scenario. We have a type book. It is equal to a number. Name is equal to a string. And there's also a price. So we set up this number over here and we're good to go. Then let's create, let's say, 2 instances. I'm going to call this book1 is equal to an object, and let's right away set up our type, our book type, and then in here, let's provide some dummy values. ID will be equal to 1, name will be how to cook a dragon, because why not? And also, let's set up some kind of price. So in this case, it's going to be some random 15. Then let me copy and paste. And instead of book1, this is going to be book2. Now the type will stay the same. The ID will be 2. As far as the name, we're going to go with The Secret Life of Unicorns. And we're going to set the price equal to 18. So all this is good, but what if I have a discounted book? Where not only I have these 3 properties, but there's also a discount. So first, let's set it up, and you know what? I think we can speed this up a little bit. Where it's not going to be a book. We're going to go with discounted book. Okay, good. Now, for now, type will be book, but clearly we'll have some issues. I can right away tell you that. Then let's come up with a name. In my case, I'm going to go with this one. Price will be equal to 25. And we also want to add this discount property, and we'll set this one equal to 0.15. And notice the moment we do that, TypeScript complains. Why? Well, because it's not in our types. So there is no discount anywhere here. So what's the solution? Well, we could create another type, correct? We could just copy and paste and set up over here a discounted book type and then just add that discount property. It's definitely an option, or we can nicely utilize the intersection type. How's that going to look like? Well, we have multiple ways how we can set this up. You can definitely do it over here in line, where you go with AND operator, and you just add what more types you want to have for this particular instance. So in this case, I can go with discount, and I can set it equal to a number. And notice TypeScript doesn't complain anymore. So now essentially, it uses all of the properties from the book type already, but we just added nicely the discount as well. So that's one option, or we can set up another alias. Now the logic here is not going to change. So I can just cut it out and go type, then discounted book, and we're going to set it equal to this one. So now for my discounted book, I can use the discounted book type alias. And again, the difference with union type, it's either going to be this type or the type on the other side of the pipe. However, with the intersection type, now we combine them. Now we say, yeah, it's going to have all of the properties that we have in the book type. And also there's going to be this discount one, which is a type number. All right. And at the end of the type alias section, I quickly want to mention that type alias also supports computed properties. So effectively, we don't always have to hard code. For example, if I have a tiger object, and eventually I'll set up the type, you know what, for now, let's just set up the object. In here, I can go with age and set it equal to 5. So nothing new. But we can also set up a variable. In there, we'll have a string, and we'll actually use that string as a property name. So straight up JavaScript. Let's say we're going to go with const prop name, and we're going to set it equal to age. And now instead of hard coding, I can just go with prop name. So if I'm going to change the string value, now my property is also going to change over here in the tiger. And we can do the same thing in the type alias. I can go with type animal. Let's set it equal to our object. And then instead of hard coding, we're going to go with prop name and set it equal to a number. I just need to follow the proper syntax over here. And now let's set up the type for the tiger. And we're good to go. So just like in regular JavaScript, we can use computed properties in type alias. Okay, and up next, let's cover interface type, which is used to describe the shape of an object. As a side note, we are purposely covering interface type right after type alias, simply because they are very similar. And yes, before you ask, quite often you can use either one of them, and the result is going to be the same. Now, what do programmers do when the same thing can be achieved in multiple ways? Well, we argue about it on Twitter and try to convince everyone else that our solution is somehow, some way better. Why? Because apparently that's the best use of our time. And remember, if all the other arguments don't work, you can always say, it's just a better practice to do it. Apparently that one always works. Jokes aside, I do personally prefer type alias over interface, and therefore during the course, most likely you'll see type alias syntax more often, but just like I mentioned before, it really comes down to your preference, despite what yet another Twitter guru says. Okay, hopefully I did not scare you away with my joke/rant, and if you're still here, let's set up a book object. So I'm going to navigate to my tutorial. I'm going to call this deep work, and you'll see in a second why. So we're going to go here with deep work. If I only would know how to spell, this is going to be my object. We're going to go over here with this ISBN, which essentially is just used for books as the ID. So in my case, I'm just going to go with 1, 2, 3. Then we're going to come up with title. I'm going to call this deep work. As a side note, this is an awesome book. Again, I'm by any means not being sponsored, or I'm not trying to sell you this book, but this is an awesome book. You won't regret whatever dollars it costs. So we're going to go over here with author. That is going to be Cal Newport. Awesome. And then let's also set up the genre. And I believe it's self-help. And we're looking for help. Now I do need to add over here a comma. And we already know how to set up the type alias. So probably this is something we're gonna set up at the very end. But we also can use the interface. Again, this is something that we use if we wanna describe the shape of the object. Now, the keyword is interface. Then we come up with a name. Same deal, lowercase, uppercase, totally up to you. In my case, I'm going to go with the uppercase. And then instead of the equal sign, we just want to set up over here the curlies. And then same deal. We go with the property name and then the type. And I right away want to mention that the read-only modifier, which we covered with type alias, as well as the optional property, is also allowed. And therefore, I'll go right away with read-only. Then I'll target basically this book ID, and I'll set it equal to a number. Remember, if we'll try to modify this value later, it's not going to work. Then also, let's set up a string. Okay, beautiful. That's going to be for the title. Then the same deal we're going to do with author. We're going to set it equal to a string. And the same is going to be for genre, but I'm going to set it as optional. Again, just so we get this one out of the way. I don't think we need to spend a separate video on these two things since we have covered them before. And effectively, if I go here, where is my deep work? And if I set it equal to my book, I'm good to go. So if for some reason I go with a deep work and try to modify this property, which is read only, let's say I'm going to go with some value. Notice TypeScript is going to complain. Same deal is going to be if I'll try to add a property that doesn't exist. Let's say price, and I'm going to set it equal to 100. That is not going to work. And then let's say for genre, since it's optional property, I can just remove it, basically comment out, and my code is still going to work. And if you enjoy working on the challenges, you can set up a type alias for this deep work object. And you'll see that in this scenario, you can use either of those approaches, and the result is going to be exactly the same. Okay, and up next, let's discuss methods in interfaces. And we're gonna spend few videos on it just because it's not, in my opinion, a complex topic, but it can be a little bit confusing because you can set up methods as properties as well. So essentially you can mix and match. And at that point, it might look a little confusing. So start with just straight up approach, which is my preference. And then I'll show you the alternative code that you might see somewhere in the wild. So effectively, if this book has, for example, a method of print author, I just go directly to my interface. In this case, I'm going to add a comment and I'm going to come up with that method. Now, please keep in mind in here, we're not typing any logic. I'm just saying, yes, there's going to be a print method, or you know what, should be print author. For some reason, I went with print method. It's not going to look for any parameters. And then as far as the return, it's not going to return anything. It's just going to log. So the moment I do that, now notice I have TypeScript complaining because I haven't set up that method over here. You know what? Just so I have less code, I'm just going to remove those comments over here. So now let's set up that method. Again, this is going to be my approach where I go with print author setup over here in my method. And in this case, I'm not looking for any params. We'll cover that in a second. And then we just go with log. And then since I'm not using the arrow function syntax, I can access any of these properties over here by using this. Again, we're going to cover the arrow syntax approach a little later. For now, we just want to log the author. That's it. So now let's go right after the object. We're going to go with deep work. Then we're going to invoke print author. And if everything is correct, we should see in a console the author. So let me take a look at the browser. And yep, I have my Cal Newport, so my logic works. Now, what is the syntax if there's going to be a parameter? Well, let's try it out. In this case, I'm going to go with print title, and I'm just going to add some message after the title. I'll say this book is awesome or something along those lines. So let's go here with title. We set up the parameter. As a side note, this name doesn't need to match whatever we set up over here in the instance. So in here, I'm just saying, yes, there's going to be some kind of parameter, and I'm going to reference this as message. Now, type is going to be string, and just for kicks, let's also return from this function. Again, we're not setting up any kind of logic over here. I'm just saying that there's going to be a method by the name of print title. So now we want to scroll down, and same deal. We want to set up our function. So I'm going to go with print title, and I'm just going to call this value just to showcase. Again, they don't need to match. Now, is my preference to set them up the same? Yes. But again, that is just my preference. And then inside of the function, same deal. In this case, I do want to return. And notice how TypeScript essentially is complaining that, hey, you said that it's going to be a string over here, and at the moment it's still void. What's up with that? So let me just access again this dot, since we're not using the arrow function. Then we can access nicely title, and I'm going to provide over here whatever message is going to be passed in. And then let's keep on moving. I guess right after the print author, either we can log it right away, or in my case, I think I'm just going to store it in a result. So let's go with deep work, then print. Nope, it's not the one. We want to go with print title, and then let's say is awesome book. So this will return a string. So what do we do with string value? Well, we log it. And yes, it looks like everything's correct, but text is not. So let me set it up properly over here. Again, if we have a method, in here we just set up the blueprint. So what is going to be the method name, whether we're going to accept any parameters. If we do, then it's useful to set up right away a type, and also whether we're going to return something from this function or no. And then inside of the instance, we set up the method, and we just need to follow our blueprint. So if we're not returning anything from this function, we just set up the functionality. If we are returning, we need to make sure that the types match. And with this syntax, we can access any properties by using this keyword. Okay, and up next, let's cover an alternative way how we can set up methods in interfaces. Now, let me stress something. Technically, this video is optional. I just wanted to cover this because you might encounter such syntax somewhere in the wild, but I personally tend to stick with the approach we covered in the previous video, simply because I find it way more straightforward. Alternatively, we can set up the method in the interface as a property. How's that going to look like? Well, we can go here with print something. And again, the example is going to be pretty straightforward. And essentially, we set it here equal to a function. But please keep in mind, this is a syntax. We're not setting up over here the arrow function. This is just the syntax that we're using. So we say that it's going to return a number, and then we set it equal to some value and pass in the number. And now with this property in place, we want to go to a deep work object. And here we have quite a few options to set up this function. So I'm going to add these comments. I'm going to say first option, then there's going to be a second option. And I believe there's going to be a third one as well, but we'll see. Most likely I will improvise as we go. So first option, well, we can use the good old function keyword. So I'm going to go with print something. That's going to be my property right now. Then I go with function, same deal. It's looking for some value. Now, what is going to be the value? That will be a number, correct? And then as far as the function body, just so I return a number, essentially, I'm just going to go with some value. Now, let me scroll down a little bit. I mean, most likely we can just remove these values just so our console is less busy and I can go with my deep work. Then let's go with print something. We want to pass in some number. Why not 34? And then let me set up the log and let me move this sucker inside. Then let me remove my semicolon. Let's navigate here and notice I have 34. So again, instead of setting up the straight up method, now I set up the property, which is equal to a function. In here, if I have some parameters, then I set up the type. And I also say, well, what is this function returning? Again, you don't have to return something from this function just because it's a property right now. So that is going to be our first option. Okay, let's comment this one out. And our second option is going to be arrow function. So we can go here with print something. Remember, we want to access the some value. That is going to be our parameter. And then as far as the logic, I'm going to go with some value. Now, there's a reason why I'm setting up the curlies. I'm fully aware that we can set up the implicit return. The reason for that is because I wanted to showcase that there's a gotcha with this and arrow functions. So arrow function is gonna capture the globalness. Please keep that in mind if you're using arrow functions. Unlike the good old regular function, where we right away have access to this, which is scoped to this instance, it's not going to be the case with the arrow function. So for example, if you want to access any of the properties, in my case, I'm going to go with author. We'll have to go with deep work and then the author. Now let's navigate over here. Notice we have both. We have the 34 and we also have the author. So this will be our second option. And I guess what was somewhat confusing is the fact that you can also do another way where I can go with print something and effectively just use the syntax we already used before. So this also is going to work. And that's why, again, my preference is just to use this approach where I set up the method and I clearly do the same thing inside of my instance. So this will also work. So we can go here with return and then some value, print something, and notice once we navigate back to the console, this also works. And lastly, I'm not trying to confuse you too much, but this also is going to work. So notice we have over here this print author, which is set up as a method, but we can set this one up as a property. So we can go here with print author. Now I believe TypeScript is going to complain, so I'll uncomment the first one, my approach, I guess. If I have a property, then we're going to go with print author, and we will set this up as a property, and we'll set it equal to an arrow function. Again, not trying to confuse you too much, but just showing you alternative syntax that you might see somewhere. Again, remember, we don't want to use this. We actually want to go with deep work, and then we're going to look for author. Now, TypeScript will complain since I already have my first approach. But again, if you navigate to the console, you'll see that the result is there. Now, I'm not calling print author. That's the reason why I don't have it. Let me go here. Let me invoke it. And you'll see that as far as functionality, it works. Again, what's confusing is that you can set the property equal to a function. So instead of straight up method, you set up a property, which is actually equal to a function. And then you can start doing this mix and match where, yeah, it was a property, but then actually in here, it's going to be a method and then the other way. That's why my preference is to set up methods with this syntax and the same in my instance. Just set up straight up methods simply because, in my opinion, is just less confusing. Hopefully, I didn't lose too many of you. And with this in place, now we can start working on our next task. Okay, and once we're familiar with the interface fundamentals, let's work on a small challenge where we want to set up a computer interface. Inside of it, we want to set up a few properties. One is going to be read-only, which is going to be for object, then brand equals to string. RAM is going to be number. Upgrade RAM will be a method. And in there, we're going to be looking for number, and we'll return a number. And also, there's going to be a storage property, which is going to be optional, but the type is going to be number. Also, once we have the interface, we will set up the instance and we'll provide the properties apart from the optional one. And then finally, we'll also invoke the upgrade RAM method. So let's try it out. Let me set up my interface. Name will be a computer. Let's go line by line. This one will be read-only. So I'll set it equal to my ID. Then brand equals to a string. After that, let's go with RAM. That will be number. Okay. Then upgrade RAM. This one will be a method. So we'll look for increase. And this actually is going to be a number. Now from this function, we want to return a number. And then also let's set up the storage, which will be optional, and we'll set it equal to a number. So now let's create our instance. In my case, it's going to be a laptop. So set it equal to our object, and we right away want to set up our interface type. Now let's pass in those values. There will be an ID. Then a brand is going to be a random brand. After that, we have a RAM. We'll set it equal to 8. I guess 8 gigs. And let's also set up our method upgrade RAM. As far as the parameter, I'm going to go with a different name just so you can see that for sure everything works, even though the names don't match. And in here, let's just set up the functionality where we grab the current RAM value and we just add the amount which is passed in. And then since I want to return a number, I'm just going to go with this dot and RAM. This is what we're returning. Since the storage is optional, I'm not going to pass it in. Let's just set up our instance, then storage, and now I'm going to set it equal to 256. We can log it. So let's go here with our laptop. Let's see. Yep, I have my object, ID, brand, RAM, and everything up to the upgrade RAM. And also let's invoke the upgrade RAM. Let's pass in some value and let's keep our console log. So we're going to go over here with another one, I guess, since we're returning the value. So let's go with laptop, upgrade RAM. Let's pass in some kind of value. In my case, I'm going to go with 4. And then if everything is correct, this is what we're getting back from the method. And also our RAM, instead of 8, is actually equal to 12. Okay, and up next, let's see how we can perform interface merging, how we can extend the interface, and then we'll work on another challenge. And during that challenge, we'll see how we can use type guard with interface. For starters, I want to create 2 interfaces, one for person and one for dog owner. Now, both of them will have 2 properties, I guess. Well, one is going to be a method, name, and let's say details. So let's go with interface. I'm going to go with person. I'm looking for name. I'll set it equal to a string. And also there's going to be a get details method, which will return a string. So that's my person one. And I also want to set up one for dog owner. So let's just go here, dog owner. So that one will have a dog name, I guess. That's going to be my property name, which is going to be a string. And then instead of get details, we're going to go get dog details. Let's invoke it. And again, we're looking for a string over here. Okay, beautiful. And first, let's see how we can merge the interfaces. So once I have my person one, I want to create my object. I'm going to call this person, and the type is going to be equal to my person interface. Now, what are the 2 values we need to provide? First, we need to go with John, and as I know, I'm missing here the equal sign. And the second will be the get details one. So let's just go with get details. That's the function. And we're gonna set up the functionality with the template string, name, colon. Then let me access this dot. So this dot name. And also let's add age. So this one will also be equal to this dot and then the age. Now, notice over here how we don't have the age, correct? And one way is to go back and set it up over here in this person. But there's another way how we can add this property, and that is by merging the interfaces. And I know that this looks a little funky in the beginning. Please keep in mind that most likely you're not going to do that in the same file, but let's say if you are getting the interface from somewhere, and if you know the name, you can do something like this. And as a side note, yes, essentially I'm using the same name. I go with interface person, and then I just go with age number. So I add that extra property over here. Now, this also needs to be in my instance, correct? So in here, I need to come up with some kind of value. And now the get details is correct. I can access both the name and age. So I have the first one, and then I just merge. So whatever properties I'm going to set it up over here, yes. Essentially, if I create this instance, now all of these properties will have to be there. Hopefully that is clear. Now, just to showcase, let me go with person dot and then get details. Let's invoke it. And for some reason, I don't see anything in the console. And of course, because I'm returning. So what am I doing here? Let me go with my log. Let me move this sucker up. And now let's try it out. Yep. I have name John and age is 30. And up next, let's see how we can extend the interface, which is a way for us to create a new interface that inherits or essentially just uses the properties and methods from the existing interface. Now, it sounds more complex than it actually is. Imagine this scenario. We have an employee instance. And for now, we're not going to set the type. Let's just set it equal to an object. I'm going to go with some kind of name. I'm going to go not with John. Let's go with Jane over here. Then let's also set up the age. Because remember, we already added this to a person. So now essentially we need name, we need get details, and we also need an age. So let's set up some kind of age here. Then let's go with our details. However, in this case, since we're going to add one more property, the return is going to be a little bit different. Here's the thing. Jane is a person. That kind of makes sense, correct? So I can definitely set it equal to a person and call it a day. However, let's imagine that Jane, since she's an employee, she also has the employee ID. Now, I don't want to add it to a person. So I want to keep this as a separate interface. But I do want to use all of the properties that I already have in my person one and just add on that employee ID. So here's how we can do that. We go with interface, then come up with a name. In my case, I'm going to go with employee, and then we go with this extends. And now we're just looking for a specific interface we want to use. And now let's just add this employee ID and set it equal to a number. So now Jane, not only she's going to be a person, but she's also going to be an employee. So now when we set up the type, we go with employee, and now not only I have name and age, but I also need to apply this employee ID. So let's add this one. Let's say over here 1, 2, 3. And then remember, details needs to return a string. So in this case, I'm just going to grab whatever we have over here. And then let's just add the employee ID as well. So let's add a comma. We're going to go with ID, and then let's access this dot and then employee ID. Now, just so we can see that everything works, I guess instead of person details, let me go with employee, get details, and yep, I have all three values in the console. Now, we can also inherit from multiple interfaces. Essentially, I can extend from the person as well as the dog owner. So we're going to go with a manager instance, I guess. So we're going to go here with manager. Eventually, we'll set up the type. For now, I just want to provide a name. It's going to be equal to a Bob. And also for now, let's go with the age, which will be equal to a 35. Now, when it comes to Bob, not only is going to be a person, so we'll need to provide all of the properties, but also let's imagine that he's a dog owner. So essentially, we want to extend from both interfaces that we already currently have. the person, and a dog owner. Now, since Bob is a manager, I also want to add a method onto the interface. And in my case, I'm going to call this manage people. So let's move where we have Bob. And first, I guess let's construct the interface and then we'll worry about the properties. So we're going to go with interface manager. For starters, let's just add that method that I was talking about. So I simply want to go with manage people. It's not going to take any parameters and we're not going to return anything. And if we set this equal to a Bob, we'll have an issue since we have two properties that we haven't set up in our interface. So now let's go with extends and one by one, let's look for those interfaces. So we're looking for a person and a dog owner. So Bob is a manager, a person, and a dog owner. And now if I navigate over here and set it equal to a manager type, I will have to provide all of these values. What they are, well, we need to provide a dog name. Let's go with Rex. It's a super popular name. Then we also have get details, and you know what? In this case, I will speed this up. I really don't want to type everything from the scratch. So we have get details. What do we want to access here? I guess let's just go with age since we don't have the employee ID. Then we also have one for dog. So let's go with get dog details. Now we will go with name is, and then let's access the dog name. Dog name over here. Then let's remove the age. I guess we don't need it. And lastly, let's set up that manage people. Manage people. Let's invoke it. And for now, we simply want to log. So let's set up a console log and let's write a text managing people. And lastly, just to test it out that everything works, I want to go with manager and let's invoke manage people. If everything's correct, we should have this text in a console. And again, this is how we can merge interfaces by essentially using the same name and just adding the properties. Another name that you might hear is reopen. Essentially, they mean the same thing, where we declare the interface with the same name one more time, and then TypeScript is going to merge them together. And we can also extend. So let's say if we have an interface with some properties and methods, and we just want to grab methods and properties from some other interface, simply go with extends. We'll look for that specific interface, and in the process, we'll right away get those methods and properties. And with this in place, we can move on to the next task. And up next, let's work on another challenge. And during the challenge, we'll see how we can use type guard with the interface. Now, I did split up the challenge into multiple videos. So in the first video, we'll kind of prepare everything. We'll set up our function. We will return one of the interface types. And then in the following video, we'll work on more logic where we'll see how we can use the type guard. So I didn't want to jam everything in one video because there's quite a few lines of code. And I mean, the most important thing is kind of at the very end. And usually if it's a long video, then people just lose the interest. So long story short, we want to define a person interface with the name string. Then we want to set up a dog owner, which extends the person, and just add the dog name, which is going to be a string. And also we want to set up a manager, which extends the person. So not person and the dog owner. No, the manager is going to extend only the person. And we'll just add two more methods on it. Then we want to set up the instance, which can be either of them. So we'll use the union type, and actually we'll set it equal to get employee function. Now in get employee, we'll just call math.random, and based on a value, we'll return one of those interfaces. So whether a person, dog owner, and a manager. And again, in the next video, we'll see how we can use the type guard, because there's a gotcha that we need to be aware of. For starters, let's navigate to tutorial one by one. Let's set it up. So this is an interface. We want to go with person. Let's go with name equals string. Okay. Then let's also set up a dog owner. So we have here interface dog owner. Now that one will extend the person. So get that name property, and we also want to add the dog name. Dog name will be equal to a string. And then the last interface is going to be a manager, which is going to extend the person. And in here, let's go with manage people. That's our method. And we're simply going to go with void and also copy and paste. And let's say delegate tasks. So those are our two functions. And then let's set up our instance. But before we do that, let's also set up a function, and I'm going to call this get employee. And this is the function that we're going to use in our employee instance. So for starters, I'm going to go here with const employee. And as far as the type, I'm going to use the union type. So either it's going to be a person, or it's going to be a dog owner, or it's going to be a manager. And I'm going to set it equal to my get employee, and I'm going to invoke it. Now, I do want to move this function up simply because in the following video, we'll write the code over here. I think it's going to be less confusing. So let me move it up. That's going to be our function. And here's the task. Inside of the get employee, I want to invoke math.random. And then based on the value, if it's say less than 0.33, well, then I'm just going to return a person interface. If not, then it's going to be a dog owner. And if not, then it's going to be a manager. So I have this employee. Notice over here, it just says, well, the moment you're returning void, and that's not what the employee is expecting. So in here, I'm looking for one of these three values. Now, in this get employee, we're not going to pass any parameters. We simply want to go with our logic. So let's set up the random. That one will be equal to math.random. So we'll get some random value between 0 and 1. And now let's just work on those returns. But also, let's set up the type right away. So we're looking for person. We'll also grab the dog owner. And potentially, this could be a manager. So again, we don't know what the value is going to be. So every time we'll refresh the browser, we'll get some random value over here. And then based on that value, we'll set up that return. So let's start with our first option. If the value is less than 0.33. Well, in that case, I want to go here and I want to return a name, John. So which interface is that? Well, that's the person one, correct? So these two match. Then let's also set up another else if. So if the random is less than 0.66, well, in that case, let me grab this, and now we just want to add the dog name. So in this case, we're going to go with Sarah, and we're going to go with dog name, and we're going to set it equal to Rex. Now, lastly, if it's not less than 0.33, if it's not less than 0.66, then we're going to go with another else. And in here, we want to return a manager interface. So in this case, we're going to go with return, then object, name will be equal to a Bob. And then let's set up those two methods. We're going to go with manage people. And as far as the logic, let me just go with console log. And we're going to say managing people. Okay, good. And then let's do the same thing for delegate tasks. That's my function. And as far as the text, it's going to match. Now let me navigate where I have the employee and let's just log it. Like I said, we'll have to refresh the browser. So once I navigate over here, notice this was my person instance. Then I get over here the manager, correct? Then I get the dog owner, and as you can see, every time we refresh the browser, we're getting a different value. So in here again, we want to set get employee, and we want to make sure that we only return one of these interfaces. We use the union type, and then when it comes to the instance, same deal. I'm looking for one of these three values. So employee is going to be either a person, a dog owner, or a manager. And in the following video, we'll introduce the type guard and make this challenge more complex. Okay, and with this in place, now let's make this challenge more complex by adding a function which is going to check for specific interface. And only if it's a manager, we want to invoke delegate tasks. Because here's the kicker. We get back our object, we store it in the employee, and if we try to go with name, everything works. Why? Well, because dog owner extends the person, manager extends the person. So that property will be definitely there. We can navigate to the browser. We just need to refresh, and eventually we will see all three values. But it's different with delegate tasks. So notice, once you start typing, TypeScript is complaining. It says, well, listen, it could be either the person or a dog owner or a manager. So you don't know that 100% the delegate tasks is going to be there at runtime. And this is why we want to set up a function. And we'll start with somewhat straightforward approach. And then we'll cover why we want to use type predicate. So let's go here with a function. In my case, I'm going to call this isManager. So I want to make sure that it's a manager. And then in the if block, I'm just going to invoke delegate tasks. That's my overall goal. So I'm going to be looking for object because this is what we're getting back from employee. But same deal. As far as the parameter, well, it can be one of these three interfaces. Okay. Then as far as the return, like I said, for now, let's just go with the straightforward approach where I'm going to go with Boolean. Either it's going to be true or false. And I guess the first gotcha in here is the return. Remember previously when we used the type guards, we did something like this. We went with type of, then object, and set it equal to something. Now, is it equal to what? Object? Well, all of them are objects. So that's not specific. So if I invoke isManager with employee, this should return for all of them pretty much the same value. Let's try it out. We're going to go here with log isManager. Then let's pass in the employee and let's take a look at the console. Notice as I'm clicking, I'm all the time getting true. So yeah, this type guard is great, but it's not going to work in this case. So if we want to check for manager, we want to look for something specific. And that something specific is one of these methods. And the syntax is following, where we want to go with the method, which will pass in the string, and in, and then the parameter, in this case, object. So now let's correctly type one of the methods, in my case, manage people. And now let's navigate to the browser. And again, once we refresh, we'll actually see correct results. Only if the interface is manager, then we return true. And if it's not the case, then we return false. But there's another gotcha. So now let's go and set up if block. I'm going to go with isManager. I'll pass in the employee, pretty much our setup. And then let's try to invoke employee, and same deal. I don't have delegate tasks for some reason. Let me try to invoke it. And again, TypeScript is complaining. So here's the deal. Yes, our logic over here is correct. But just because we return a Boolean from this function doesn't automatically signal to a TypeScript that now employee is actually type of manager. in here, basically, yeah, we passed the if condition, but as far as TypeScript is concerned, it can be still one of these three types. And this is where type predicate is super useful. And that is a special kind of return that not only returns a Boolean, but also it asserts the argument to be a specific type. So what am I talking about? In here, instead of the Boolean, we can go with object. That's going to be the syntax is. And then since I'm checking over here for the manager, that's the interface I'm going to use. And now TypeScript definitely knows that once we pass this condition, this will be a interface manager. So once I navigate back over here, I can refresh. Once I'm getting back the manager, I'm also logging delegating tasks. Okay, and at the very end of the interface section, I also want to cover the differences between the interface and the type alias. So if you're setting up the object, since interface is used to provide the shape of an object, you can use either of them. So if I have object John with name and age, I can either use the alias type person, or I can use the interface person. Now, as far as the differences, you see, type alias, we can also set up for primitive types. For example, if I have number or the union type number or string, and the literal types, you won't be able to do that with the interface. So that's the first difference. Again, when it comes to interfaces, they're useful to provide the shape of an object, but you won't use them with the primitive or with the literal type. Now, with interfaces, we can merge them together like we covered before. Or another word is to reopen them. You won't be able to do that with the type. So with the interface, you can set up the interface, you can add some properties, then, I don't know, 3 lines later, you can create the same interface, basically with the same name, just add more properties, and you're good to go. That doesn't fly with the type. That's another difference. Now, as far as the interfaces, they can be implemented by the classes, while the type aliases cannot be implemented in such way. So if you work with classes, this is something to keep in mind. You can use the interface with the class, but you won't be able to implement the type alias with the class. And lastly, remember when we covered computed properties, you can only do that with type alias. So you won't be able to use the computed properties with the interface. And with this in place, now we can move on to our next topic. Okay, and up next, let's discuss tuple or tuple in TypeScript, which is a special type since we don't have it in JavaScript. And essentially, it allows us to set up an array with fixed length and ordered with fixed type. In other words, it's super useful when we want to group different types of values together. So for example, I have a let person. Now, this is an array, and here I have string of John and then number of 25. I can set the type in such a way where I go with my array and then I provide those values. So in this case, I'm going to go with string and number. So now this value is fixed. So if I'm going to try to add something else like hello, TypeScript is going to complain if the types are not going to match. If, for example, I do decide to place 25 over here, TypeScript also is going to complain. So not only we have fixed length, but also we right away set up the fixed types. So now this value can be only the string and number. Now there is a gotcha, something I'm going to cover in a second, but for now, let's just focus on this, that yes, it's going to be John and it's going to be 25. Now you're not limited to only 2 values over here. You can set up as many as you want. And for example, you can go here with number and number. I mean, that's also an option. let's say you don't want to have just an array of numbers, but you want to have an array with fixed amount of numbers. So let me just go here. Let's say with date. So in this case, it's going to be number, number, and number. And then depending where you live, either you'll pass in the month or the day. So let's say I'm going to go with 12, then 17, and then we're going to go with 2001. So notice now this is a fixed array with number, number, number. So again, if we make any changes, TypeScript will complain about it. Now, it's useful if, let's say, we want to return something from the function. Let me go with function get person, and we're not going to provide any parameters. I'm just going to say that, yeah, this function is going to return an array with such types. So string and number. So now let's set up the function body where we want to go with our array. We want to pass in John, and we're going to go with our 25. So now if we have random person now, that one is equal to a get person, we invoke it. If we log random person and then 0, copy and paste, and 1 in a console, we should have both of those values. Now, like I mentioned, the gotcha here is that even though when we're hard coding these values, TypeScript is going to complain unless we provide over here this read only, we can actually add items or remove items from our particular array. So how is that going to look like? Well, let's say if I go with date.push, I can add the values, and TypeScript actually is not going to complain about it. Now, it complains because it's not a number, right? So it says, well, it's not a number, but if I change this to my 34, everything is going to be fine. So I can set up multiple instances, and now if I log the date, check it out. It's probably not something that we expected. Now, the workaround is to provide this read-only over here. So in this case, I cannot do that. So once we add this read-only, we cannot use anymore the push pop or whatever methods. That's something to keep in mind. Now, lastly, I also want to mention that we can use the optional parameters as well. So let's say if I'm going to create a new instance and I'm going to call this Susan. So I'm going to go with my tuple. We're going to set up a string, a number, and in here I'm just going to go with my optional parameter. Once I set it equal to my function, notice I can just provide the string, and basically I'm good to go. TypeScript is not complaining. This should do it for tuples in TypeScript. And up next, we're going to discuss enums in TypeScript. Okay, and up next, let's discuss enums in TypeScript, against something we don't have in JavaScript. And essentially, enums allow us to define a set of named constants. The syntax is following. We want to go with keyword enum. Then let's come up with a name. In my case, I'm going to go with server response status, since we'll have a little bit of functionality. So we're going to go with response status. Then we want to go with the curlies, and this is totally up to you. You can go all lowercase, you can capitalize the first letter, or you can go all uppercase. Totally up to you. We just need to provide over here the values. And in a second, I'll show you what this actually results to. So first one is going to be success and then the error. Now we can add more, but for our example, we really don't need it. Then let's set up the interface. In this case, I'm going to call this server response. And then the first property, result, actually is going to be type of enum. So let's set it equal to server response status. And then another one is going to be a data. And this will be an array of strings. So now let's set up a function get server response, which actually is going to return this interface. So we go here with function get server response. Let's invoke that. As far as the return type, let's set up the server response. So this is equal right now to our interface. And then inside of the function body, we want to go with result. And now, since this is type enum over here, this is what we want to use. So we'll go over here with server response status. And notice we either have error or success. Again, you can use enum if you want to store some constants and then later on use it in your project. So now in this case, we only can provide success or the error. So let me type this one, and then in order to match our interface, I'll provide data as well. I'll say first item, then comma, and we're going to go with second item. Now I do need to add a comma over here. We do want to invoke it and set it equal to response. Const response is equal to our get server response. Let's invoke this function over here. And let's set up the type, what we're expecting. So we're going to look for our interface. And then let's also log the response, just because I want to show you the potential values we can set up over here. So at the moment we have success and error. And by default, they actually get the numbers starting with 0. And I'll show you what I mean in a second. So first, let me just log the response. And notice how the result is 0. Now, why is that? Well, because if we go up over here and we log server response status, we'll see that we have right now the success and error, and the values are 0 and 1. So it starts with 0, then 1, and then pretty much the more values you add, well, the more numbers you're going to have. Now, don't be surprised if you see quite a few values in a console. Essentially, at the moment, we have 4 of them. This is something we're going to discuss in the upcoming video. For now, I just want to showcase that even by default, you get those values starting with 0. So 0, 1, 2, 3, and whatever. You can also reassign them. So for example, I can say that success is going to be equal to a 500, or I'm sorry, 200, and error is going to be equal to 500. Or I can mix and match. I can say that, yeah, error is actually going to be equal to this string. This also is valid. And again, the main point is that now we have over here this constant, which we can use all throughout our project, instead of trying to make sure that we type the string or the number correctly. Okay, and up next, let's take a look at the gotcha with enums, which is the fact that when you have number values, it's actually going to do the reverse mapping. And remember, it is the default. So if we don't provide anything, we will get that reverse mapping. For example, if I provide over here 200 and 500, if I navigate to the browser, again, I have more values over here in this object. So not only error and success, but I also have this reverse where number is actually a property, and then whatever is my constant name is set as value. Now, why do we care? Well, because let's say we want to iterate over the values. In JavaScript, we have object.values, and then we pass in the object. Now, in this case, we'll pass in the enum, and you'll see that everything is going to work, but it's going to depend what kind of value we have over here. If we have a number, we'll have to do an extra check. So let's go here with object.values. Then let's provide server response status. And we're going to go with for each. So we're iterating over. Now I want to grab every value and we'll just log it. And again, since I have the number values, I have this reverse mapping. So now not only I have the number value, I also have this success and error. And it's not going to be the case if, let's say, we're going to go here with success and in here error. Again, something valid that you might set up in your code. Now everything is correct. Now we're only accessing that string. So if we have numbers, which again is the default setup. So again, let me set it up here as 200. just so we're on the same page. The solution over here is just to add another type guard. So if I only want to access the values, they are type what? They're number. So this was going to be a string. And therefore, in here, I'll say if type of and value. That was the name of my parameter. If it's equal to a number, well, then I want to log it or do some kind of functionality. In this case, just log. So we're going to go with console log and we'll log the value. So now we correctly just access those number values. Now, another place where we need to be careful is when we're setting up the value. So notice something interesting. If I have an enum, I have a constant over here, and the value is number, then later when I set up this enum as my type, I can still use the good old number. So this is going to work because, again, TypeScript is doing that reverse mapping. However, if you have an enum where the constant value is actually a string, this is not going to fly. So just to showcase that, I think I'll comment this one out. So if I have here 200 and 500, if I set up over here this result to be equal to my enum, I can go to my server response, and this is going to work. So TypeScript is not going to complain about it. And I can see that my code runs and everything is awesome. However, if again, and I promised for the last time, we'll change it around, we go with success and error, this is not going to fly. If we navigate back to our get server response and try to provide the string value. As you can see right now, TypeScript is complaining. So we cannot assign string to a type enum. However, when we use the number value, it's going to work because there is this reverse mapping. Hopefully that's clear. And now we're ready to move on to the next topic. Okay, and now let's work on our next challenge where we want to define a enum with the constants of admin, manager, and employee. Define the type alias named user. And in there, we'll set up the ID, property, name, as well as the role. And the role is going to be equal to our enum. And also we'll set up the contact, which is going to be a tuple with two elements, the email, which is a string, as well as the phone. Then we'll set up a function by the name of createUser, which will take in the user object as a parameter and return the user object. And then at the very end, we'll call the user object, provide the object, and we'll create the instance. So in the tutorial, I think I want to start by defining that enum here. Let's call this user role. Let me set up my constants here. And I think I'm going to rely on those default values. So 0, 1, 2, and I guess in this case, that's going to be it. Only going to be 0 and 1, 2. Then we also want to go with employee. After that, let's set up that type alias. In this case, user. Here, one by one, let's set up those properties. ID is equal to a number. Then we also have name is equal to a string. We're going to go with the role. And in this case, it's going to be equal to a user role. So one of our three constants. And then we also want to go with contact and set this one up as string and string. We have create user function. So let's set it up over here. Create user. And this one is looking for a user parameter, which is going to be type user. Same deal over here. We're going to go with user. And from the function, we'll return the user. And the last step is to create the instance. So let's go with the user, which will be type user. Let's call create user. And now let's provide the values. ID, name, John Doe. Then also we'll have a role. And since we're using our enum, we're just going to set it equal to user role, then dot, and one of the values. In my case, I think I'm going to go with admin one. And then at the very end, we also have the contact. I want to set it equal to our array, and let's just provide some values, gmail.com, comma, and then we're going to go with 1, 2, 3, 4, 5, 6, and 7, 8, 9. At the very end, let's just log it, and pretty sure everything's going to be correct. Yep. Looks like I have the correct value. And with this in place, we're ready to move on to the next topic. And up next, let's cover type assertion, which is a way to tell the browser what type an existing variable is. And this is especially useful when we know more about the type than the TypeScript does. As a side note, it's very handy with DOM elements. So if these examples don't seem that convincing, in the later sections, we will cover different examples as well. So let's imagine the scenario. We have a variable, and I'm going to go with some value, and for some reason, type is any. Now, as far as the value, I'll set this up as a string. So this is a string. And then in the next line, I want to get the string length, which actually is going to be a number. So in here, let's set it up. Type is going to be equal to a number. And now I want to go with dot length, but I want to assert to a TypeScript that actually this is a string. So I'll say some value, not just any type. I'll say as string. So the keyword we're looking for is this as. That's the assertion where we tell TypeScript that, yeah, I know that maybe this is not something you expect, but I know more. And I know that this is the specific type. This is also something that we can use, for example, with the JSON parse, because it returns any. So let's say we have a type bird. Now this type bird only has a name, and we'll set it equal to a string. Now it looks like I have a typo over here, so let me set it properly. And now I'll set up 2 JSON strings, and we'll run parse. Now, in order to speed this up, I will grab those values from the README over here. So basically, we have bird string and a dog string. We want to set it up over here. And now, again, once we'll run JSON parse, you'll see that type actually is any. So let's say I have a bird object, and that one is equal to JSON, then parse. And now I'll pass in my bird string. So again, let me copy and paste, and let me set up one for the dog. And as we hover over, like I said, type is any. But I don't want type to be any. I actually want this to be a type bird. So if we create an instance or any other functionality, and we set it equal to a bird object, instead of just leaving it as type any, I can go with as, and then my type. Because I clearly know that, yeah, maybe I'm getting this back as type any, but I know that the signature matches whatever I have here for the type bird. Now, please be careful. You can also do something like this, where you can set up the dog to be a bird. And most likely, that's not the behavior you want. So if I go over here with not bird object, I'm going to go with a dog object, and I'll set it equal to a bird. I will be able to look for dog.name. But if we take a look at the dog string, it doesn't have that property. So it has the breed. So if we go here with log and we type bird name, and as I said, for some reason it's complaining, it says cannot find bird. And yep, it's because for some reason I named it bed. So let me go here with bird and also a dog. Notice how TypeScript is not complaining, because I made a type assertion that yes, this will be type bird, even though we can clearly see that it's actually type dog. Now, we don't have the type yet, but you get the point. So if I navigate right out of the browser, notice how I will get this unexpected undefined at runtime. And at the very end, let me just show you a use case that I just encountered when I was working on my next JS project. So in there was a enum, and I believe the name was status. Don't quote me on that. And there were more values, but I'm just going to set up 2 so we don't have to spend all day typing. And essentially, there was a constant, and I set the values equal to a string. So there was pending, I believe, interview, declined, but we're just going to go with these 2. So we're going to go with declined, and we'll set it equal also to a string. So I had this enum, and then I was just adding it to, I believe it was the job instance, and I was saving it in the database. Now here's the kicker. When I was saving actually in a database, I was saving it as a string because that was the value for my status pending. And then when I was getting back the value from the database, it was already a string. But I needed to reassign this value to one of the instances. And at that point, TypeScript was complaining because they didn't match. And if this doesn't make any sense, let me just showcase. Let's imagine that we have a user object, and in there I have 2 things. I have name string, and also status is now going to be equal to a type status. So we know that essentially we can use status.pending, status.decline, everything is nice. But since these values are not numbers, we don't have that reverse mapping. So if we'll try to set this value as a string, it's not going to work. So now let me quickly navigate to README, and I just want to grab these 2 comments over here, again, just so we don't have to type this from the scratch. Imagine this scenario. Now we save status pending in a database, but we save it as a string. So we'll save this value over here. Then we get it back from the database. And now I'm going to go with the status value, and I'll set it equal to the string value of pending. So effectively, this is what I'm getting back from the database. Again, kind of makes sense, correct? Because this is the actual string value. Now, if I'm going to go here and set up my user instance and set it equal to my user type, yep, I typed a name, everything's correct. But if I'm just going to go with the status is equal to a status value, notice how TypeScript immediately complains. Type pending is not assignable to this type. So TypeScript doesn't know that I saved it in the database as a string, so I know for sure that it's the value that's going to match the constants here in the status. TypeScript doesn't know that. It just says, hey, listen, status here is type status, so you cannot set it equal to a string. And this is where the assertion is useful, where I say, yeah, it is a string, but I know for sure that is type status. So again, type assertion essentially is a way to tell the TypeScript that we know what the type is, that we know more about the type than the TypeScript does. Okay, and up next, let's cover type unknown, which is a type safe counterpart to type any. So just like type any, we can assign any value to type unknown. But the difference is that before we can use the variable with type unknown, we need to perform some type checking, which again avoids the unnecessary runtime errors. So let me go to tutorial, and in here I want to create a variable, and I guess in my case I'm gonna call it unknown value. So that will be my name, and as far as the type, I will set it equal to unknown. So just like with any, I can go here with unknown value, and I can set it up, for example, to be a, I don't know, a hello world. So yep, this is allowed. I can also go to a next line and set it equal to, for example, array. That is also allowed. So let me set up my array. I'm going to go with numbers. Okay, good. And then also we can set it up to be a number. So let me go with 42, and then let me add some numbers after the dot. So this is allowed. Now the difference is that I cannot go over here and say unknown value and then set it equal to a fixed. As we can see, TypeScript complains. It says, hey, listen, that type is unknown. and right away you're running some kind of method. How am I supposed to know that it's actually a number and we can run this particular method? I mean, maybe it's still a string. So the difference again, unlike type any, before we can use that value, if it's type unknown, we need to check, well, what is the type? So in this case, we can do following operation. I can go type of and then unknown value, and I can check, well, if it's a number, well, then I want to run my method. So let me move this sucker down. And notice now everything works, because in this condition, TypeScript knows that, yeah, unknown value is actually a number. Now, one place where we'll definitely see type unknown is in the try catch block, because by default, TypeScript is going to set this error to be unknown. Now, why do we care about that? Well, what is typically the first thing we do over here? Go here with log, and then error, and then the message. And notice how TypeScript says, well, error is type unknown. So how do you know that there's definitely going to be over here this message property? And this assumption comes from the fact that typically, especially if we're throwing our own errors over here, we use the following code. We go with throw new error and provide whatever message. And in this case, I'm going to go with there was an error. So this is a nice assumption, but please keep in mind that in JavaScript, we can also do something like this. We can go with throw and some string over here. And I know what you're thinking. Well, there's no way I'll do that in a try catch block. Yeah, but you might be running some code from third-party library. And at that point, you don't know whether the error you're going to be getting back is going to be the instance of the error class, or it's going to be something else. Again, it literally can be a simple string. Now, to demonstrate that, I will use somewhat of a silly example where I'm going to set up the function over here. I'm going to go with run some code. So let's imagine that we're saving an image in a database, or I don't know, we're posting some data somewhere, we're sending an email or whatever. And in here, I'm just going to set it equal to a random. Then let's go with math.random. Let's invoke that. And essentially, if it's less than 0.5, then I want to throw a new error. If not, then I'll just throw good old string. So let's set up over here if else, and let's check for random. If it's less than 0.5, well, then I want to use this sucker. Let me set it up over here. And if not, then I'll just go with throw, and we're going to go with some error. So let me save this. And now in try block, let's go with run some code. And effectively in here, in a catch, we want to check whether the error is the instance of the error class. And if that's the case, yeah, then we'll have access to the message. In this case, there was an error. And if not, well, then we'll simply log and provide some hard-coded error. And this is essentially what you're going to do when you're working with TypeScript. Before you do something with that message, you want to check whether the error you're getting is actually the instance of the error class. So here in the catch block, we want to go with error instance of. We're looking for the error. And then if that's the case, yeah, then TypeScript knows, okay, there is a message property. And here we can go right now with log, and we can set up the error dot message. Now, if it's not the case, since I already have some text, I'll simply log the error. Let me log it. So now let's navigate to the browser and check it out. Depending on that math random, either we're going to get there was an error, or we'll have that string some error. And again, just like any, type unknown can be anything. But before we can start using type unknown, we'll have to do some type checking. And therefore, this is a type safe alternative to type any. And up next, let's cover type never, which is a special type that represents the type of values that never occur. Now, I'm not going to sugarcoat it, especially in the beginning. This entire concept might seem pretty confusing, but hopefully after we cover one of the most common use cases of type never, it's going to be easier to grasp the main concept of type never. For starters, let's just establish that if we have a variable with type never, we cannot assign value to it. So let's say if we set up a variable, some value, and if let's say it's 0, if I'm going to go with type never, TypeScript is going to complain. And I'm going to get the same result regardless of the value over here. So this can be hello world, this can be an array, doesn't really matter. We cannot assign any value to type never. So that's the first thing we need to remember. Second, you might encounter in your own code type never if you set up one too many conditionals, speaking from the personal experience. So let's say you have a type theme over here, and you set it equal to two possible values. Either it's going to be light or it's going to be dark. Then let's set up a very useful function called check theme. Yes, we'll say that theme parameter is going to be equal to our type of theme. Now we're not going to return anything, so I'm just going to set it equal to void. And then inside of the function, I'm going to set up two conditions. I'm going to go with, well, if theme is equal to, and then I'm going to go with light one. And I'm not going to be particularly original. I'm just going to go with light theme. And then let's return from the function. And we already know that TypeScript is super smart. It knows that at this point, theme can only be value of dark, correct? Because these are the only two options. But let's imagine a scenario where we do add another condition. I'm going to go with if theme is dark. Okay, good. Then I want to log it, but I'll change the value and I'll also return. So let me change this one around. Let me go with dark theme. And notice something interesting. If we type theme after both of these conditions, TypeScript says, hey, listen, theme is type never. Because we have handled all of the possible cases. So at this point in time, there is no possible value for this theme. So if you ever encounter such scenario, you'll have to go back and look at the original value and also all the conditions you're setting up. Because somewhere things are going south. If you are at the point where variable is type never, well, then you already have handled all the possible cases. And what's really awesome, we can actually use it to our advantage. The fact that we cannot assign any values to never, and also the fact that TypeScript will immediately assign type never if we cover all of the possible conditions. As far as our example, we're going to go with enum. I'm going to set it equal to a color. We're going to go with red and blue. So those are two possible values. Now we can assign it to a string, but there's really no need. Then we want to set up a function. In my case, I'm going to go with getColorName. As a side note, I'm just going to set up a switch statement where we check for possible values. But if you work with Redux, you'll find this example very similar to how we set up the Redux store. So as far as the type for my parameter, it's going to be a color. And inside of this function, I simply want to go with switch. I want to check for my color, and let's set up our cases. So at this point, we have two of them. So we're going to go with color.red. So if the color is red, what do we do then? Well, then we want to go with the return red. So let's set up our colon, return, and we're returning the string of red. And if it's blue, well, then let's just change it around. So let me select these two, and let me just go with blue. Then let's set up two console logs, I guess. Let's invoke getColorName, and we'll pass in color, then red, and we're going to copy and paste and set up blue as well. And everything's awesome. If we take a look at the console, yep, we have red and blue. But what if sometime later we go to a color and add green. And notice everything is valid. I'm not breaking any rules over here. The problem is going to be here. When we invoke it, this is going to fail, but the worst case is actually going to fail silently. So if we navigate right now to the browser, we can see red, blue, and undefined. Why? Well, because we're not handling the case over here. And again, this fails silently. So we set up nicely an additional enum. We correctly pass it in, and then unexpectedly, we're getting an error, correct? And if you're familiar with such code, you're probably screaming at me. You're like, hey, listen, just set up the default case and throw the error. And you're correct. Before TypeScript, that was the approach. So let's go here with default. Then we go with throw, new, error. And for now, let's just take a look at the color. And all of this is nice, but keep in mind, this is again happening at runtime. So yeah, we have this default case where we throw the error if none of the conditions match. But I actually would like to do that while I'm writing the code, not when my application is running. So we can definitely keep this one over here. But a TypeScript approach is to come up with the variable. And I'm going to go with at build time here. And let me add another comment. And in here, I'm going to go with at runtime. And in here, we want to set up another variable. Now, the name is really up to you, but I'm going to go with unexpected color. The type will be equal to a never. And now we'll assign it to the color. And notice how immediately TypeScript complains. Why? Well, because initially we only had 2 values. So if we go back to this one, everything is correct. I only have this yellow squiggly line, which is totally okay. But if I'm going to add this green one, then right away TypeScript is going to yell at me because now I have one more condition. And of course, we already saw that if we don't handle it over here, then essentially we will throw that error at runtime. So what's the solution? Well, we go with another case. Let's go with color, green, and same deal. Just want to go with return and return a string. In this case, it's going to be a green one. And as you can see, the moment we set up our case, TypeScript doesn't complain anymore. Everything is fine because we have 3 possible enums, and we're handling all of those cases in our get color name as well. So essentially, this is a great benefit for us where we can check for those potential errors at build time instead of just runtime. Okay, and up next, let's switch gears and quickly discuss modules in TypeScript. Now, if you are familiar with how ES6 modules work, most of the things we're about to cover will be a nice review. But when it comes to modules in TypeScript, there are some gotchas we need to be aware of. Let's start with the main one. You see, by default in TypeScript, files are not modules. They're actually treated as scripts in a global scope. So what does that mean? Well, if I go to a source, come up with a name, for example, actions ts, come up with some random variables. One is going to be Susan, then second one is going to be something. So let something is equal to something. If I create another file or in the tutorial, try to use the same variable name, I'm not going to be successful. So TypeScript is actually going to complain. So it doesn't treat this file as a module. So whatever I set up in my files is actually put in a global scope, which obviously limits the variables I can use. I have Susan over here, and I also have Susan in the actions, and therefore TypeScript is complaining. So pretty much think of it this way. Everything that you put in the files, by default, again, we'll fix that in a second, but by default, is actually put in the global scope. So in order to fix it, we have two options. We can go to tsconfig and essentially set the property, or we can add the export and import. And the moment we add export and import, then they're treated like typical ES6 modules. Now, also, don't be surprised about this gotcha, where, let's say in tutorial, you'll try to come up with the variable with the name of name, and you won't be able to. Even though technically in actions, we don't have this value over here. You see, such name is used in declaration file. Again, something we're going to cover a little bit later. And again, we have this name collision because TypeScript doesn't treat this file as a module. So essentially, unless we change that, there's going to be some keywords that we cannot use. And this was super confusing to me in the beginning, because as I started learning TypeScript, I wanted to use this name variable, and I got this red squiggly line. And I was like, what's happening over here? Why I cannot use this name one? I mean, there's technically no error. And again, let me repeat for a third time. It's because by default, TypeScript is going to essentially treat the files as just scripts in the global scope. So once we know the issue, how we can fix that, like I said, we have two options over here. We can either go to tsconfig and add the property. And you know what? Let me just first showcase how this would work with import and export. If we add export or import statement to our file, immediately TypeScript is going to essentially treat this as a module. So for example, if I'm going to go back to a tutorial, and if I'm going to go with import, and I believe this one was the named export. So we want to go with something from the actions. Everything is awesome. So notice we don't have the issue anymore with the global scope, correct? So now these ones are scoped to tutorial, and then these ones are scoped to the actions. Hopefully that is clear. So this is one approach. Now, what if I don't want to add import and export, like force it in a way? Well, then we can go over here to tsconfig, and we're looking for the property by the name of module detection. And we want to go with force. So by default, it's going to be set to auto, but we want to force it. So in this case, even if there is no export statement, everything is going to work. So notice, now of course I have different complaint because I'm importing from the actions and there is no export. But the moment I save, I can use the name, even though it's technically used in declaration file, which was the issue before. And I don't have this name collision with actions anymore as well. So I have Susan over here, and the same is in actions. Again, few approaches. We can either add the property in tsconfig, or if we add import and export, then immediately TypeScript is going to treat it as a module. Okay, and once we're familiar with the main gotcha, let's just see how we can use ES6 modules in TypeScript. And like I mentioned before, if you are familiar with the main concepts, this is just going to be a nice review. Now, before we start typing away, I do want to mention one property in the tsconfig, which is module. And at the moment, notice how we have the value of ES next. Now, this property controls what module syntax is set up in the output code. So effectively, once the TypeScript is done compiling our code. So if I navigate to a playground, notice I have my export statement over here where I'm exporting some function, and this is going to be the result. Now, if I go to tsconfig and change from ES next to, for example, CommonJS, and as a side note, if you're not familiar with CommonJS, it used to be the main module syntax in Node.js, but even Node.js is right now slowly but surely switching to a ES6 module syntax. And notice the moment we change it, actually, this will be the output. So this is a CommonJS syntax. So if you ever have a use case where you want to use different module syntax in the output code, just look for the module property, something I wanted to mention. And now let's just go to actions and set up few values we want to export. And then in tutorial, we will import them. Again, just to have a nice review how the ES6 modules essentially work, just so you can see that pretty much the idea is exactly the same. First, I want to go with some kind of function. I'm going to go with say hello. Let's set up name equal to a string. And you know what? I'll also say that we're not returning anything from this function. In here, we're going to set up a nice console log. We're going to go with hello. And let's access the name. So nothing really groundbreaking. Then let's also export let person is equal to Susan. And let's also set up a new student. So this will be my object, and there's going to be a type for this student. So new student. I don't have the type yet, so let me just type over here Peter and age. Let's set it equal to 24. And you know what? Let's do set up the type, because I want to showcase how we can nicely export the type. So for now, let's just go with type student and name is equal to a string. Then age is equal to not string, sorry. I'm going to go with number, and then new student is going to be type student. And now, since I already have two named exports, I just want to showcase how we can do the default one as well. So we're going to go with export default, then new student, and essentially call it a day. So now I want to navigate to tutorial, and one by one, let's grab all of those values. Since I have the default export, I'm going to go with new student, which is coming from the actions. Of course, we can use a different name, but I'm not going to do that. And then for the name ones, we're going to go with say hello, and also we'll set up the person. 1 second. Yep, I want to save. And let me open up the tutorial over here. So these are the things we're importing right now. Let's invoke say hello. We're going to go TypeScript. Okay, good. Then let's log the new student and also a person, just so we can see whether we're getting the correct values. And then we'll talk about the types and how we can export them. So hello TypeScript, I have Peter as well as the Susan. So everything works as we expect. And as far as the types, yes, we can nicely export types as well. So in here, I can go with export, then type student, and then back in tutorial. I have a few options. I can either go here with the student. Notice how I'm getting right away a nice suggestion. Or we can also add over here this type. Again, this doesn't change anything as far as the functionality. It's just a common approach to signal that this is a type we're importing. So this clearly signals to me that, hey, this is a type that I can use in this file. So for example, I can go here with const another student, set it equal to my student type, and let me add different values. So this will be equal to Bob. Let me add an equal sign over here, comma, and we're also going to set up the age of 23. And then if I log another student, we can clearly see that we don't have any TypeScript errors, and then in the console, we should have the correct value. Now, $1 million question, what is the correct quote unquote approach? Should we set up the types in a separate file and then import it, or we keep it in the file where we're actually using the type? And as always, the answer is probably not something you're looking for. It really comes down to your preference. Yes, definitely. You can set up over here a new file, call it types, TS, and then pretty much every time you have a type in your project, set it up in a types, and then import in all the files where you're using that value. It's definitely an option. You can definitely do that. And another approach is to keep the type in a file where you initially are using it. And then if you ever have a use case, like in our case in tutorial, you export and then grab it in tutorial. And a common scenario is that you initially just set up the type in the file. And then if you see that you are reusing it all over your project, then yeah, at that point, it kind of makes sense to keep it in one place, since the imports are going to be easier. You won't have to think about, well, where is the actual type located? But again, as always, it really comes down to your preference. All right, and while we're still on the topic of modules, let's also see how TypeScript treats JavaScript files. So remember at the very, very beginning of tutorial, I mentioned that whenever we work with TypeScript, in our case, since we're working with JavaScript files and React files, we need to stick with either .ts extension or tsx extension. And now let's see how TypeScript is going to treat the file if it's just a JS extension. So let's say I'm going to go with source, and we're going to create the example JS. And let's go with export, some value that is equal to some value. Everything is awesome. I'm just missing over here the keyword. In this case, I'm going to go with let. And now if we go to tutorial, what do you think is going to happen? How do you think TypeScript is going to treat this file? So let's go with import, some value, and it's coming from, and I don't see essentially it in my suggestions. So I can try to force it. I can say over here example JS, but I'm not going to be successful. So effectively, TypeScript is complaining that it couldn't find the file. Now, the reason for that is because it's not a TypeScript file. So here's the thing about TypeScript. It pretty much needs to know everything about your project. And this is something that we're actually going to come back to when we start working with the third-party libraries in our project. Essentially, when we start using the code that's coming from somewhere else. So as far as TypeScript is concerned, no, we need to set this one up as a TypeScript file, so then it clearly knows, well, what is the shape for the data we're getting? Because at the moment, TypeScript is like, hey, I don't know, what are you getting over here? I have no info on this some value. Now we can force it. There's a property we can add in the TypeScript config. Just keep in mind that TypeScript's ability to infer the types, it's not going to be as robust as when we're working with the TypeScript file. So yes, we can navigate right now to tsconfig. We can look for compiler options, and we can go with allow.js, and essentially we can set it equal to true. Now we do need to add a comma over here. And now everything magically works in our tutorial. So essentially, TypeScript can infer that some value is actually a string, but just be careful with such approach. Effectively, since we're working on a TypeScript project, yes, we do want to name our files TS, because then TypeScript is going to know that it's a TypeScript file, and it's going to have the info on the shape of the data. And if you'll just set up JS file without making any changes to the tsconfig, try to run it, TypeScript will complain. Basically, it's going to say, hey, listen, I'm not sure. What are you exporting? What's happening over here? I'm not okay with this. So let me remove and delete this import as well. And with this in place, now we can move on to the next topic. And up next, let's explore the type guard options available in TypeScript. Basically, my goal was to gather all of our options in one place. And since we already discussed most of them throughout the course, this section will primarily feature challenges. So if you're interested, read the steps and attempt to complete the challenge before watching the video. Also, for some challenges, I already provided starter code, so we can spend more time on the type guard concepts. And we're going to start with the good old type of type guard. And this is going to be our starter code, where we have a type. It's either string, number, or Boolean. We assign it to a variable, and then we just invoke math.random. And then depending on the random value, if it's less than 0.33, then the value is going to be hello. If it's bigger than 0.33 but less than 0.66, then it's going to be a number. And if it's actually bigger than 0.66, then it will be a Boolean. And our goal is to set up a function. In my case, I'm going to call this check value that takes in one parameter value, and the type will be this value type. And inside of the function, effectively, we want to check for all of these conditions for the string, number, and Boolean. And based on that, we want to do something. Again, it doesn't really matter what we do as far as the functionality, but we do want to set up those type guards correctly. So let me just take the starter code just so we can spend more time on the actual function. Let me set it up here in tutorial, and let me start working on the function. So we want to go here with function, then check value. This will be looking for the value parameter, and I'll right away set it equal to a value type. Now this function is not going to return anything, at least in my setup. And then let's just set up those type guards. And remember, one of the most straightforward type guards we have is type of. And then we have a bunch of possible values. So if I go here with if, then type of, I'm looking for my parameter, and I set it equal to. And in here, we should at least get a list. Now, the reason why we don't have the list is because I have 3 equal signs over here. So we have this big int, Boolean function, and you can read the rest. So let's start with the string one over here. And I guess since people are tired with the uppercase, why don't we go with log and value 2, and let's try the lowercase somewhere to lowercase. Okay, good. Let's return. So we want to set up the return here. Then let's check for the number. And if we bypass both of these conditions, then logic tells us that the value is going to be Boolean. So I guess, you know what? In order to speed this up, I'll just copy and paste. In this case, I'm not looking for string. We're looking for number. And then we want to go with 2 and fixed. And let's pass in 2. Again, we want to return. And at this point, it is a Boolean. So let's go here with log. And let's just log the value. So let's access the value and let's invoke the function. So let's go with check value and pass in the value. Now let me navigate to the browser. Notice at this point it's a number. Then I have hello. And at this point it's a Boolean. And with this in place, we can move on to the next type guard. All right. And the next type guard we're going to discuss is going to be equality narrowing. Now, don't be scared of the fancy name. Essentially, it's just a narrowing which occurs when we use equality checks. Now, I think we'll right away also go with the check for property type guard, because effectively we'll have the same starting code. So we have these 2 types. One is dog, one is cat. And in here we have the type property, which references the actual type. And also we have the name, as well as the method, which is unique to that specific type. And essentially, our goal is to come up with a function, which is going to check for that specific type. And if it's a dog, then we bark. And if it's a cat, then we meow. And like I mentioned before, we'll pretty much work on both of the challenges since the starting code is the same. And we just have multiple options how we can narrow down one of the types. So in tutorial, I want to grab this code. Notice how we're using over here the union as well. So now we have this animal, which could be a dog or a cat. So now let's set up our function, which makes the sound. So make sound function. We're going to go with animal. So that is going to be our parameter. And that one will be equal to our type animal. And here, let's go with animal and which property is unique. Well, that will be the type one, correct? So we can just say, well, if animal type is equal to, in our case, dog, well, what do we want to do? We're going to go with animal and bark because we know that it's a dog. Now, if it's not the case, we already know that we have animal and our other option essentially is to meow. So if we go over here and just invoke the function, depending on what we're going to pass in, that's what we're going to get in the console. Now, at the moment, again, there's no functionality over here. Hopefully, it's clear that effectively we're just narrowing down the types. So this is one option we have. Also, we can check for property. And how does that look like? Well, we can go here with function, then make sound, same deal. Animal is equal to our animal type. And then inside of the function, we want to set up if, and now we're looking for a specific property in the type. Now, in our case, which one is the specific one? Well, we can actually check for method. We can take a look whether bark exists. If it is an animal, then we know that it's a dog. If not, then in our case, we know that it's a cat. So we're going to go with if and then bark in. So this is a keyword we want to use in the animal. Well, if it's the case, let's go with animal bark. And if not, then we know that it's a cat. So we can run the other method. Let's go with meow and let's invoke it. So effectively, when we have such setup, these are the options we have. Either we can check for property or a method, or if we have a property which has that unique value, for example, in this case, it's a type one, well, then we can also use the equality checks. All right, and up next we have truthy or falsy guard, and it's as straightforward as the name suggests. Essentially, in here, we just want to check for truthy or falsy value in the condition, and depending on the result, just set up the functionality. And as far as the challenge, we want to create a function. In my case, I'm going to call this print length. We're going to be looking for a string parameter. As far as the type, we're going to use the union type. So either it's going to be string, null, or undefined. And then if it's truthy, if it's a string, then we just want to log string dot length. If not, then we'll just say that no string was provided. And then we'll just test with few values. So here in the tutorial, we want to go with function print length. Let's look for string. I'm going to go with str. And then as far as the type, either it's going to be a string, either it will be null, or we're going to go here with undefined. And if we want to check for a valid string, we simply want to set up the if block and then pass in the str. So if it's truthy, if there's value in a string, then we'll end up in this if block. And as far as the logic, we're going to go with str and then length. So at this point, we know that it's a string. Now, if it's not the case, I'm just going to go with log, and let's just go with something generic. No string provided, even though as I'm looking at it, I mean, we're also going to end up here if there's no value in the string. So technically, it's not 100% correct, but let's just go with this one for now. Again, our main purpose was to set up the functionality inside of the function. So let's go with print length. Let's go with hello over here. Then let's pass in the empty string. Then we're going to go here with null. And after that, let's pass in pretty much nothing. Let's at least try to do that. Now, we're not going to be able to since TypeScript is going to complain, but let's just pass it in just for our reference. So let's say if we don't provide anything. And also at the very end, let's go with print length and set up the undefined. Now let's navigate to console and essentially notice if we provide a valid string, yep, the result is 4. So we get back this length. And if not, then we just have a list of no string provided. Again, not 100% correct technically in here. It is a string, but it's an empty one. But again, these are just minor details. The main goal of this video was to showcase the truthy or falsy type guard in TypeScript. All right, and up next we have instance of type guard, which is a way in TypeScript to check the specific class or constructor function of an object at runtime. And this is something we actually covered very, very recently when we talked about type unknown. So therefore, in this case, again, we'll have 2 examples. We will go back to try and catch. So we'll reiterate pretty much everything we learned in the type unknown video, and also we'll work on another example where we'll check for the date. So first, let's just reiterate that if we have try and catch, this error is unknown. So even though we have over here for sure throw new error, and if I pass in the message, TypeScript will complain if we'll just go with error.message. Because there's also a possibility for different type of error. Essentially, we might have an error which is not the instance of the error class. So therefore, if we do want to access the message, first we want to go with error and then instance of, and we're looking for our error class. So if it's the instance, yes, then we know that there is that message. If not, well, then we simply want to log something, some kind of hard-coded message. So let's go here with log, and then let's provide some kind of string. And we're looking for error object. And now we just want to render, I guess, the error message. So error, that message. So now we can access it. If not, well, then let's simply log something else. We'll just go with unknown error. Error and ... Again, if we navigate to the browser, if everything is correct, we should have this one over here. Why? Well, because at the moment in try block, I have try new error. Now, if I'm going to comment this one out or simply type above and say throw and some error, now I should have unknown error in the console. So again, this is something we covered pretty much a few videos ago. Now, also, we can use such setup to check for date. So we can check whether the input we're passing in is a string or it's actually the instance of the date object. So let's set up our function. We're going to go with check input. And in here, the variable name is going to be input, basically the parameter name. And then either it's going to be date or it's going to be a string. Now, from this function, we want to return a string. And now we want to check whether the input is the instance of the date object. If it's the case, then we want to turn it into a string. Now, if it's not the case, if it's simply a string, then we want to return the input. So let's go with input instance of, then data object here. And then let's use input. Since this is a date right now, we have access to all of these methods. We're looking for get full year. Let's invoke this one. And we want to turn it into a string. So notice, if I just return this one, TypeScript immediately complains because this will be a number. But we said that we want to return a string. So let's invoke this to string. So now TypeScript is not complaining. And if it's not the case, if it's not the instance of the date, well, then I don't need to do these acrobatics. I can simply return the input. So now let's construct two variables. We're going to go check input. In here, let's just pass in new date. And also, we're going to go with some random value as well. Random, and we'll set it equal to check input. And let's just pass in some kind of string. So 2020, the best year ever. Of course, in the air quotes. And let's pass in some random date. Then let's log both of these values. We're going to go over here with year and random. I'm not even sure whether we are really interested in the console, but let's just log it and notice essentially both of them are strings. And again, the instance of TypeGuard is a nifty way for us to check in TypeScript whether the object is an instance of a class or created by the constructor function. If it's the case, it's going to return true. If not, it's going to return false. All right, and up next, let's discuss type predicate function, which is a special kind of function that not only returns true or false, but also we can narrow down the type. And again, this should be a refresher because we did discuss type predicate previously. As far as the starter code, let's just grab this one and then we'll go over the challenge. So here in tutorial, I have two types. I have the student one as well as the user. Notice this property is the same. It's a string. And the only difference, well, they have different methods. So one is study and the other one is login. Then I use the type union to create type person, which can be either the student or the user. And then again, I go with my math.random. If it's bigger than 0.5, then I'll return 1. If not, well, then I'll return another one. So either this is going to be a student or a user. And effectively, what we want to do is set up our type predicate function where not only we check for specific type, but we also want to help TypeScript by narrowing down the type. And in my case, I'm going to show you two options, how we can check for specific type, but feel free to use whichever makes the most sense to you. And then after that, we want to use if else, essentially run our type predicate. And if it's true, we want to invoke one of the methods. So let's say in my case, I'm going to be checking for student. If not, then I'm going to invoke login, which is for the user. So right after the person, I'm going to go with function is student. At least in my case, I'm going to be checking for student. Again, this is totally up to you. You can check for the user as well. Now, I'm going to be expecting a person, which again can be either of them. For now, I'm not going to set up the return type. And as far as our options, well, we can use the in operator, something we talked about literally a few videos ago, where again, we're looking for something unique. In this case, either it's going to be study or a login. And we just go with the method name, then in, and then the person, since that's our parameter. Or we can also use the type assertion, where we assert that person is going to be a student. Then we invoke the study method, and then we check whether it's defined or not. So again, this part is totally up to you. For now, again, we don't have any returns. I just want to showcase that if we go here with return and then study, again, our method in person, this will return either true or false. So either this method is in the type or not. Now, if it's the case, then we want to go with person is the student, correct? Because at that point, TypeScript knows for sure that the instance is the type of student. And if that's the case, then we can use the study method. Now, alternatively, we can use this approach where we go to return, then person, and we assert that it's a student. Now, what is the method student has? It has the study one. But again, just because we're asserting doesn't magically make this person to be a student. And therefore, in here, we still check. We say, okay, we assert that person is a student. We know that there is a study property, but it also can be undefined. So it's only a student if it's not undefined, like so. So those are the two options you can use over here. And now let's set up the if block. Let's say, well, if it's a student, then let's pass in the person. What do we do next? Well, then we can use essentially our method, correct? And if it's not, what options we have? Well, then it's a user, correct? So we go here with person and then login and also invoke it. Again, a very fancy name, type predicate. Effectively, just remember the is keyword and remember the fact that not only we're trying to check for a specific type, but we're also helping TypeScript to narrow down that type. Okay, and before we move on to the next topic, I also quickly want to show you one gotcha, and this involves type never. Now, technically, this video is optional. If you're not interested, you can just move on to the next video. But I simply want to showcase that if we hard code the person to be a specific type, TypeScript is going to yell at us. So in here, yes, we are setting up that person randomly, correct? So we have our random person, and pretty much depending on the value, well, we either return a student or a user. Now, if I set up my person differently, let's say if I comment this one out, again, I'm going to go with person. I'll say that this type is actually a person, and then I'll hard code. So I'll say name is equal to Anna, and then since I'm creating a student, I'm going to set up my study method. So I'll come up with my function, and I believe it doesn't return anything. So I'll just go with log and study dot dot dot. Okay, let me fix the typos and all that. So now I have this person, but I'm hard coding. This is not anymore random. Notice TypeScript essentially right away yells at me. It says, well, there's no way this person can be a user, the other type. Why? Well, because you hard coded to be a student. So yeah, I can still check whether the person is student. So type predicate still works, but in the else block, you'll notice that person is never. And this brings me back to the point that I was making in the type never video. Essentially, if you have the scenario where type is equal to never, you'll just have to go back to the initial place where you're setting up the variable and also start checking your conditions. Because effectively in here, TypeScript just says, hey, listen, there's no way that person can be a type user because you hard coded to be a type student. Now, what's interesting, if I change this around to a login, now the person is actually a user, correct? So now I'm hard coding to be a user. So I have my type predicate. I check in my condition. It's not the case. And now we can successfully get to else. But if I hard code my person to be a student, then there's no way for me to get to this else block. Hopefully it's clear. And now we can move on to the next topic. All right. And up next, let's discuss discriminated unions. And also, let's recall how we can set up the exhausting check using type never. Now, again, I know that the name discriminated union most likely sounds pretty scary, but essentially it's just going to be a property which has a literal value. Now, as far as the star code, this is what we have over here. So we have two types. One is going to be increment action. Second one will be decrement action. Both of them take in a number, the amount timestamp, which is going to be a number. Again, this is totally random. And the same goes for user string. This is totally random. And then we have a type by the name of action where I use the union type. And I just use both of these types here. So either it's going to be increment or decrement. And then I will set up a reducer function, which is looking for two things. It's looking for the state. So again, this is just going to be some random number, and also the action. So what do we want to do? Do we want to increase the number or we want to decrease? So let's start setting up, and in a process, you'll see why we need the fancy discriminated unions, which again is just a property with a string value. So for starters, let's go here with new state. And you know what? I haven't set up the function. So maybe let's start with this one. So we have a function looking for state, which will be a number. So some kind of hard-coded number, and then also the action. So whether we want to increase or decrease, and by how much. This is the amount over here. So if we want to increase, then by this amount, and the same goes for decrease. Now, I'm not going to set up again anything as far as the functionality. I simply want to go with reducer. So that's the function. And of course, I forgot to add the name over here. My bad. So we're looking for reducer. Then as far as the initial value, again, we're just hard coding something random. So I'm going to go here with 15. And then when it comes to action, well, now I'm going to pass in the object. So either it's going to be increment or decrement. And in this case, I'm going to hard code that. The user value will be John. We don't have the type yet. So let's just go here with amount of 5 and then timestamp. Well, let's set up 1, 2, 3, 4, 5, 6 or something along those lines. And now let's discuss why do we need the discriminated unions in the first place. Well, we have two types. And how are we going to check for a specific type? I mean, we cannot use type off. We cannot use in. We cannot use, instance off or any of the things that we covered previously. Why? Well, because pretty much they're the same, correct? Now, they do have different meaning. One is going to increase this state over here, and the other one is going to decrease. But in the reducer, how am I going to check for that action? And this is where the discriminated unions come into play, where we'll have this unique literal value. How's that going to look like? We'll navigate back to increment action. And yes, effectively, you'll just add here whatever property name you want. In my case, it's going to be a type, and it's going to be equal to increment. And now we want to do the same thing for decrement. So instead of increment, we want to go with decrement. So now in the reducer, we want to set up a switch statement where we're going to check for the type. If it's increment, then we'll increase. If decrement, then we'll decrease. And also, let's just recap how we can set up our default case with the help of type never. Now, TypeScript is complaining because I'm not providing a type over here. So we do need to go with one of them. In this case, I'm just going to go with increment. Again, it doesn't really matter since our main focus is on this logic here in the reducer. So first, let's set up the switch one. And we're going to be looking for action type. That's the property we're interested in because it's unique to each type over here. And again, if we have 10 types, yeah, we'll pretty much have to set up the type for all of them and provide that unique value. Then we want to go with case. And in this case, I'm going to go with increment. And as far as what do I want to return from the function, well, let's go with number. So we're going to go with that initial value, basically a state, and we'll add action dot and the amount that I'm passing in. Now we want to do the same thing for the decrement, correct? So let's just change it around. And again, let's just recall the issue with the setup. If we add some other type to this action, well, it's going to fail silently, correct? And therefore, we want to set up the default case. And we want to assign the action to some variable which is type never. Because in that case, if there's some other type over here, it will immediately be assigned to that variable, and we cannot assign to type never. So let's just go over here. Let's say default. That's going to be our default case. Let's also throw, I guess, quite typical scenario. So throw new error, and then I'm going to set up the template string. And in here, essentially, let's set up unexpected. For some reason, this is the biggest challenge as far as the spelling. Unexpected action over here. Type will be equal to never, and we'll assign it to an action. So if actually action is never, if we have handled all the possible cases, we're good to go. But if there's going to be some additional case and we're not handling, right away TypeScript is going to yell. And in here, let's just type unexpected action, and then let's access the unexpected action. Again, the point really here is not to run the code. I mean, we're mostly focusing just on the logic over here in the reducer. So this is how we can set up the discriminated unions and exhaustive check using the never type in TypeScript. Okay, and we have successfully arrived at the most complex and confusing topic in TypeScript, which is none other than the generics. In short, generics allow us to write, for example, functions with any data type. And you can think of generics as a variable for types. Now, I'm not going to sugarcoat it. It's not an easy topic. The good news is, though, that most likely in the beginning, at least based on my experience, you'll primarily use generic functions or interfaces created by somebody else, whether it be the creators of TypeScript or developers of some third-party library. And in that case, you'll only need to remember one concept. Every time you see those funny-looking angle brackets, think generics. And let's begin by taking a closer look at the arrays in TypeScript. So at this point in tutorial, we should be already familiar with the syntax. So we have 3 variables. The values are arrays, and here we just say, well, what is the type for the array? And as we're looking at this code, and we're just focusing on TypeScript, so please don't tell me that the answer here is the keyword let. As you're looking at this code, what is the one thing that doesn't change? So what is the one thing that stays the same? And it's kind of pretty obvious, but I do want to start from this point. And the answer is following. Notice how the type is changing here all the time. But we're always getting this array. Now, of course, we can make this complex. We can provide our own type. We can provide the union type, whatever. That doesn't change the main idea. We're always getting back this array. And not only that, we can pretty much pass here whatever we want as far as the type, correct? So it still needs to make sense as far as type. And we'll always get back the array. So it's not like I need to go somewhere and look for string array. No, I don't have such type. I literally just have this one universal one that I can use. Because if you think about it, how difficult it would be that not only we need to remember, but also to construct such types. Let's say we'll need to have one numbers array type, then one Boolean one. And I can go on and on and on and on. And actually, we can examine what type are we getting back over here. So let me remove this silly text. And now let me right click. Then we want to go to type definitions. And yes, I know we haven't covered the declarations yet. Don't worry, all of that is coming up. And you know what? I'll actually pick the third one because it's going to be easier for me to show you. So let's go here to type definition. And then we're looking for this declaration one. So we're looking for lib es5d DS. Again, we haven't covered them, how we have access to them and all that. All of that is coming up. For now, let's just focus on this code. So notice we have this interface. Again, something we should be already familiar with. Remember, we use it to provide shape of an object. The name here is an array. And check it out. We have the funny looking angle brackets. And inside of it, we have this T. Now, right away, I want to mention T is convention. You can call this shake and bake. You'll see that in a second once we set up our own generic interface or function or whatever. Basically, this represents the notion that this type can be anything. So I can pass here the string, number, boolean, my own type, you name it. And every time, not only I'm going to get back the array with that specific type, I'll also get all of the properties and methods that we know already exist on array. So what am I talking about? Well, we know that length is part of the array, correct? We can just call array.length and we're good to go. So notice we have over here this method. So we can definitely use it. And then let's keep on moving. And we'll see, again, all of the functions we're already familiar with. But here's the kicker. For example, pop. Now, if you're not familiar, this essentially is a function which removes the last element from the array and returns it. But now notice, what is the return here specified for the pop? It's not string, number, or boolean, or your own type. No, it's basically this T. It's basically this generic. So whatever I pass in, whatever array I construct, well, I want to remove that last type, correct? I'm not saying, hey, this is the array of strings, and now I need to call specific method to remove the string. No. Basically, whatever type we use to set up that array, well, that's the same type we remove. And notice how essentially we're saving a bunch of the code, because imagine if you would have to set up such interface pretty much for any type that we can pass in the array. I mean, you'd go most likely insane. So that's why we use this variable where we say, okay, you can pass in any type and it's going to get treated the same way. We'll create the array the same way. We can call the methods the same way. So none of that changes. So whatever type we pass in, well, that's the type we're going to use to operate. So hopefully, again, this is clear that it definitely makes sense in a lot of instances to set up the generic one, because you don't want to set up essentially the interface for every possible type that you can pass into array. And now knowing this, we can actually take a look at the second approach we have to construct the arrays. Now, I can tell you right away that just because we know the generics, you won't have to use the syntax. So you can still use this, I would say, more user-friendly syntax, but I do want to showcase that since this interface is an array, we also have this option. So now let me comment, I guess, these ones out. You know what? Let me start everything from scratch. So I want to go here with let, and again, I'm going to call this array1. And then as far as the type, sorry, I'm not going to go with string. I will go with array, and then let's pass in the string. And now, as far as the result, well, that one is actually exactly the same. So I'm just saying, yeah, it's going to be an array of strings. And again, this doesn't change. The only thing that's going to change, the type that we're passing in. So if we pass in the string, and of course, we'll get back array of strings, as well as all the methods that we can call. So if I call the pop on this one, on array1, guess what? It's going to remove the last item, and the type is going to be string. And of course, we can repeat the same for number and boolean. And with this in place, now we can move on to the next topic. All right, and once we're familiar with the main concepts, let's construct our own. Let's start easy. Let's just go with the function as well as the interface. So here's the goal. We want to create a function which is going to take any type and return the same type. So one approach could be following. We can go with function. Then let me go with create string. As far as the argument, I'm going to call this string. Basically, I'll give it a type string. It returns a string. And then from the function, we return the argument. Now, everything is awesome, but we pretty much need to return the same function for any type. So we need to create one for the number, for Boolean, and rest of them. Now, I'm not going to create function for all of the types, but you know what? Let me just showcase with the number. So let's say if from this function we want to return a number, this is what we'll need to do. And as you can see, this gets annoying pretty fast, correct? And we only have two types. So this is what I was mentioning in the previous video. Imagine that array interface, if it's not a generic, but pretty much you'll need to copy and paste. And everywhere where you have a string, you'll have to change it to number and Boolean and then rest of the types. So what's the solution? Well, this is where we use the generic. I will leave this one for your reference. Or you know what? Actually, you have it in a README. My bad. Let's start from the scratch. I think it's going to be better. We're going to go with function. Then let's call this something generic. And I think generic function is good enough. And we will set up the parameter. We will set up the logic. Now I want to set up the variable for my type. So instead of hard coding, instead of number and string, I'll say it can be any type, and both my argument as well as what I'm returning are going to be that type. So we go here with this angle bracket. Like I said, you can call this shake and bake. Just make sure you use the same name. And again, the convention is just to go with T, which stands for type. So we go here with T. Then we say that, yeah, argument is actually going to be this type. So I'm not going to say that it's a string, number, or whatever. No, whatever type we have over here. And as far as the return, we'll also go with the T. This is what I'm returning from this function. And now we just need to set up the logic where we return the argument. So now we can go here and set up some string value, set it equal to generic function. Then, since I'm creating a string value, this is the type I want to pass in. And then I just want to provide a string. Let's save this. And now I can do the same thing for the number. So instead of string, we're going to go with number. And instead of type string, we'll set up the number. Now, it does need to make sense as far as the argument. So it's not like I'll randomly pass in the string. As you can see, TypeScript is complaining. And we set up over here the number. So now we can use this function with any type, even the ones that we set up ourselves. So this is not limited anymore to one specific type. This right now is generic function where we can pass in any type and we'll get back the same type. And while we're on topic, let's also take a look at the interface. So I'm going to go with interface, and let me right away call this generic interface. Same deal. If we want to set up a generic one, we already know that we need to go with angle brackets. Let me stick with convention with the T. And then there's going to be a value property. The type will be whatever we're setting up over here as T. That's why they need to match. And let's also set up the get value function, which is not going to take any parameters, but it will return the same type. And now let's create a new instance. I'm going to call this generic string, which is somewhat funny, but let's just stick with that one since I have that in a README. So we're going to go with generic string. We go here with generic interface. We say that, yep, as far as the type, it's actually going to be a string. And now inside of our instance, of course, we need to follow the same rules. So the value I'm going to be setting up has to be a string. So we'll go here with hello world. And then as far as get value one, well, let's just return this dot value. Return this dot value. Let's save it. And once I save, I have right now the string instance from my generic interface. So this is how we can construct our own generic functions as well as generic interfaces. All right, and before we start working on the more complex examples, I do want to showcase something. Most likely, as you're looking at these first few examples, you're like, I mean, this is ridiculous. What is the actual need for such functions? I mean, I do understand, yeah, there's angle brackets. Yeah, I can use this T and it's going to work with any type. But in reality, this is just silly. Okay, hold that thought. And let's just set up a async function. And remember, in JavaScript, what do async functions return? They return a promise. So let's go here with async. Let's call this function. I'm going to go with some func. For now, let's not worry about the return. Or you know what? No, let's set it equal to a string. I do definitely want to showcase something. So we right away have the error. This is something we're going to deal with. For now, let's just return and hello world. So technically, it's kind of correct. We're returning a string. So what is TypeScript complaining? Well, again, async functions return what? They return a promise. So now let's do the same thing like we did with the arrays. Let's look at the type that we're getting back. And hopefully in the process, you'll see that even though this might look somewhat silly, essentially this is the foundation that you'll see over and over and over in documentation. So if I'm going to go here with result and some func, and we'll take a look at the result. I mean, it says that it's a string, but we clearly have this issue over here. And notice now we have this. The return type of a sync function or method must be the global promise. Again, funny looking angle brackets. Type, did you mean to write promise? And interesting. We actually have the generic again. So you know what? Let me remove the return type for now. I'll rely on TypeScript to infer the type. And now let's click on the result and type definition. And same deal. Notice we have over here this interface. The name is promise. And again, it's a generic. And yes, it has a little bit more code. But notice the general idea. Effectively, we just get back this promise. And in there we have the type. So the point is that every time we have this async function, we do need to set up promise as a return type. And we just need to remember that it's a generic. So instead of typing string like I was doing before, we just go with, okay, we're returning a promise, but since it's a generic, we need to specify the type in the angle brackets. So again, the main point is that, yes, I know that this might look silly, but keep in mind that this is going to be the foundation that you see in documentation. As silly as it looks, it actually handles all of the cases that we're interested, because in here, I can return whichever type I need in that particular instance. And I simply just need to provide the value over here in the angle bracket. So let's say if I'm going to go with 234 or whatever number, then it's going to complain. So now I just need to go over here and say, yeah, I will return a promise because it's a sync function, but the type in this case is going to be a number. So yes, even though our first two examples might look super silly, they use the same concepts that you're going to see later in declaration files. And with this in place, now we can move on to the next topic. All right. And once we're familiar with the fundamentals of generics, let's work on a tiny challenge where we want to set up a function. In my case, I'm going to call this create array, which takes in two things. It takes the number length. So that just controls the length of the array. So if I pass here 3, then I'm going to have 3 items. If I have pass here 15, then obviously it's going to be 15. And then the second thing is going to be the actual value. So if I pass in the string, then I should be getting back the array of strings. If it's going to be number, then it's going to be an array of numbers, and hopefully you see where I'm going with this. And I guess let's start again by hard coding. Hopefully in the process, we'll see why we want to use generics. So first, let's create a function. I'm going to go with generate string array. Like I said, we're looking for two things: length, which is going to be the length of an array, and also, well, what is the actual value? And as far as the type, I'm going to go with string. Now, from this function, since I'm taking in the string type, I want to return a string and array. Now, when it comes to logic, I want to create the result variable. This will actually be string and array. And for now, it's just going to be empty array. But yes, we're going to store over here the strings. Okay, good. Then let's assign result to array. So again, we can use our object. In there, first we want to pass in the length. So how long is going to be the array, how many items we're going to have over there. And then let's just call the fill method. So pretty straightforward. Whatever value we pass over here, we'll add to our result. So we'll call fill and we'll pass in the value. And then from this function, since I want to get the array of strings, let's just go with the return and a result. Let's save it. And again, everything is awesome, but I need also the same array for numbers, booleans, or any other type. So now we just need to make this function generic. Or you know what? Let me just quickly showcase that the code actually works. So generate string array. How many items? I don't know. Let's go with 6 because I have the example of 3. So you probably don't believe me. Let me go over here and notice everything works. So I get back my array. It's type string and I have 6 items. Okay, beautiful. So now how I can make this function generic. And again, most of the logic is actually going to be the same. The only difference everywhere where we have the string, we just want to convert it to a generic. We want to convert it to that variable. And as a result, we'll be able to pass pretty much any type. So let me copy and paste. Instead of generate string array, we'll just call this create array. Create array. Length stays the same, but this one actually is going to be equal to a t. And now we want to set up that angle bracket. So again, we set up this variable for the type and we pass here dt. So now everywhere where we want to reference the type, we'll use the t instead. So in here, instead of string, instead of hard coding that, we'll go with array and pass in the t. Then instead of strings, we're going to say that, yeah, the result is going to be just an empty array of this specific type. This doesn't change. This doesn't change. Now we just want to invoke it and we'll do the same thing. Like in the README, we're going to go with strings, then create array. We want to provide a string over here. And as far as the value, let's go with 10. The more, the better, I guess. Let's copy and paste and let's call this numbers. So numbers, this will be a number. Let's go with 15. And as far as the value, I'm going to go with 100. So now we just want to log both of these values. Array of numbers and strings. Strings, let me move this one up. Just because, don't ask me why. And if everything is correct, this is the result we should see in the console. So this is how we can create a function which takes any type and returns an array with specific length of that particular type. All right, and up next, let's see how we can set up multiple variable types. And in my case, I'm going to use the function example. So we want to set up a function called pair, which takes in 2 parameters. However, the type is not going to be the same. And then from the function, we just return both of those parameters. But again, we need to return the same types. So let's go here with function. Again, the name will be pair. We start with our good old T, so we already know that one. But if we have multiple variables like this, we just add a comma and then provide the value. Again, it's a convention to go with TU, and then if you have more parameters, just follow the logic over here. But you can name them, of course, differently as well. Then we're gonna set up our param, I guess, 1. So this one will be equal to T, and then param 2 is going to be equal to U. Like I said, from this function, I want to return an array, and I want to keep the same types. So this will be equal to T and U. And let's just set up the logic where we have param1, comma, and then param2. So now let's invoke it, and if everything is correct, we should get the correct result. So we're going to go with the result. That one is equal to pair. And then I'm going to go with number and a string. Let's go with 1, 2, 3 and hello. And check it out. TypeScript is not complaining. So if you have more variable types, add a comma. And then the common approach is to go with U and then rest of the letters that follow you if you have more parameters. Or you can come up with your own names. Just make sure you use the same name in the parameters as well as the function logic. And up next, let me quickly show you that TypeScript can still infer the type even if we don't provide the types here in the angle brackets. But just like before, we need to be careful. Yes, if you are expecting to get back the number and a string, everything is awesome. But if by mistake you pass in some other type, it's not like TypeScript can magically figure this out. So therefore, if you don't pass in the types you're expecting, just make sure that you pass in the correct values. Hopefully that is clear. And as a side note, this is something that we're going to see later when we start working with React, where use state hook actually is a generic, which again, if we think about it, kind of makes sense, right? I mean, we can pass in string into use state, same how we can pass in the array. So this use state hook needs to accept whatever value we pass in, whether that is a string, number, all the way to array of objects. And essentially, since it's a generic, we can technically bypass the angle brackets. So let's say if it's a string, I just let TypeScript to infer that, yes, for sure, it's going to be a string since I'm passing in the empty string. But for example, when we're going to be setting up the arrays, TypeScript is going to complain. And at that point, we'll need to specifically let TypeScript know, hey, is it going to be an array of strings, numbers? And in this case, I'm just coming up with some fake product type. So hopefully that is clear. Yes, TypeScript can still infer the type. Just be mindful when you use such approach. And also, I want to show you how we can set up the constraint on a type. Essentially, I can limit the type options I can pass in. So let's imagine this. I have a function of process value. Function process value. And in here, I have my generic T. But I only want to limit this to a string. So the keyword we're looking for is extends. And then in here, we pass in the specific type. Now, in the following video, I'll show you a different example. So don't think we can only use it here with primitive types. But let's just start nice and easy. So we're going to go over here with the string. Then we want to set up a parameter. Again, I'm going to say that it's equal to a T. And you know what? Let's say that we're also going to return it. So in here, let's log it. Let's say value. And let's also return the value. Let me save it. Let me call process value. Now, in this case, I'm just going to infer the type and I'm going to say hello. And as you're looking at it, you're like, well, I mean, at this point, we can simply set up a function without the generic, correct? So I can simply say that, yeah, I'm going to be passing in a string and I'm expecting a string back. And you're 100% correct. So with this particular example, I mean, there's no real benefit of setting up the type and then extending it only down to a string. But again, it is an option, and in a following video, you'll see a more complex example where actually it definitely makes sense. Now we can also use the union type. So effectively, I can go with the string or number. And at this point, if I call in process value, I'm able to pass in the number as well. So for example, I can go with 12. Now, if I'm going to go with process value and then pass in, I don't know, true, then of course TypeScript is going to complain because we can only pass in a string or a number in this generic function. And once we're familiar with the extends keyword, now let's see a more complex example where we have our own types. So let's imagine the scenario where I have type car, two properties, branded model, both of them strings. Then I create the instance. Same with product, only in this case the properties are name and price. And I have a string and number. Again, I create the instance. And the same with student. So the property is the same. The first one, name, it's a string. But then the second one is age. And in here, I want to come up with a function. I guess I'm going to go with print name, because why not? Where I just want to access the name property. So let's go with our function, print name. Then let's provide the type. The generic in this case, we're going to say that input is also going to be t, and we're not going to return it, so I'm going to go with void. Now, even if we just try to console log input.name, TypeScript is going to complain. Why? Because it has no guarantee that there will be that name property. So in this scenario, we're not going to extend to a string. We actually need to look for the types which have that name property, correct? And in our case, we can either go with the student or with the product. We just set up over here extends, and we go with student. So just like before with string number, boolean, or whatever, we can use our own types as well. So now if I go and invoke the print name in here, and if I'm going to pass in the student, everything's going to work. Now it's going to fail if I pass in the product, even though it has the name, correct? Let's try it out. So I'm going to copy and paste. And once we invoke the, not print name, sorry, we're looking for product. Of course, TypeScript is going to complain because the type is product in this case. So yes, we can still use over here the union type and pass in the product, but there's actually a better way, because if we think about it, what are we going to do now? We'll look for all of the types where we have the name, and then essentially just use the union type and add it to extends. I mean, technically it's an option, but like I mentioned, there's actually a better way. And that better way is that we can set up an object. We can set which property we're looking for, and then we can pass here in the extends. Now we can set it up as a separate variable, or we can pass here directly. So instead of passing in my student or product types, I can simply set up an object, and I can say, hey, listen, I'm looking for name property, and it has to be a string. So now TypeScript is smart, where it says, okay, so student, yeah, it does have a name, so everything is going to be fine. Same with the product, but if I'm going to try to call it with a car, it's not going to work because there is no such property. So if I pass in this instance, notice essentially it complains that the name property is missing in the car. So this is an interesting way how we can use extends, not only with the primitive type or our own custom type, but also we can simply narrow it down to the shape that we are expecting. Okay, and at the very end of generics, let me show you how to set up default type. Just please keep in mind that it's not going to be super useful in our examples, since we're hard coding all of our data anyway. Basically, they're going to be far more useful when we don't know what is going to be the shape of our data. So let's imagine we have interface. It's going to be a generic, and I'm going to call this store data. I'm going to say that I'm expecting T, and then inside of it, there's going to be a data, and it's going to be equal to an array of types. So whatever we pass over here. Then let's set up store numbers. So store numbers, and first let's set up the type. So we go with store data, then number, and then we set it equal to data. And in here, since I want to store the numbers, I'm just going to go with 1, 2, 3, and 4. Okay, so this works. But what if, let's say, I have some random stuff? What if I don't know what I'm going to have in the array? Well, let's try it out. So we're going to go with random stuff, set it equal to store data. For now, we're not going to pass anything in. We're going to go with data, and then we'll set up some random stuff. So I'm going to go with my string over here as well as the number. Now, store data is expecting the type. So at the moment, essentially, we have two options. Either we set up over here the default one, then we won't get the error over here. Or since, let's say, I'm not sure what data I'm expecting back, technically, I can hard code here any. I can say, yeah, I'm not sure what values I'm going to have in this array, so I'm just going to go with type any. Now, if we want to bypass this, essentially passing in any if we don't know what data we're expecting, we can simply set t equal to any or any other default type. As a side note, you can go here, for example, with string or whatever. It's just somewhat common to see any as default type. And in that case, we don't need to even provide it. So if I don't provide the type, then right away, TypeScript is going to use any as my default one. Again, kind of hard to see over here because we can clearly see basically what we have in the array. But just to showcase that I'm not making this up, let me grab the example from the README. So if you're interested, you can also copy and paste. Now, there might be some errors since I don't have those values over here. Don't worry about it too much. I just mainly want to showcase some stuff. Most likely you're familiar with the library called Axios, which is super popular to make HTTP requests. And normally the syntax is following where we go with Axios, then the method. Now by default it's get, but in here I hard-coded get as well. And we pass in the URL, and the data is located in the object in data property. Now, if we take a look at their documentation, we can actually see that get is a generic. What does that mean? Well, it's looking for the type, but if it's not passed in over here, it uses any. So if, let's say, you just called axios.get, it's going to set data as any. So whatever we're getting back. And we can actually see that if we continue inspecting the documentation. Notice there's also a second one, which is R, and that one by default is equal to Axios response, and it uses the type we pass in. So essentially, this is another generic interface, which is used as a second type over here. And essentially, it uses the T that we pass in. Now, if we take a look at the Axios response in our generic one, we can see that we're getting back this data, and this is set equal to T. But again, the default value is any. So for example, if we don't provide any info on a type, it's going to be equal to any, because that's the default, as we can see. It's used over here, it's passed down to Axios response, and the same deal in the interface. Now, if we set up the angle brackets and specifically say that, hey, listen, I'm fetching this data, but I know that the structure is going to be following. I'm going to get back the array of objects. And in there, I'm going to have name, which is going to be a string. In that case, this data will have this shape. So if we provide essentially a shape that we're expecting, then this T becomes that shape and goes all the way down to data. Now, if not, then they use the default parameter and essentially it's set equal to any. Now, I know it's a lot of code in here, a lot of angle brackets and that, but hopefully it's clear how we can nicely use type any if we don't know what shape we're getting back. Because again, think about it. This is an HTTP request. So the shape can literally be anything. And therefore the default one is any. And then if we provide specific shape, well, that's the shape we're going to have here in this data property. Okay. And while we're still on a topic of HTTP, let's also see how we can fetch data with TypeScript. Now, normally I use Axios library with React Query simply because the setup is super straightforward and React Query is really good at inferring the types. But let's start nice and easy and cover the straight up fetch API first. And also keep in mind that in this example, we'll just log the result. So we won't set any state or display pretty much anything in a browser. We'll just check for correct results in developer tools. All of that is coming up. Just be patient and wait for the React part of the course. Now, also, you will need the URL. So in the README, I provided a URL back to my server where we can just fetch some random tours. We were using this one in my React course to basically build one of the projects. So this is totally up to you. If you want to use this URL, feel free to do so. If not, if you have some other URL, you can, of course, use that as well. And for now, we'll just simply set up a fetch function. We will log the result. We'll see the issue if we don't have any type. And then in the following video, we'll have a challenge where you'll have to set up the type and proper returns and all that cool stuff. So for now, let me just grab, I guess, the URL. So we're looking for this one over here. And we want to come up with a function. So in my case, I'm going to go with a sync function. Let's call this fetch data. It's going to be looking for URL. It will be a string over here for now. No returns. We just want to set up the try catch. Since we have async operation, it's always a good start. Now in here, let's go with a response. So this one will be equal to await fetch. We pass in the URL. So notice how we can right away start using fetch. And actually we'll cover that in, I believe, 2-3 videos. How come we have access to this function without any issues and TypeScript doesn't complain. And fetch has this interesting setup where it doesn't treat, for example, 404 errors as errors. It only treats the network errors as errors. Basically, if you'll have 404 over here, it's not going to come up in the catch block. So we'll do a manual check where I'll say if response.ok is not set, well, then I'll throw my own error. Again, this is just an extra check we need to do with fetch. For example, you don't need to do that with Axios. So we'll go with throw new error. Then let's set up the template string. We'll go with HTTP error and the status here. Let's go with status, and we're going to set it equal to a variable. Let me access that. We're going to go with response that status. So now we're checking even if we'll have 404 error, it will actually trigger the error and we'll return whatever we have in catch block. And now let's access the data. Again, we're looking for the array of objects. That's what we have here. And you can definitely see that if you navigate to this URL in the browser and we want to set up another await. Let's go with the response and JSON. Let's invoke that. And at the very end of the try block, let's go with the return data. Now in the catch block, let's right away construct the message. So I'm going to go with error message, and this one will be equal to ternary operator, where I'll check if the error is instance of error. Well, then I will set the error message variable equal to error.message, since I know that the property is going to be there. If not, then I'll just go with something generic. There was an error. Like so. Let's set this one up, and then let's log, just so we can see what's happening. We're going to go with error message here. And then at the very end of the catch block, we want to return empty array. So if we're not able to get all of the tours, we'll return empty array. Now, I guess for now, let's just log what we have in the data, and let's invoke the fetch data. Fetch data, let's pass in the URL. If everything is correct in the console, we should see this array of objects. And if I go over here and mess with the URL, since I have this check over here, now the response is not going to be okay. And I can clearly see that over here. So we're nicely throwing the error as well. And this is going to be my error message. So this works. Now where's the issue? Well, let's go over here, set the tours away to tours. So now I'm essentially assigning this to some kind of variable, and notice something interesting. What is the type? Well, it's any, because TypeScript doesn't know what I'm getting back. So yeah, I was able to fetch data. I have access to it. I have no issues. But this is equal to type any. Now, why is that such an issue? Well, let's try doing this. Let's go with tours map. We know that we're iterating over, correct, our array, and we should have access to each and every object over there. But if I type tour, check it out. TypeScript immediately complains. It says, okay, I have no info on this. This is type any. So how am I supposed to know what is this tour? So we're not getting any suggestions. We're not getting auto completions, anything like that. So yeah, I can set this equal to tour any, and then go with tour.name. But I mean, this is not going to be sustainable in the long run. So yeah, I can nicely see everything in browser's console. But since we're working with TypeScript, we will have to figure out how to provide the shape of our data to TypeScript. So TypeScript knows that, hey, listen, this tours is going to be an array of tours where I have following properties. So I have ID, name, info, and rest of them. And this is something that we're going to do in the next video as a challenge. All right. And once we see the issue, now let's fix it. How? Well, we're working with TypeScript. So we need to provide the shape and set up the correct return type for our fetch data. And once we do that, TypeScript is going to know what we have there. And then we'll have auto completion, suggestions, and all that cool stuff. So here's the challenge. Set up the type, a hint. You can use the URL as your reference. And also set up a proper return type for the fetch data. Again, a hint. Remember that it's a promise, correct? Because it's async. So first, let me navigate to the browser, and I can see that essentially each and every object is going to have ID, name, info, image, and price. And guess what? It's pretty straightforward. All of them are strings. So now I just want to navigate back to tutorial. And somewhere over here, set up my type. I'm going to go with type, and name is up to you. In my case, I'm going to go with tour. ID is going to be equal to string. Then I have the same for name, info, image, and price. So you know what? Let me just copy and paste. Hopefully it's going to be faster in the long run. So we have info here. Then we have image. And at the end, we also have the price. Let's save this. And there's two places where we want to set up this type. So first, we want to set it here where we have the return. And I'm also going to set it over here where I have the data. So I'm going to say that I'm expecting from this .json back my array. And it's going to be an array of tours. And the same over here for my fetch data. I'm going to go with my return. And remember, this is async, correct? So what do we need to pass in? A promise. Promise is what? It's a generic. So we go over here with door, and then we pass here the array as well. Now, don't worry, if it's empty, it's still technically going to match whatever we have in our return. And now we don't want to set this as any, of course. We can actually go back and we'll nicely see that this is a tour. Why is that super beneficial? Because check it out. If I'm going to go here with log and tour dot, notice I have all of these properties right away available. I can go with name, save it. Again, the result in the browser is not going to change, but essentially, this is just a type safe way how we can fetch data. Where we come up with the type, we set up proper return, and after that, we can start using this data in a type safe way in our project. All right, and the moment we feel good about ourselves that we have nicely provided the type and everything is awesome, we can start using in our project. Let me throw you a mind grenade. So what do you think is going to happen if I'm going to remove some properties or I'm going to add some extra ones? So let's say if I'm going to go with something and then I'm going to set it equal to a Boolean. What do you think is going to happen? You think I'll have access to it? Do you think TypeScript is going to complain? And I guess you can clearly see that TypeScript is not complaining. And actually, if I go over here, technically I can even select it. But what is the result? I'm getting back undefined. So here's the kicker. Yes, this is definitely something we want to do. We do want to provide a correct shape to the TypeScript, but there's no way for TypeScript to check this at runtime. So yes, this is super useful for us to later use in our code. You saw previously what happens if we don't do that. Then basically TypeScript thinks it's any. But also, just because we set up this type over here at build time, it doesn't 100% guarantee that at runtime we'll get the correct results. Because this is just build time. In here we're saying, yeah, this is going to be my shape. So I can type here whatever I want, and TypeScript is going to be like, hey, listen, you told me that this promise is going to return the array of tours. And this is going to be the shape for the tour. But what if the something is actually not there? I mean, there's no way for TypeScript to check that. And therefore, in the following video, we'll take a look how we can do the runtime checks with the help of extra library by the name of Zod. Okay, and up next, let's see how we can validate data at runtime. First off, let me just mention that technically you can do it manually. So in this case, yes, we can iterate over data, check if the specific property exists, as well as has the proper type. And even though it sounds super cute, in reality, it can get messy pretty fast. So instead, if you ever need to validate data in such a way, Zod library is a very solid choice, simply because it provides a bunch of options out of the box, and it's far better battle tested than our own validation code. Now, you can use Zod in other scenarios as well. For example, in my Next.js course, we use Zod to validate form submissions on the client, as well as server actions on the server. If you are interested in learning more about Zod, just visit zod.dev, or you can follow the link I left in the README. First thing we'll need to do is install the library. So I'm going to open up the terminal. Now I'm going to open a new window. Technically, you don't have to. Just make sure if you stop the server to start it up again. Otherwise, stuff is not going to work. So in this window, I simply want to run npm install and Zod. So now we install this library. And as a side note, in few videos, we're going to talk about declaration files. So there's another reason why I'm installing this library. So we install the library. Okay, everything's beautiful. I can close this window. There's really no need. Then we want to import Z from Zod, and essentially it's a named import. And then we want to construct our schema. So let's set this one up. And you know what? I can just type it scratch, I guess. So let me go over here. Let me go with import, then Z from, and I'm looking for my Zod library. Again, if you have successfully installed, it should be somewhere over here. Notice I have dependencies, and there I have the Zod one. So we import the Z, and then we want to construct our schema. So this is very similar to what we have over here. This is going to be shape of our data, but difference, well, we'll use Zod methods, and this is going to be checked at runtime. So I'm going to come up with Tor schema, and as a side note, eventually we'll set this equal to a different value, but not for now. So in here we want to go with Z, and then the object is the method we're looking for. So I'm pretty much saying that I'm constructing an object, and here, yes, we pretty much want to provide the same properties. And as a side note, I think I can remove this something here and this one here as well for now. We'll figure out what we're going to do there in a second. And yes, we want to set up the validation for the same property. So this is not going to change. However, in this case, Zod provides a bunch of methods. Now, again, I'm not going to go through each and every method. In this case, we simply want to check whether this is going to be a string. And this is super easy. I can go with ID and then Z dot and then string. So this method essentially is going to check, is it a string or not? And if it's not a string, if it's not present, then basically it's going to yell. So now let's copy and paste, and we simply want to provide different values. So we're looking here for name. Then we want to get the info. We also want to set up an image over here. So image. Lastly, we also have the price. So all of them are strings, but the commas are missing over here. That's why I have the errors. So let me set this one up. And then as far as the Tor, we can actually infer the type. So I'm not going to leave this for your reference since you have access to it in a README. But essentially, I can go with type Tor, and instead of hard coding, Zod has this method of infer, and it is actually a generic. And we should be familiar with this one. So notice the syntax. Effectively, we just go over here with these angle brackets. And then inside of the angle brackets, as far as the type, we go with type of, and then Tor schema. So now we infer this Tor type. And notice pretty much the result is the same. But now we're nicely getting this from Tor schema. And like I said, you have more options. For example, ID has to be a string, but I can also add min, max, and all kinds of methods. Again, this is just scratching the surface. And notice how we don't need to change anything here in the return or also here in the data. But we do want to right now add some checks at runtime. And in order to do that, I'm going to rename this to raw data. So this is not something we're going to be passing. And instead, we want to go with const result is equal to. Then we go with our schema. It has an awesome method of array, which we can invoke. We're not going to pass anything in. And we also have this safe parse. So essentially, safe parse is not going to trigger automatically the catch block. We'll do it ourselves. So we're going to go with safe parse. We pass in our raw data. So now we're going to check this at runtime. Actually, not only at build time. And then since we have a safe parse, since this is not going to trigger immediate error, we want to check for the success property in the result. So if essentially we don't have the success property over there, then we'll go with throw new error. And let's again come up with some message. Let's go with invalid data, for example. Let's access the result dot, and we're looking for the error. So if we're not able to parse, then we'll throw the error manually. And now where we have the return instead of data, which we don't have anymore, we're going to go with result.data. So that's where our data is going to be located. And again, if we're successful, this doesn't change. We're still getting back that array, but the difference will actually check everything at runtime. So now let me navigate to the browser. I don't believe I'm doing anything. So you know what? Let me just log the result just so you can see what we're getting back. Let's go with the result. Notice we're successful. So success is true. So we bypass that error one, and then we get back the data over here. So now I can navigate to my map one. And again, I have access to the tour. So let's log something. Let's go with tour dot, and again, let's access the name. So this works. Now here's the biggest difference. If I'm going to go over here and let's say add a property, which I'm expecting, but it's not there, we'll actually get the error. So if I'm going to go with something and set it equal to whatever number, it doesn't really matter. If I go over here, notice how immediately this is going to trigger the error. So success is equal to false. And now I have this error message in the console. And again, the cool thing is that we're checking this at the runtime, not just at build time. Okay, and I think at this point, we're ready to talk about TypeScript declaration files and why they're so important. And let's start with a small recap. If I were to go to tutorial, and you know what, no, let me create a file first. So I want to create types, yes, and here I'll right away export, and I'm going to go with export type and random. And here, let's just go with name and string. If I were to import this, so import, I mean, with the type keyword or without, everything is going to work, correct? Because TypeScript knows everything about this type random. So I can start right away using it in our project. So far, so good. But can you explain to me this? How come I right away have access to the document object? So if I type over here, press dot, I have access to all of the methods and all of the properties. And of course, I'm not going to double check that. So I'm not going to prove that it's definitely a document object. But trust me, it's the same one. And again, good luck trying to build something without this document object. So how come we have access to it? Because I can guarantee you that I didn't set it up anywhere. It's not like I went to the types and then started constructing the document type. I mean, that would be just a work for, I'm not sure, half a year. So what's happening over here? Well, you see, when we work with TypeScript, there's something called declaration files. And the same is going to work for libraries, something we're going to cover in a second. But when it comes to TypeScript, they get included. And then essentially, as we're working with TypeScript, it already knows everything about the document. So if we go here to a type definition, there is a definition for this document. Like I said, it's going to be giant. But good luck working without the document. So in here, there's an info about every property, every method, what it's doing, what parameters the function is expecting, and that sort of thing. So in here, technically, there is no functionality that's going to be running in this file, but there's going to be type definitions. Since when we work with TypeScript, TypeScript needs to know everything about the shape of our data. Otherwise, as you saw with the straight up JavaScript file, it's just going to complain. So I guess first I'll show you where the declaration files are located, and then I'll show you how we can add them or remove them from the project. Now, as a side note, since we're using the boilerplate Vite application, it's already done for us. But yes, if you're starting everything from scratch, you can add those things manually. For starters, if we navigate to a node modules and TypeScript, which is a package we're using, under the lib, notice this long list. Well, these are declaration files. Again, once you navigate over here, let me just find something. Maybe this one over here, right? Notice you have these type definitions. It's not like in here you have some kind of function that's running. No, but you have clear description of type definitions. So again, if you want to start using something from the DOM, you can only do it if there's a type definition for that something in one of the files. Again, you'll see in a second, if let's say we don't have access to these files, TypeScript is not going to know what is a document or any other web APIs. And the way we control that, let me just close the node modules. Again, it's already set up for us, but essentially you can do it over here in this lib. Notice this DOM. Essentially, in the lib, you specify the set of bundle library declaration files that describe the target runtime environment. And notice over here, this DOM, well, if we remove it, notice something interesting. Immediately, TypeScript is going to complain. Immediately, TypeScript is going to say, hey, listen, what document? I don't know what you're talking about. So essentially, we can either set it up ourselves or we need to have those type definitions. Without those type definitions, we won't be able to essentially successfully build our project. So let me just close this one and navigate back to tsconfig. Let me add the DOM since I do want to use it, since we're building for the web. And this leads me to the second point. Yes, the same works with any library you want to use in our project. Remember how in previous video, we were able to import Zod from the Zod library, and we were good to go. So notice how, again, TypeScript is not complaining. And in fact, TypeScript knows everything that there is to know about the import. It knows the types it contains. It knows the methods, properties, and all that. How? Well, let's check it out. Again, we're navigating to node modules. I want to close this one. We are looking for a Zod in this case. And under the lib, guess what? Again, we have the type declaration files, and in there we have type definitions. And therefore, once we start using the library, TypeScript has no issues. It right away knows what the method is expecting, what is the interface, and all that. Which leads me to another point. Yes, if you're going to install a library which doesn't have the declaration files, basically there are no type definitions, you won't be able to use it. Now, the good news is that there is a repo which essentially contains the types for a bunch of libraries. But first, let me show you what happens if we install such library. What is the result? And again, this is just a random example. I'm going to use bcrypt.js, which is a password hashing library. And technically, this is optional. I mean, you don't have to follow along. I just want to showcase something. So let me go to a separate terminal window. Let me install it. Okay, I installed the package. Clearly see that it's in my dependencies. Okay, good. Let me remove all of this. I'm going to go with import bcrypt.js from, and I definitely have the library, but check it out. So essentially TypeScript is complaining there is no declaration file. So same issue like we had with the straight up JavaScript file. And like I mentioned before, the solution is following. There is a repo which contains a bunch of types. And I left the link in the README, so let me try to navigate over here. And in this repo, under the types, you'll be able to most likely find the library you just installed because it contains like what? 7,802 entries. So essentially you have TypeScript types for all of these libraries. And the one that we're looking for in this case is bcrypt.js. Otherwise, we cannot use it in the project. And the way we install the types is following. So we go with npm install. We're going to go with save dev, then add types, and then bcrypt.js. So our specific library. Let me grab this line of code. And the moment we do that, TypeScript is going to know everything that there is to know about this bcrypt.js. So if I'm going to go over here, type dot, notice I have access to all of the methods the import provides. Hopefully it's clear why TypeScript declaration files are so important when we're building the TypeScript project. And with this in place, we can move on to the next topic. Okay, and up next, let's cover TypeScript config file, where, as the name already suggests, we can configure our TypeScript setup. Now, if I'm being totally honest, I actually find this topic super boring, and therefore I'm planning to cover only the properties which, in my opinion, are the most important ones. But if you are interested in specific property, or maybe you feel like a rebel and you want to explore all of them, feel free to utilize this link in the README. So this is the link that you're looking for. As you can see, it guides us back to the documentation, and you can start scrolling, and you'll see that this is a giant file where pretty much you can find everything that there is to know about the tsconfig. Again, big picture, this is where we control our TypeScript configuration. I just want to mention that we have this include, and in here we point to where the TypeScript files are going to be located. So in our case, where it is, well, it's in the source. This is where we're setting up our project. Then we have compiler options, and let's start with the target one over here. And with this one, essentially, we control the output code. So we navigate to a TypeScript playground. Notice I have this export const and then the arrow function. Now, if my target is a JavaScript language version, which has the arrow function already, then as you can see, the output code is going to be pretty much the same. But if, let's say, I change this to ES3, notice how it didn't have the arrow function. And therefore, we get good old regular function. So this is what we control over here in the target. Now, as far as the module, remember, with this one, we're controlling what kind of module syntax. Again, we're going to get back in the output code in the lib. This is where we were controlling the declaration files that we're getting. And pretty much after that, the one that we're interested in is the strict one. So this is this flag which controls how a bunch of the errors and the warnings are treated. So if we're going to go with false, then a bunch of the things that technically should fail are not going to, and we'll be able to build the project. Now, if we set this one to true, then we have the strict type checking set to true. And then, for example, we have this no unused locals. So if I were to go to tutorial and come up with let something is equal to something, notice how I get this warning that something is declared, but I'm not using it. Well, if we go here and set it equal to false or just remove it, then essentially we'll have no warning message anymore. Again, just a example of one of the properties that we can use. This concludes the tsconfig, and with this in place, we can move on to the next topic. And up next, let's quickly cover class syntax in TypeScript. Now, if you don't use classes in your project, feel free to skip this section altogether, since most likely you'll see very little benefit. And first, let's start with a recap that classes in JavaScript serve as blueprints for creating objects. And they also have this special method called constructor, which is automatically called when we create a new class instance with the new keyword. And this keyword inside of the constructor refers to the object being created. So in this case, I have a class. Notice we need to use the keyword of class. Then the name is book. Now the convention is to go with uppercase, but technically you don't have to. And it has a constructor. It's a typical method. Basically, we can pass here params, and in this case, I have title and the author. So every time I'm going to go with new book and pass in the values, they'll be set inside of this object, inside of this class instance. And in order to set those properties, I need to go with this dot then the name of the property, in this case title, and I just set it equal to a value which is being passed in. So in this case, it's deep work and then the author name. Now, since we're working in TypeScript, notice how we have few red squiggly lines. How do we fix them? For starters, we need to set up the annotations over here in the constructor. So what is going to be the type of the title and author? And here, let's just go with string and string. And of course, we can use the Boolean, we can use the number, pretty much everything that we have learned up to this point. But here's the kicker. I still have the red squigglies inside of the constructor. And you'd think, okay, we can go over here and say that this is going to be a string and number or Boolean. But when it comes to classes and TypeScript, we actually need to go inside of the class and explicitly set the type for the properties we're setting inside of the constructor. So in this case, since I have two of them, I have title and author. Yes, I need to go above my constructor and essentially set this one equal to a string. And the same is going to go for author. So I set both of them up, and then notice now I don't have the red squigglies, and I'm able to create those instances. Again, result is going to be exactly the same. I will still have my instance, in this case, deep work, with the title and author properties. The difference, now TypeScript is happy as well. So I'll be able to build my project. Just like in normal JavaScript, we can also set instance properties, or they're also referred to as default properties. And essentially the idea is that we set this property inside of the class instead of the constructor, and then they get automatically added to all the instances we create. Now, how's that going to look like? Well, imagine we have this checked out property, and it's a Boolean, and initially it's always going to be false. So yes, definitely we can go here with this dot checked out. And again, notice we're not passing anything in a constructor. It's going to be set by default, and I'm going to go with false. So now I can navigate over here and say checked out and set it equal to Boolean, correct? So this is going to work. But since I'm not passing this as a parameter, we might as well set this one up as a default property. So I can just remove this line of code, and where I have the checked out, yes, I can still keep it as Boolean and set it equal to false, but we can also rely on the fact that TypeScript is going to infer this value. So this is up to you. You can go like this, or you can set up the checked out like so, equal to false, for example, or true, and then TypeScript will immediately infer the type. Now again, just like other times when TypeScript infers the type, just be mindful of potential pitfalls you might face. And if, let's say, we're going to go with deep work and checked out, we should see the value in the console. So at the moment it's false, and let's say if we decide to set it equal to true, that's also an option. So let's go with deep work, checked out, and let's set it equal to true. Now, since it's a Boolean, we can definitely do so. Now it's equal to true, but if I'm gonna change it to hello world, of course, this is not going to work. TypeScript is going to complain because it is a Boolean. So this is how we can set up default properties in classes in TypeScript. When we work with classes in TypeScript, we also have this read-only modifier, which does exactly what the name suggests. Essentially, if we add this read-only modifier to any of the properties, we won't be able to modify them. For example, if I'm going to go to my title, add read-only, yes, I can still read the value. For example, I can go with deep work and title, and for some reason, I keep forgetting to set up my logs. So we can still nicely access the value. The problem is going to be if we try to change it. So if we go here with deep work title and set it equal to something else. So this is not going to fly because now we have this read-only modifier added to the title property. Also, in TypeScript, we have private and public modifiers, which control whether we can access the property or the method from the outside. Now, as a side note, by default, everything is public. Therefore, if we go with deep work and type dot, notice we have access to author, checked out, and title. But if I'm going to navigate over here and let's say set checked out to private, notice how still we go deep work, and now I only have access to author and title. So yes, of course, I can go over here and say public. Just keep in mind that's the default behavior. Let me just set it up. So I'm going to go with public over here. And also, as a side note, you can combine them. So notice in this case, I have already read only for the title, but I can also say that this is going to be a public one. Now, typically, the way we control some private property is by setting up some kind of method which we can call from the outside. Just to showcase that, let me go with the method, and I'm going to call this checkout. Then let's set up the functionality where I'm going to go with this dot checked out, and I'm going to set it equal to true. So as you can see, I'm still able to access the property from within the class, but like we just saw, we were not able to see the checked out value from outside. So in this case, I can go with deep work, then let me call the method checkout. And now if we'll take a look at the deep work again in the console, the checked out should be set equal to true, correct? So let's navigate back over here and notice, of course, the value right now is true. So this is typically how we would access the value. We set this equal to private, so we cannot access it from the outside, but then we set up a method which actually controls this value. And just to hammer home that we can mix and match, I'll set up a few more methods. One is going to be is checked out, where we're just going to check the value. And then I'm going to set up the private method. So again, this is a bit of an overkill, but I'm just going to add this public one over here. As you can see, that's the default behavior. Everything is public. Then we're going to go with another one where we're just going to check what is the value. So we don't need to take a look at the console. So in here, I simply want to return this dot and checked out. And then also I want to set up the private one where we're going to toggle. So this will be a private method toggle, and let's come up with a name. Status. That sounds like a good one. Hopefully I have no spelling errors. And from this function, I simply want to return the opposite value. So I'm going to go with this dot, and we're looking for checked out. Now, since this is a private one, again, I'm not going to be able to call it here where I have my instance. Instead, where I have the checkout one, I'll just set it equal to this dot. So now I'm accessing the private method, and I'm invoking the toggle checked out status like so. And now let's just navigate over here. I guess let's clean up our code a little bit, and let's just invoke a few functions. So for starters, let me go with deep work. We have checkout. That's the one that we want to invoke. And after that, we're going to go with log. And again, we're looking for our instance. And now we want to check the actual status. And notice over here, this is set equal to true. So by default, it was set to false. Then I ran the checkout method, which essentially just toggles the value. And then I logged in the console that it's equal to true. Now let me try this one out. Let me run it 2 times. And now this should be set equal to false because we're just toggling back and forth. So this is how we can use public, private, and read-only modifiers in classes when we work with TypeScript. And up next, let's see an awesome shortcut we can use, which is going to save us quite a few lines of code. Now, for starters, I do want to clean this up since I want to discuss getters and setters in the upcoming videos, and I think it's going to be too much logic inside of one class. And also let me remove the first two properties as well as all of this code over here in the constructor. So the shortcut is following. At the moment, notice if I go with my deep work and type dot, I don't see anything, correct? Since we didn't set the properties correctly. But what we can also do is add read-only, public, or private modifier in front of the parameters. And if we do that, it will be automatically set as a property with the value inside of the instance. So let me show you what I'm talking about. We go here with read-only. And yes, even though it might seem redundant, since by default, technically, this is public, if we go here and set up the public, this will be set in my instance. Now, we're not going to use this value, but just to showcase that the same is going to work with the private, I'm simply going to go over here and say some value, and let me set it equal to a number. So now if I go to my deep work right now and type dot, notice I immediately have access to author and the title. So this is the shortcut. We don't need to use this anymore over here. We don't need to explicitly set these properties in a class. We simply can use either read-only or public or private. And effectively, immediately, TypeScript behind the scenes is going to set those properties with the appropriate values when we create the instance. Now, since you might not believe me about the sum value, let's come up with some random function. Let's just explicitly say that this is going to be public, and I'm going to call this get some value. Okay, and then we'll return this dot and some value. So notice inside of the class, I do have access to it. So let me call get some value, and we do want to place it in the console log, I guess. So get some value. Let's invoke this. Let's set up our log. Let's move this inside. And the moment it says undefined, because I did not provide the value. Okay, so notice, of course, it's missing. So I have some value, and since I'm looking for a number, I'm going to go with 45. So once we log right now, everything is correct. So again, this is an awesome shortcut we can use in the constructor. We can add one of the modifiers, and this will automatically set those properties in our instance. And up next, let's work on the example with getters and setters, which are special methods that are accessed like properties. More specifically, let's take a look how we can combine them with the private and public modifiers, which we covered in the previous videos. So one cool thing that we can do with the getter is to set up a computed property. So essentially, I can create the property on the fly. Now, in order to create the getter or the setter, we want to go with get or set keyword. Then we want to come up with a name. So this essentially will be a property on this deep work. And in here, I just want to compute some value. So in this case, I'm going to go with the template string. First, I'll access the title, and I'll combine it with the author. This dot author. Let's save it. And now we want to go with our deep work. And notice we have essentially this info property. Now, since we're returning the value, I keep forgetting that we want to place this inside of the log. And in console now we have title followed by the author. Again, what's super cool is that we can create this on the fly. So I can just come up with the property, then do my computation, and I didn't need to set anything in the constructor or above the constructor. And the same way we can set up the setter. The keyword we're looking for is set. And in this case, again, I'm going to control that checked out property. So first, let me start with a setter name. Now, just like good old method, we can provide over here parameters. And in this case, I'm going to call my parameter checked out. Now we do need to provide a type. And then inside of the setter, we're going to go with checked out, and we'll set it equal to our parameter value. And then let's navigate to the console log. And right after that, let's invoke our setter. So we're going to go with our instance, then the setter name. And in this case, again, this is the property. So we set the value. Now, if I'll try to go with hello, and notice how TypeScript immediately complains. So let me go back, and yep, I want to go with true. And now I don't see anything in the console since I'm not logging. Let me try one more time where I'm going to go deep work. And if everything's correct, the checked out should be equal to true. And we can use the private and public. As you can see, again, by default, everything is already public. But let me just showcase. If we go here with private, now we can only invoke this inside of the class. So this is not going to work. Let me comment this one out, and let me set up 2 more getters. One is going to be for the checked out value, and in the second one, we'll actually use the check out method. A lot of checkouts. So let's go over here with get. Now, as you can see, the name can be exactly the same because one is a setter and other one is a getter. By default, it's going to be public. And then from this one, we want to return checked out. And now just for kicks, let's set up a getter, but inside of it, let's invoke the setter just to make it more confusing. So let's go here with public, even though, again, technically it doesn't change anything in this case. I'm going to go with some info. We're not going to pass anything in. And in order to access our setter, our private one, we want to go with this dot checkout, set it equal to true. And then after that, we want to return. And since I want to return the same value, you know what, let me copy from the info and let me just overwrite in here. So now let's navigate to a console. First, we want to go with log, I guess. We're going to go with deep work, then some info. So this is going to set our checkout equal to true and also return this value. And also let's copy and paste and set up one more. And in this case, I'm looking for my getter, the checkout one. And once I navigate to a console, as you can see, at this point it's false. Then I get back the same info, the title followed by the author. And at the very end, we can see the checked out value, which is now equal to true. And that's how we can use getters and setters with public and private modifiers. And up next, let me showcase how we can implement the interface by the class. And if you remember the video types versus interfaces, it was one of the things which we could do with the interface, but we cannot do with the type. So let's imagine we have the interface and the name is I person, which essentially stands for interface person because there will be a class of person. Let's come up with some random properties. So we're looking for string. Then also we want to set up the age number. And you know what? Let's go with greet method. And it's not going to return anything. And it's also not going to take any parameters. Then we're going to go with class. Let's come up with a name. In my case, person. And we go with this implement, which essentially is promising that it will provide all of the properties and methods defined in the interface. So in this case, we're looking for I person. That's the interface I want to use. And in here, let's go with the shortcut, which we covered before. So I can go with public. Now, what is the name? It's a string, correct? So let's set up. And also we want to go here with public age. Now this will be a number. We're not going to set up anything in a constructor. Well, we don't have to. We still have a red squiggly line because there is no method. So right after constructor, let's go with greet. It's our function. And let's just log some stuff over here. In this case, we'll go with hello. My name is Slim Shady, and this is name, and also I am this.age. Let me access this.age, and we're gonna go with years old. Now we do want to set up our instance, so let's go with const and hipster. We're looking for a new person. Let's provide a name, shake and bake. And as far as the years, well, let's go with 100. And then at the very end, let's invoke hipster greet. And if everything is correct, we should see the text in the console. So that's how we can implement the interface with the class. Again, something we cannot do with the good old type alias. Okay, and once we're done with tutorial, let's put our TypeScript knowledge to a good use and create a small tasks application. As far as the setup for this project, I'm going to set my code editor and browser side by side, but you don't have to. It's just my preference, since that way I don't have to switch screens like gazillion times. Also, I will set up a new page. In my case, I'm going to call this tasks HTML. Keep in mind, technically, you can build everything in index.html. I just think that it's going to be easier if we separate the tutorial from the project. So here's what we want to do. Navigate to the root. Again, please don't set this one up in the source. We want to create a new file, and I'm going to call this tasks HTML. Now I will create a basic HTML structure, and in the VS Code, essentially, we just do that by getting the exclamation point, I believe. I mean, I haven't created the straight up HTML project in so long that I already forgot. So yeah, basically we want to click shift and backtick, and notice we get this suggestion from Emmett that we can create a HTML structure. Now in my case, I'm going to call this tasks app or tasks. Then also there's going to be a link for CSS. So that is coming up. And in here for now, let's just say tasks app. Let's save it. Now, this is totally up to you. You can navigate in the browser and just stay there. Or we can actually go to main TS. And notice we have both of these logos. Well, at the moment, these links navigate somewhere externally, basically back to TypeScript and Vite. And we can actually change this around where I'm going to go with / and tasks. And of course, if you named your page differently, please make sure that the href matches. And I'll do the same for this one. So now once I click on one of them, I'm going to navigate to the tasks app. Now, I'm not going to set up the link back. I don't think there's any need for it. For now, I think we can close the main one, but we will return to it. And also, let's create in a source tasks ds. So this is going to be our TypeScript file where we'll set up the logic. Let's go with ds. Now, in this case, we're not going to import that in the main ds. We actually want to go directly to tasks. Somewhere here, the bottom of the body, we want to go with script. Then we're going to add type module. And now let's look for source. We're looking for tasks, I believe. Yep, that was the file. And I always prefer to set up some log just so I don't run around like a headless chicken looking for a bug. But maybe there's an import wrong or something along those lines. Now, for some reason, yep, everything is fine. So I see over here the tasks. So I know that my logic works. Then let's navigate back to tasks HTML. And now above the script, effectively, we want to set up the structure for the application. So I just want to add some HTML elements. Now, this is totally up to you, but I also provided some CSS just so it looks a bit more presentable. Now, you have two options. You can either get it from the final folder. So navigate to the final repo, look for TypeScript tutorial, and then more specifically, look for tasks CSS. So I didn't want to add this code in the main CSS file. So we're going to create a separate file for that task CSS and then just grab that code. Or you can nicely navigate to the end of the README and just copy this code. Again, there's a bunch of base styles, so let's not worry about the CSS too much. As far as the actual CSS for the project, there's not that much code, but I'm not going to go over it because this is definitely not a CSS course. So just select everything inside of the backtick where you see the CSS. Then we want to go, I guess, let's set up in a source. Doesn't really matter. We're going to go tasks CSS, copy and paste. And now where we have tasks HTML, we want to set up a link. We're looking for the CSS one. And basically it's in the same, or it's not, sorry, it's not in the same folder. We're actually looking for tasks CSS. So once we add that, I mean, at the moment, most likely we won't see anything, but once we add our elements, we should have a nice CSS as well. And with this in place, now let's set up the structure. And I'm not sure whether I mentioned that technically the CSS part is optional. So, I mean, it's not going to affect any of our logic. Our application is just going to look tiny bit more representable. Then we want to go with tasks, so some kind of value. As a side note, we might need to refresh. Yep, now everything works. Now I can see my tasks over here. Then let's create a form. Now we won't have the action, but I do want to add a class. And even if you're not using my CSS, please make sure that you use the same classes. Or if you use a different class, make sure that you remember that when we are setting up the logic. Then let's go with input inside of it. The type is going to be text. Then we want to go with another class and we're going to go with form input. Let's save this. Okay. This is what we should see. Then also let's add a button. Type will be equal to submit. Okay, beautiful. Let's add a class name btn. Let's call this add task. Okay, again, I'll have to refresh. And then right after the form, we have unordered list class. Let's go with list. We're not going to place any items. So we will place the items dynamically with the help of JavaScript. And then at the very end, let's just add a test button because there's something we need to discuss first. So technically, this is not going to be part of the project, but it's super important we cover two things. And therefore, we're going to go here with the button. So we're creating the good old button. Let's add a class of test btn. And let's just right click me. Let me save. Let me refresh. And this is what we should see in the browser. And if you have the same result, now we can move on to the next step. Okay, and before we start typing away, let's address these two important points. First, when we use query selector, we actually get back the element, which is the most general base class that only has the methods and properties common to all kinds of elements. So that's point number one. Second, there's also potential for null. And we also need to address that. And no, we cannot build this project unless we cover both of these things extensively. Now, once we do, it should be a smooth sailing. So first, let me just showcase the two important points. If we go with const button, we know we have access to a document, correct? Because we have the declaration files and document has this awesome method called query selector, where we just pass the class in this case, and we can select the element. And everything is awesome, but as I hover over the button, notice it can either be an element. So it's going to be an issue if I try to get some properties and methods that are only specific to buttons, which is actually going to be our second point. And also, it can potentially be null. Now, why do we care about that? Well, let's say if I want to go with btn and then dot and event listener, it's not going to work. Well, technically it's going to work because TypeScript is going to fix my code, but notice it's only going to work if we go here with this question mark. So this is one approach how we can fix this. Because as far as TypeScript is concerned, there's no way to tell whether, yes, for sure, we're getting back the button. Unfortunately, again, this is build time. This is not runtime. So TypeScript is like, okay, you're selecting the element from the DOM. Potentially, well, this can be wrong, correct? And in that case, you're not getting back the element. You're actually getting back null. And we need to handle that. Also, don't be surprised if, in few cases, and as I note, yes, we'll cover that actually when we talk about the element point, you might need to do more checking. You might need to do something like this, where you go with if button and only then run the code. So this is one approach how we can handle the case where element is null. And yes, every time you'll want to do something with the element, you'll essentially need to first check whether the element actually exists. Now, another approach to deal with the null issue is by setting up the non-null assertion operator. So effectively in here, I'm telling TypeScript, yo, I know for sure that the element exists over here. And in that case, notice I can go here with btn, then dot, and then add event listener. And I don't need to use anymore the optional chaining. And the same is going to work if I'll try to run, for example, disabled on a button. I won't have to check for the element, whether it's actually present. So in here, I'm just telling TypeScript, listen, I know a bit more about my project than you do, and I know for sure that the element is there. And actually, if we take a look at the main TS, I believe it was over here. Now, don't worry about the code after. Essentially, they're just dynamically inserting the elements and all that. Notice this one over here, where they go with document query selector. They grab the div element. They're looking for the ID over here. And then they just tell TypeScript, hey, listen, we know that the element is going to be there. Now, how do they know that? Well, if we take a look at the index.html, notice this ID, it's app, correct? So you have two approaches. You'll see both of them used extensively. As far as your project, it really depends. If you like this approach where essentially you let TypeScript know, just be mindful if the element is not going to be there, then of course you will have runtime errors, or you can use the optional chaining, and then here and there you might need to actually check whether the element is present. So that's the first point that I wanted to address. Now the second one is following. I use over here this non-null assertion operator. Okay, everything is awesome, but what if I want to run disabled method? I know that the button has this particular method. So let's say I go here with btn dot, and then I'm trying to type, but I can see that it's not present. So something is off. Why I have such issue? Well, remember, we're getting back what? We're getting back actually an element, which is the most general base class from which all elements in a document inherit. Now, this one, the element, has only the methods and properties common to all the elements. So where I'm going with this? Well, there's going to be instances where you select elements and you need a specific method or a property which is only on that element. And this is the case. The button. I know it has disabled one, and I know for sure that I definitely want to use it, but I'm not able to because I'm actually getting back the element. Now, let's take a look. Why is that a case? Let's go here to type definition and notice the query selector. So query selector, surprise, surprise, is what? A generic. Now, It's looking for the type. And notice how there is actually type constraint, where it says, yeah, you can pass in the element, but it needs to extend from the element. So this is a more interesting case for type constraint. Instead of our string and number, our silly examples, actually this limits the element to the element. And not only that, notice how it actually provides this one as a default. And what does that return? It actually returns the element we pass in over here, or it returns null. So all of the things we learn, we can now nicely use when we inspect the documentation. So now it's very easy for us to look at this documentation and be like, okay, so we do need to provide the element we want to select. It needs to extend from the element. And if we're successful, we're actually going to get it back. So now let's navigate back. And in the query selector, we want to set up the angle brackets. And then we want to look for HTML, button, and element. So that's the one that we want to pass in. So now we're not getting back the element or null. We're actually getting back our HTML button element. So now if we start typing, notice btn, disabled, and we can nicely set it equal to true. Now, before I show you the type assertion option, which is another approach you'll see, let me just remove this non-null assertion operator and showcase that here and there, you'll have to actually check for the button. So remember our second option, where every time we will use a method, for example, add event listener, we'll need to add the optional chaining, which as a side note is already done by TypeScript in this case. In the case of disabled, it's going to be a little bit different. So if we'll try to do that, TypeScript is actually going to complain. It's going to say, hey, listen, you cannot do that. So instead, we'll have to check button, and then we can set it equal to true. Again, this just brings me back to the point that we have two options over here, and we can also always add this exclamation point. And as far as the second option, if we don't want to pass here in the generic, we can also use the type assertion. So let me just go here with disabled, and let's set it equal to true again. And let me remove. Now, once I do that, TypeScript is going to complain. And another approach that you'll see is this one, where we select, yes, we're getting back the element, but then we use that type assertion and we say, yeah, actually, this is going to be HTML and then button element. Now, I personally prefer the other approach, and that's why throughout the course, you'll see that one. But definitely, don't be surprised if you see something like this in the code base. This is also an option we can take where we select the element and then we just use the type assertion, and you have the example in the README. So I guess I can just remove pretty much everything over here because we'll start everything from the scratch and we'll start working with our form. So you know what? Let me clean this up. We also don't need that silly button over here since we covered two important points. And now we're ready to move on to the next step. Okay, so let's start working on our project. And in this video, I want to select three elements. I want to select the form. I want to select the form input as well as the list. So form input is where we'll get the value. We'll add the event listener on the form. So every time we submit the form, we will grab the input value. And also we want to get the list, since every time we'll provide here a task, if the value is there, then we'll basically add it to our list. And also, this is where TypeScript is going to come into play. We'll need to set up our type. So this is something interesting every time you work on a TypeScript project. Yeah, pretty much one of the first things you'll want to do is to start at least setting up the shape of your data. This is, at least in my opinion, biggest differences between a regular project and a TypeScript one. You'll always have the types or interfaces somewhere because TypeScript needs to know about the shape of your data. So let's start, I guess, by selecting all three of them. I'm going to go with task form. Now, I'm not going to use the non-null assertion operator throughout the project. I'm just going to use that optional chaining. So we're going to go here with document, then query selector. I do want to set up the angle brackets, and I'm just going to say that this will be a HTML form element or null. Then let's go with the class, and we're looking for the form. And I believe I forgot to mention, you see, there's no way for TypeScript to know that this definitely is a form. That's why we need to provide over here this form element. So it cannot magically go to the HTML and figure out that since we're using the form class, then for sure we're selecting the element, which is actually a form. That's why we get back this generic element, and that's why we need to use the generic to provide what is the element we're actually selecting. Hopefully that is clear. Const form input is going to be the next one. We're going to go with document query selector. Then we'll provide the HTML input element. So this is the element I'm looking for. Input element, okay, good. And then the class is dot, and then form input. Now, I think I can make this one so everything is in one line. I'm pretty sure we can see everything that's happening. I mean, you know what? No, let me make it like this. And then also let's go with const task list element. And this one will be equal to document, then query selector. Let me add the angle brackets. As far as the class, we're looking for a list. And over here, we want HTML, UL, and a list element. And my apologies, I'm just going to be kind of randomly moving this stuff over here. Don't worry, we shouldn't have issues with the later code. It's just these select lines. Then let's create the type, and effectively we'll have a task with description, which is going to be a string, and is completed, which is going to be a boolean. So let's set up this one, type task. Then let's go with the description, set it equal to a string. And yes, as a side note, you can set this one up as interface as well. It's just my preference to go with type aliases, and we're going to go with boolean. And then I'm going to set up an array of tasks. So this is where we'll store the tasks. And as a side note, eventually we'll grab these tasks from the local storage as well. So think of this as the state for our application. So we're just going to go with tasks. It's actually going to be equal to an array of tasks. And for now, it's just going to be empty array. Okay, and now let's start setting up the functionality. So we want to add event listener on a form. We're going to be listening for submit events. We do want to prevent a default. So we want to handle everything with JavaScript. And after that, inside of the callback function, we want to grab the form input value. If some value is provided, we'll actually wipe everything clean and return. And of course, before that, we'll have to do quite a bit of logic. And if there is no value, then we'll just set up the alert. So let's set everything up. We're looking for task form. Again, we can rely on TypeScript, or we can manually add this optional chaining operator ourselves. Then we're looking for add event listener. Like I said, we're looking for submit. And again, notice how helpful TypeScript is. So right away provides all the possible events that we can use over here. For now, we will provide callback directly, but in the following video, I'll show you the gotcha we need to be aware of. Remember, we have access to the event. Now, if we hover over, we can see that actually it has a type of submit event, something important we need to keep in mind. And then let's go with event. We're looking for prevent default. and we just invoke it. So now we'll handle everything with JavaScript. After that, let's grab the form input. And more specifically, we're looking for the value property, which again is on the form input. I'm going to give it a name of task description. Let's set it equal to form input. Same deal. We don't have this non-null assertion operator. So again, we can just rely, I guess, on TypeScript, or in this case, it simply complains. So we'll just need to add this optional chaining. So now we're grabbing the form input value if we have something in there, if the user has provided something. Then we'll do a list of things. If not, then go with alert, and we'll just say, please enter a task description. Again, it's not going to be the most complex application ever. Let me refresh and notice if I don't provide anything. Essentially, I just get this alert box. Now, if we're successful, again, there's going to be a list of things that we will do. But once we're done adding a task to the list, once we're done rendering the tasks and updating the local storage, at the very end, regardless, we want to set the form input value back to an empty string, and we want to return, since I only want to hit this alert if no value has been provided. Now, also for time being, you know what, let's just log here. Let's just say task description. So if I provide some random value, check it out. I have it here in the console. If not, again, we have this alert box. And with this in place, now we can move on to the next task. Okay, and before we set up the logic to add new task to our list, let me showcase the event object gotcha. And as you know, this is something you'll also see in React section of the course. So pretty much the main idea is going to be exactly the same, and it is following. You see, if we provide over here callback function directly, everything's awesome. TypeScript knows that, yeah, it's actually a submit event, but it's not going to be the case if we set up the reference. So we can go here with function, create task. As a side note, I don't think I'm going to keep it. So I'll just set it up and eventually remove it. But this is totally up to you. Of course, you can also keep this code. If we're going to go over here and basically take all of this logic like so, everything should work, correct? We have access to the event, and now we can just replace it. Well, let's see. Let's go with create task and check it out. So TypeScript essentially is saying that event right now has the type of any. So this is the case where if we're setting up functions and providing them as references here when we're listening for events, then yes, we'll explicitly need to provide what is the type. So in this case, we're looking for submit event. And once we do that, again, our logic is going to work. I can provide some value over here and everything is awesome. And the same is going to work with the empty value. And yes, the same you'll have to do in React. Now, in there, the code is going to be more complex, but the idea is the same. If you're listening for some kind of event and you set up the logic directly in a callback function, yes, event will have that correct type straight out of the box. But if you're setting up a function which you're then using as a reference, it's not going to be the case. Something important to remember. Okay, and up next, let's see how we can add task to our list. Now, in this video, we're not going to set up the logic to render any tasks on a screen. That is coming up. So most likely we'll do right after we are able to add task to our list. And in here, I want to first create a function. I'm going to call this add task. And as far as the parameter, it's going to be a task, but this is where we set up the type. So we definitely say that we need to provide the task, and we're not going to return anything from this function. And as far as the logic, we want to go with tasks, and then push, and we want to add our task. So whatever we provide over here. Then we want to navigate back to our if block. And you know what? Let's add 3 comments. We'll say add task to list. Then second one will be render tasks. And then we also want to update the local storage. So all of that is coming up. For now, inside of the if block, I want to construct a task. So if I have a text, I want to go with const task is equal again to my type, my task type. And I want to set it equal to description. This will be equal to task description. So this will be my string. And then as far as the completed one, we will hard code. So go with is completed, and we'll always set it equal to false. So once we create the task, now we can invoke add task and pass in a task. And since I have the correct type, everything is good. TypeScript is not complaining, and we can actually log the tasks here. So let's go here with tasks. Let's add something. So let's say first task, and check it out. Now I have my array with my first task. If I go with second task, it's not going to be surprised if we have 2 items in the array. And with this in place, now we can move on to the next step. Okay, and up next, let's render the task on the screen. Now we will call actually render task in 2 places. So for now, we'll only call it here in a task description block. So if we're successful, we'll just render it on a screen. But also, once we're able to grab the tasks from the local storage, we'll iterate over and render all the tasks on a screen. So think of it this way. Not only we want to render the task once we add new one to the list, but also when the user first navigates to the page or we refresh, we want to grab the tasks from the local storage where they are nicely saved, and we want to render them on the screen. As far as the function, first we just set up our keyword. I'm going to call this render task. And again, it's looking for a parameter, but the parameter has a specific type and it's equal to task. Then inside of the function, first I want to create the element. And in order to do that, I need to come up with a name. In my case, I'm going to call this task element. Then we go with our document. It has a method of create element. And we just need to provide what element we want to create. So either we scroll down or we just type li, and now we successfully create the list element. Then we also want to add the text content. Basically, it's going to be the value for our task description. The property is text content, and we set it equal to task. So whatever is passed in, and description. And then at the very end, remember we have our list somewhere here. That's the one. If it exists, if it's not null, then we want to add this element to the list. So we go with task list element, append child, again, TypeScript auto formats for us and just adds this optional chaining, and then we pass in our task element. So now let's navigate up where we have render tasks, and we want to go here with this function, pass in the task, and now let's try it out. If we're successful, we should see the task on a screen. So let's again go with first task and check it out. We successfully created the element on the fly. Same is going to be with second task and all the tasks we add to the list. All right, and I think we're at the point where we can add local storage to our project, because it's nice that we can render all the tasks we add to our array. However, if we navigate away or just refresh, notice how essentially we lose all the tasks since they're just saved in the memory. Now, before we do anything, I actually want to make sure I have nothing in a local storage. Otherwise, I might get some weird bugs. So let me navigate to my local storage and just clean everything. Again, let me refresh. I have nothing in there. So now again, I can make this one smaller. And as a side note, I'm looking for the console. Okay, good. And now as far as the functionality, we want to create a function called update storage. And in there, we will use the local storage, more specifically set item method, and we'll need to provide the value and just stringify our current tasks. So in my case, I'm going to do it over here. So we go with function. Let's call this update storage. And as a side note, yes, we'll call it in multiple places. So update storage, as far as the parameters, well, we're not going to pass anything in. And as far as the functionality, we're just going to go with local storage. Then let's go with set item. As far as mining, it's going to be tasks, then comma, and then we're going to stringify the tasks. As a side note, yes, pretty much every time we will add the task to our list, or when we click on the checkbox and we edit the task, when we set it equal to completed, or we uncheck that, yes, effectively we will overwrite all of the values that we have in the local storage with this new one. So we'll grab these tasks and overwrite with the current values. Now, when do we want to call it? Well, for starters, we want to do it over here. So we're going to go with update storage. Let's invoke that. And you know what? I will actually open up a bigger window. I think it's going to be easier to see. So that's my tasks. Let me open up the application. Okay, good. And then let's go with first task again. Yep. This is what we have over here. Notice tasks. And I have the array. And if I'm going to go with second task, now this is going to get added to the array. So this should cover when we add the task to the array. So this should cover the form submission. Now we also want to handle when we load the page. So at the moment, we always set it equal to an empty array, but we want to change that. And in order to do that, we will come up with a function called load tasks. Now you can set it up with all of the functions, but I'm just going to do it over here, since in my opinion, it's going to be easier to see the entire functionality. We are looking for a return, and from this function, we want to return an array of tasks. So an array, and type is going to be the task. Now inside of the function, first let's grab the tasks from the local storage. So we're going to set it equal to stored tasks. That is equal to local, or I'm sorry, not load, local storage. It has a method of get item, and we're looking for the tasks. Now, here's the kicker. Just like previously, this can be a null, and we definitely need to handle that. So in here, when we set up the return, we're not just going to go with stored tasks. Actually, we will set up optional chaining, and we'll say, hey, if there's a value, okay, awesome, parse it. So we're going to go with stored tasks, because keep in mind, we cannot store essentially objects in a local storage. We can only store strings. That's why we went with JSON stringify. And now we want to parse that value. But we only want to parse it if we get something back, correct? If not, well, then we'll just return empty array. And now where we have the tasks, we'll actually go with load tasks. We will invoke it. And since potentially now we can get some tasks from the local storage, we also want to iterate over and render the tasks. So for every task we have in the local storage in our array, we want to call render task method. So, I mean, somewhere after the tasks, we want to go with the name, so tasks, then dot. We're looking for each, and we simply can pass in the render task. Now let me showcase that. Essentially, it's pretty much the same as we have over here. So notice we can either go with tasks, then for each, and then pass in the callback function, or you simply provide the reference to render tasks. And now let me navigate to the browser. And if everything is correct, whatever tasks we have in local storage, once we refresh, we'll see them in the browser as well. All right. And at the end of the project, let's also add the checkbox to our list item. And every time we click on checkbox, we'll be able to control this is completed. So by default, it's false. But then once we click on a checkbox, we can actually toggle that. And I think I'll try to cover the part 8 and part 9 in this video. Hopefully it's not going to be too long. For starters, we want to navigate to render task. And at the moment, we're just adding the list item to our list. But we also want to add a checkbox to the item and then add that item to the list. Hopefully that makes sense. So let's go here with checkbox. We have const task checkbox. That will be my variable. We're looking for document, then dot. Then we want to create the element, and this is going to be the input. So not list item. We're looking for the input, and then we'll set the type to be equal to a text box. So we're looking for a task checkbox type, and we set it equal to checkbox. Then let's set checked equal to is completed. Again, by default, it's going to be false. So let's go with task checkbox. We have the checked property, which controls that, and we want to set it equal to task and then is completed. And now before we add task element to our list, we also want to go with task element. So task element, then append child, and we want to pass in task checkbox. And check it out. Now we have the checkbox. At the moment, it's not doing anything since we don't have any functionality, but we'll change that. Right after we create the checkbox, I also want to add the event listener. And the event we're going to be listening for is going to be change. So before we add it to a task element, let's call toggle checkbox. We're looking for our task checkbox. That's the element. Then add event listener. We're going to be listening for change event. We're not going to access the event. And as far as the functionality, we want to go with task and then is completed, set it to the opposite since we're going to be toggling. And the way we do that is following. So we go with exclamation point and task is completed. So we set it equal to the opposite and then we call update storage. So now once I click, and you know what, let me showcase that on the big screen. Again, let me start from the scratch just so you don't think that I'm cheating over here. And if we take a look at the tasks, okay, this is what we have, is completed is equal to false. But then once I click, notice it's set equal to true. So when I refresh, I get back the same result. This concludes the tasks project. Hopefully everyone enjoyed it. And up next, we're gonna take a look how we can use TypeScript in React. All right, and once we're familiar with the TypeScript fundamentals, let's see how we can use TypeScript with React. Before we begin, let me just mention that I assume you are already comfortable with React. So things like components, state, most common hooks, and some of the popular libraries. If you are confused about some React topics, please pause the video and utilize some external resources, since our main focus is going to be on implementing React with TypeScript. Otherwise, this part of the course will easily turn into a React tutorial. In order to follow along with this part of the course, you will need a starter project, which is the second folder in the main course repo. So if you have not already done so, get a hold of the repo, either by downloading or cloning it. And once you have the main repo on your machine, open the second folder in your text editor. So get a hold of the repo, open up your text editor, and then just access the second folder. Now it is a Node app, so same deal. We want to start by running npm install first. And also, or you know what, I'm not gonna set up such command because here and there, students complain that such command doesn't work on their operating system. So first, let's just run npm install, and then we want to go with npm run dev. And if everything is correct, again, you'll have the application on localhost 5173, And this is what you should see on the screen. And if that's the case, we can move on to the next step. All right, and let's start by taking a look at the files and folders, as well as the assets I provided. So we have node modules over here. This is where we have all of our dependencies. We have the public one. This is where we can set up some public assets. A source folder. Again, this is where we'll do all of our work. But in this case, we're going to be working with React. So we'll create components and all that cool stuff. We have the ESLint file, also a gitignore. Again, this just provides info, what files and folders are going to be ignored by the source control. Index.html, this is where our root component is going to get injected. So for example, if you want to change the title, feel free to do so. A package JSON. So in here, you could take a look what extra libraries I installed. And also we can see that we have the dev one. So that spins up the dev server. And also same deal. We have over here a build command. And before Vite builds the project, what do? We compile our code. Then we have the good old TypeScript configuration file, and also a few more configuration files for Vite and also the node one. Now, you'll also find the README over here. And just like in the first part of the course, we will use this README to set up the challenges, to take a look at the examples. I also provided some links to useful resources and all that cool stuff. And first thing that I just want to mention, essentially this project is a straight up Vite React.js boilerplate application. The difference, I just added some assets to it and removed some boilerplate files. That's it. So if you're going to run npm create Vite latest React TypeScript, so this is the name, of course you can change it, then the double dashes template and provide React.js. Effectively, this is the project you're going to get back. And like I mentioned before, most of our work we're going to do in the source. So let's just navigate over there. For starters, just like traditional React application, we have main TSX. So this is where we inject our app, basically our root component, into that div with the ID of root. Now also you'll notice few imports, but we'll discuss it later. I mean, these are just imports for some extra libraries we're going to use. Then we have the app TSX. So this is where all of our components are going to meet. You can also call this the root component. And we have a final and a star. And the way I set it up, notice these are all the topics we're going to discuss. And this is going to be our starting point. And in here, you'll find the complete code. So essentially, pretty much every time we'll start working on a new topic, we'll just import the specific folder. Because if you notice, all of them have index.tsx. So this will be the default import. That's just a node thing. And then as we're moving from topic to topic, we'll just change the path over here. Now, for all of them, you'll just find this standard component where I have few heading twos. And basically, I'm just displaying some text on the screen. So all of them pretty much will be the same. But of course, once we're done with the topic, there's going to be more files, more logic, and rest of the good stuff. And just to showcase how it's going to look like, let me navigate to app TSX. We want to go with import. Then let's come up with a name. In my case, I'm going to go pretty generic. I'm going to say component from. And now we want to go to a star /. And then again, we have all of these topics. And as you can see, they are numbered. So we'll start with return topic and then all the way to tasks. So let's go with 0, 1 return. Notice again, we don't need to provide the file because all of the folders have already a index.tsx. And then we want to replace it over here. We want to go with component and then render it on a screen. Again, at the moment, it's not going to change that much because we haven't set up any logic yet. And basically, as I'm moving from topic to topic, I'm just going to change over here the path. And then if you want to test something, of course, you can import the component from one of the final ones as well. Now, also something I want to mention, the idea with the React and TypeScript is following. If we want to set up components, basically Reacty stuff, we need to go with DSX. So that's the extension. Now, if you just want to set up some logic, some good old JavaScript logic, just like we did in the first part of the course, we just go with .ds. So whether you want to set up some hooks file or utils file or types file, that's the case, you'll go with ds. But the moment you set up the component, you want to go with TSX. Hopefully, I clearly explained how our setup is going to work. And if you're looking at the other files over here in the source one, we'll discuss them essentially as we progress with the course content. For example, the hooks, the store. So all of that is coming up. And I guess lastly, let me just mention that yes, I did provide some index CSS just so our examples look a bit more presentable. But again, this is totally optional. And with this in place, we can move on to our next topic, which is going to be the component returns in React. All right, so we have the correct import. Again, we're looking for *01 return. So that's where we want to navigate. And our first topic is going to be the component return. Now, let's establish a few things. For starters, what are React components? They are functions, correct? And what is the one thing that we know about function returns and TypeScript? Well, it's the fact that TypeScript infers the return type. So if I hover over, notice how TypeScript sees that essentially this is a component and the return is JSX element. So what does that mean? Well, if, for example, I'm gonna forget to set up the return, actually TypeScript is going to yell at me. So notice once I save, I have red squiggly line in app DSX. And if we hover over, we can see that component cannot be used as JSX component because it returns void. And a few things I want to mention. First, it's super helpful because when you're working on a bigger project, I mean, having no return sometimes can be tricky to spot as far as the errors go. And second one, this is something that I will probably repeat 10,000 times during the second and most likely also the third part of the course. Code error is going to be your best friend. The moment you hover over the squiggly line or in general, the events and state values and all that, it will immediately pretty much give you all the info you need. So in our case, let's say if we go back over here and set up the proper return, we can clearly see that TypeScript infers the JSX element, which leads me to another point. Can we explicitly write JSX element in here as far as the component return? Yes, it's absolutely an option. We can go over here. Even though it's already inferred, we can say, hey, you know what? I'm going to go over here with JSX element. We save it. And since in this case, I am returning a JSX element, there's no issue. Pretty much it's the same deal. But keep in mind, what if in your component, you decide that you're going to return a string? Well, now it's not going to fly because now I already have here an explicit return where I say, hey, I'm going to return JSX element. And what about null? What if I have some kind of logic and I'm going to go with null? Again, same deal. We cannot do that because we have explicitly over here this JSX element. Now, if you don't have that, TypeScript is smart. TypeScript can infer that, hey, in this case, it can be either hello, either JSX element, or null. So again, this really comes down to your preference. One option, you can simply let the TypeScript to infer the type. And at least at the very basic scenario, it's gonna help you to avoid this case. where you don't return anything. Second option, you can start hard coding over here. Explicitly, what are you expecting back from this component? Just keep in mind, as your logic changes, you'll have to adjust, because if you're just going to write all the time JSX element, well, TypeScript is going to be confused. So in this case, let me just hard code it. But for most part, I just let TypeScript to infer the type. So I'm going to go over here with JSX element. That's going to be one option. I'll say, hey, listen, it can also be null. And also, well, let's just set up a string type. Let me save it. And now notice TypeScript doesn't complain. Everything is fine because I have the explicit return and the options that I have inside of the component match to whatever I have over here in the list. So that's how we can set up component returns in TypeScript. All right, and up next on our list, we have, I believe, props. So first, let's change the path. So we're looking for 0 to props. Let's take a look at the browser. Yep, we have React, TypeScript, and props. So looks like everything is correct. And essentially in here, in the component, let's just provide some values. So we're going to go with something generic, for example, name and the ID, which is going to be actually a number. So 1, 2, 3. And immediately, once we add those values, TypeScript will complain. Because again, it's like setting up a function, providing the arguments, but we haven't set up the parameters. So TypeScript doesn't know what to expect. So let's navigate right now to our props index DSX. And let's take a look at the multiple options we have for props. And essentially the first one is the inline one. Remember, in React, props are gathered in this object, which we access either by just destructuring it over here, where we go with the curly braces, or we go with props. Now I'll show you the other option a little bit later. For now, let's just grab the object, the props object, and let's explicitly take a name and the ID. So those are the two values we're looking for. But before we can do that, since we're working in a TypeScript, yep, just like regular function, we'll need to set up the type. And the first option we have is basically set up everything inline. Now, I can tell you right away that it's most likely not going to be your approach, especially for bigger projects where you have components with a bunch of props, because it's just going to be very messy. So yes, in here we'll start nice and easy, but in a second, I'll show you also another approach that we can take. So in here, we just say, hey, listen, name is going to be a string and the ID will be a number. And the moment we do that, TypeScript should be happy. It's just complaining that we haven't essentially used it yet. Now, notice how everything's fine in the component. For some reason, it's complaining over here. So let's try to use these values and let's see whether that makes TypeScript happy. So I'm just going to change it around. I'll say heading 1. Now that one will be equal to name. And we're looking for our name value. And then the second one will be heading 1, and we'll just provide the ID. So let's go with ID, and then let's access that. Let's save this. And if everything is correct, we should see name Peter and whatever ID we provided. Again, we just go back to the fundamentals section where we learned that every time we have a function, we need to provide info to TypeScript. What is this function going to receive as far as the argument? And since props are essentially arguments that we pass in, when we construct the component, we need to provide the type annotations. And what's really cool, let's say that we're using this component in multiple places in our project. If for some reason I'm going to forget to provide one of the props, notice how immediately TypeScript is going to complain. So I won't have to realize this error at runtime. As I'm building the project, let's say that I'm setting up this component somewhere and I just forget that I also need to provide the name, TypeScript will immediately let me know that something's wrong. And actually the same works if I decide that the name is actually going to be title. I mean, it's quite common to have a component and you think that, yeah, the name for the prop name is awesome, but then you realize that, hey, you know what? Actually, prop name should be title. Let's say I do that. Notice how immediately in all the places where I'm passing in the wrong prop, it's going to light up. So again, imagine a scenario where you have this component in multiple places in your project. Immediately, you know that something is wrong. Again, something super, super cool where you don't need to run around like a headless chicken and then look for those instances. You'll immediately know where you provided the wrong prop. So let me set it back to name and ID. And up next, we're going to discuss alternatives to inline type annotations. Okay, so our initial setup works, but what if we have a long list of props? Or let's say we want to reuse these props. Well, in that case, we can either set up the type or the interface. Again, this is totally up to you. I'm going to stick with type just because it's my preference. I'm going to call this component props. And in here, we just want to provide pretty much the same values. So actually, you know what? I can just cut it out, remove these curlies, set it equal to, and then where I have my destructuring, I just want to set it equal to my component props. Save it. And since I don't see any red squiggly lines, I'm good to go. Now, also please keep in mind that alternatively, you can just reference the props. So in here, I can say, yeah, props is going to be equal to component props instead of destructuring name and ID. And then every time I want to access one of the values, I can go here with props ID and props name. Again, this really comes down to your preference. Some people prefer the props option and some people prefer this option. As long as you don't have the red squiggly lines, as long as TypeScript is not complaining, it does really come down to your preference. And the same goes for the type or the interface. So if you want to use the interface over here, you can definitely do so. If you prefer type, it's definitely an option as well. And while we're still on the topic of props, let's also discuss the special children prop, which allows elements and components to be passed into other components. So if I'm going to go to app DSX and set up my closing tag as well, and then let's say add a heading 2 with a hello world, TypeScript is going to complain because I haven't specified that I'm going to provide the children prop. Now the name is exactly the same, so that doesn't change. We just go over here with children. And yes, we do want to render it somewhere in our return as well. But now $1,000,000 question, what is the type? And essentially we have a few options. We can hard code it ourselves. And the type we're looking for is React node, and we can import it, or we can just go with React dot and then React node. So for example, this is one option we can take where we go with React dot and then React node. So that's the type we have access to. And the moment we do that, we fix the first error. But notice right now, TypeScript is complaining because since I set up my children prop in the props component, it's also expecting the same thing over here. And one easy way how to fix that is to just make this one optional, just like we covered during the fundamentals part. So I can just go here, say that, yeah, children might be provided or not. And if it's provided, then it's going to be a React node. Now, also a quick side note, just like with vanilla JavaScript, actually, during development, everything is going to work, even though we have the error. But please keep in mind, you won't be able to build the project unless you change some configurations and allow the project to be built with the TypeScript errors. Hopefully that is clear. So let me go back to this optional property and let me show you another way how we can handle the children prop. Alternatively, we can also import a special type from React, which is called props with children. So yes, we have access to a declaration file where there is a type called props with children, which actually is going to handle the children prop for us. Now, in order to import it, we're going to go over here with import. Now, I will add this type. Remember, technically, it's not a must. Then we're looking for props with children, and this is going to be coming from React. And if we hover over, we can nicely see the type definition. And this is where I would encourage you to stop the video and go over this logic and try to see whether you're able to understand everything that's happening under the hood, since we have covered all of these things during the fundamentals part. And again, reading such type definitions is going to be a good practice for us, not only to jog our memory as far as TypeScript, but also to understand what is the specific type or function or, I don't know, property actually doing. And if we take a look at the type definition, we can see that props with children is a generic, which again, kind of makes sense because it's going to be used in a lot of situations. So there's going to be the case where the component props has one shape, and then in the second component, the shape might be totally different. So again, a very good use case for generic. Now, by default, it's actually going to be set equal to unknown. So this will be the default value. And then notice how they use this intersection type. So essentially, whatever is passed over here is just combined with what? With children property, which is set equal to optional. So it might be passed, might not. And the type here is going to be equal to React node, or it's going to be equal to undefined. So let's try it out. I think I'm going to leave this one for your reference. So let me just copy and paste. Let me comment out the first one over here. And then instead of setting up the children property ourselves, we'll just go with props with children, and then we'll provide this value over here. So effectively, it's going to look like this. We're going to go with props with children. Remember, it's a generic, and it's looking for that type. And the moment we do that, as far as the result, notice we get back whatever type we pass in, and it's just combined with this children property. And with this in place, now I can go to the app, remove the heading 2, or provide the heading 2 to the second instance, and everything is going to work, and TypeScript is not going to complain. So again, when we work with children prop, we have few options. Either we can explicitly provide the value of React node ourselves, or we can import the props with children, which essentially does the same thing behind the scenes. All right. And once we're clear on component returns, props, up next, let's talk about state. So first we want to change the import, and this is actually going to trigger some TypeScript errors. So I think I'm just going to go with good old component for now. So let me render the component. Yep. TypeScript still complains because we haven't changed the import. So we're looking for a 0.3 state. And now we render the component. So now let's navigate to this particular component. And let's just, I guess, set up heading 2 with some kind of value, as well as the button, because inside of the onClick, we'll try to change the state values. So I think I want to do that first, and then we'll worry about the actual logic. So in here, inside of the div, I want to go with heading 2. I'll add one of the classes. So margin bottom is going to be set to 1. And I guess I'm just going to leave this one over here. Then let me go with a button. Let me remove this heading 2. And let me add some classes just so we have some basic styling. So btn center over here, and then let's just right click me. And eventually we will set up the onClick. Let's not worry about it right now. This is what we should see on the screen. Now, I don't know whether you remember, but actually we already covered sort of the use state during the fundamentals. We talked about it when we discussed the generics, but let's go over it one more time. So yes, we can nicely use state in React to control the local state. But if we take a look at use state, it's actually going to be a generic. So let's start, I guess, with the import. So looking for use state. It's coming from the React. And let me just hover over it. Notice this is going to be the type definition. It's a function. It's a generic. And essentially, we can either pass in the initial state or we can pass in the function. And as far as the return, notice it returns the value we provide in the initial state and the function that controls it. So where I'm going with this, if we have just primitive values in the use state, you'll see that TypeScript is very smart and it's going to infer the type. So for example, if I'm going to go over here with text and set text and set it equal to my use state, I don't need to set up over here the type and say that it's going to be a string, because TypeScript is going to know that. So if I'm going to go here with shake and bake, and if I'll hover over the text, notice TypeScript knows that it's a string. So essentially, whenever I will try to update this value, it's going to expect the string. And we can actually see that over here. If we go with onClick, and let's not worry about how we can handle events in React. We'll cover that a little bit later. For now, let's just pass in our arrow function just so we can invoke setText. And if I'm going to provide a wrong type, it's not going to work. So notice again, as we're hovering over, what is the setStateAction function looking for? It's looking for type string. So it's going to be okay if I go here with TypeScript. Yeah, there are no complaints. But if I'm going to provide the number, immediately TypeScript complains. Again, the logic technically is going to work during development. I can navigate over here, press, and technically I shouldn't have any errors in the console. Nope, everything is fine. But TypeScript is not happy with me. And the same is going to work if, let's say, I'm going to set up the number. So let me navigate over here, and instead of text, we're going to go with number and set number. Okay, good. And then we'll provide the primitive value over here. And you know what? Let me just comment this one out for your reference. If we're going to go with set number, again, we can see that set state action function, which essentially is a type for this one, for our set number function in this case, is expecting a number because TypeScript is going to infer the type. If I'm going to provide it, if I'm going to say 23, yeah, everything's awesome. If I'm going to go with some kind of string value, it's not going to work. Now, it doesn't stop me from explicitly going over here and saying number. I mean, we can still definitely do so. But again, the whole point is that TypeScript is going to do a very good job of inferring such type. Now, it's going to be a different scenario if, let's say, we have empty array as our initial value. So let's say we have over here a list, then comma, and set list, and we set it equal to use state and empty array. Notice how TypeScript essentially sets list to an array, but the type is equal to a never. And at this point, we have a few options. Either we provide some values over here, so TypeScript knows what the type is going to be. So for example, I can go with hello, but keep in mind, there are instances where you want the default value to be empty array. So I'm not going to provide some random hello just to make TypeScript happy. So the solution in this case is to use the generic approach, where we know that use state is in a generic, and we'll just say, all right, yeah, it's an array, but it's going to be an array of strings. And at that point, if I'm going to go to my onClick and go with my set list again, my function, everything is going to be awesome if I'm going to provide the strings over here. If I'm going to go with hello, and maybe I'll also add over here world. So this is going to fly because I have strings in my array. However, if we're going to change this around and we'll go with 1 and 3, notice TypeScript is not happy because it's expecting a type string. So this is how we can work with useState and TypeScript. By default, TypeScript is going to infer the type, but it is a generic, and there's going to be instances where we'll need to explicitly provide the type that we expect for the value, and automatically it's going to be set for the set function as well. Okay, and up next, let's cover an example where we have a list of objects. Now, in my case, I'm going to create nav links, but again, the actual data is totally up to you. So I'm going to go with a nav links. That will be my array, and I'm just going to provide some dummy data. And yes, I will, in the beginning, rely on the fact that TypeScript is going to be able to infer the type. So in here, I'm going to go with ID1, then URL. I'll just type some URL. So essentially, it's going to be some kind of string. And also text will be some kind of text. So some text. Okay, let's save it. Then we want to copy and paste. So 1 and 2. Let's just change these values over here. 2 and 3. And I don't think I'm going to change any of the actual values. I don't think it's relevant. Now I do want to set up the type. Type will be equal to a link. I'll say that ID is a number. Okay, awesome. Then URL will be a string. And then text will be a string as well. Let me save it. I'm not going to set it up over here. This is something we're going to do later. And now let's see how we can work with that in our use state. So in here, I'll call this links and set links. That will be my function name. We're going to go with use state for now. Let's not set the type explicitly. And now let's just provide the nav links. And again, TypeScript is super smart. Now it knows that essentially links has this shape. And essentially we can go over here where we have our own click. We can invoke set links. Let's say that I just want to add it to an existing array. So I'm going to spread out all the current links and I'm going to try to add a new one. If the values I provide don't match the signature, you'll see that TypeScript will complain. So if I'm going to go with ID4, then URL is going to be equal to hello, and then also a comma. And I'm going to go with, I don't know, what was the last one? I believe it was text, right? If I'm going to say hello, yeah, everything's awesome because this matches the signature. However, if I'm going to omit text, notice TypeScript immediately is going to complain because the text property is missing. So all of this is nice. The problem becomes this is inferred. And remember, when TypeScript infers something, it infers based on what? On the original value. So for example, if I just go and comment this one out, now notice TypeScript thinks that, yeah, links technically can be an array of objects with this shape or with this shape where text is actually missing. So now if I'm going to go here, I'm actually going to be successful. So this is a good use case where we want to go with our angle brackets and we want to say, yeah, we have these links over here, but actually the type is going to be following. It's going to be an array of link type. So now TypeScript is going to complain. It's going to say, hey, listen, whatever values you provided, they don't match. So we need to fix it over here. And now the same deal is going to be in our onClick as well. We'll have to provide, I believe it was our text one. Now, lastly, I just want to mention that technically we can avoid all of this debacle, pretty much if we just go with our type annotation over here and we say with the link, then of course I'm not going to be able to remove the property. But keep in mind, there's going to be some instances where you're not going to be setting that data. So again, that's why it's super useful to use the angle brackets and to explicitly let TypeScript know that the shape you're expecting is going to be following. And that way, essentially later when you need to update, it's going to be very hard to provide the wrong data. And up next, let's see how we can handle events in React. For starters, we want to change the import. So we're looking for starter and the number 4 events one. The component is not expecting anything because we just have the bare bones setup with the div and all that. And initially, I just want to set up 2 controlled inputs. One is going to be for text and one will be for email. And of course, in the process, you'll see why we have 2 of them. So let's do that. Let's go with use state. That is coming from React. Awesome. Then let's go with our text and email. And yes, I will rely on the fact that TypeScript can nicely infer the primitive types. So I'm just going to go with empty value. That will be my string. And the same is going to be for email. Let's provide the name here and let's go with email. Let's save this. And now we want to set up 2 inputs inside of the form. Again, just for better styling and all that, I'll wrap this into a section. Then we'll provide a heading 2. I'll call this events example. And we want to go with our form. For now, no action. Don't care about that. But we do want to add a class of form. And inside of it, let's go with input. Type will be equal to text. Let's just add a few classes here. We're looking for form input and margin bottom is going to be set to 1. Since I'm creating over here a controlled input, I'm going to go with value and on change. So let me go with value. So that will be equal to my state value. So I'll set it equal to my text. And then also we have on change, which essentially controls that value. So we're going to go over here with on change. In here, I'm going to pass in the arrow function. And remember, we have access to the event. And now let's go with our set text. And let's pass in event.target.value. So again, this is typical setup for controlled inputs in React. There's nothing really unique. Now we want to copy and paste. And we want to set up one for email. The difference, we're not going to use the arrow function. We'll actually set up the function reference. So type, yep, still equal to, or you know what? No, it's actually going to be email. Then the class name form input, yeah, that stays the same. Value will be email. So this is coming from the state. And also on change, like I said, there will be a reference. So you know what? For now, I guess let's just remove it, even though most likely it's going to complain. Then let's go with our button and just for kicks, let's go with type and let's set it equal to submit. Then let's add some classes, btn and btn block. And let's write over here, submit. And actually, this is something that we covered previously when we worked on the tasks application during fundamentals. You see in here, when we provide the arrow function, TypeScript will nicely provide the value for the event. As you can see, it's react.change event. So that's the type we get from our declaration files. And it's a generic. And essentially, we provide over here the element, the HTML input element. And this gives us a good clue what we need to provide over here in the function reference. So if I'm going to navigate up and I'm going to go with const and then handle change function. And if I'm going to try to access the event, TypeScript is going to complain and it's going to say, hey, listen, this is type any. So for now, let's not worry about it. let's just go with event.target.value, just so you can see that we can access that. And let's also go with our set email, and we want to provide the same value. So event.target.value. Now let me navigate to my browser. So at the moment, it's just complaining because we haven't set the onChange. This is our form. Notice I can provide the value, but I cannot do the same for the email. And in order to provide the correct type, again, we simply want to reference what we have over here. So notice this change event. We want to go with event, then React dot, and then we're looking for the change event. And if we take a look at the docs, if we take a look at the type definition, we can see that change event type is a generic. It's expecting a type, which is going to be the HTML element, and the default value is going to be element. Now, what we get back is target, and that will be the intersection type between the event target and the type we provide. So now let's navigate back to our index TSX and set up the angle brackets and provide the correct element. So we're going to set this change event on HTML and input element. So now we have access to the target as well as the value. So this is what we need to do when we set up the function as a reference. Again, if we just provide the inline one, everything is going to be set already for us. So now let me just navigate over here, and we're going to go with onChange, and we'll set it equal to handle change. And with this in place, TypeScript doesn't complain. And also we have the correct values in the browser. So let me go over here. Notice I'm able to provide the value, and the same is going to be with my email. Okay. And while we're still on the topic of events, let's cover submit event and few things we need to be aware of when we work with form data API. So let's say we want to handle the form submissions. We know that in React, there's onSubmit, and same deal. We can either pass in the inline function, or we can set up the reference. And just like with onChange event, essentially, if we pass here the inline, TypeScript will right away infer the correct type. If we set up the function reference, then we'll need to do it basically manually or ourselves. And you'll see that the form event is very similar to change event. It's also going to be a generic, and we'll just need to provide the correct HTML element. And I think I'll right away set up the function reference. But you know what? Before we do that, let me just mention that in between the videos, I added 2 attributes, one on each input, and it was the name attribute. So in here, I just set the value for text, and in here for email, simply because we will use the form data in this video as well. And in order to access those values, we need to add those name attributes. Now, I'm fully aware that these are controlled inputs, so technically, when we submit the form, we can access both of these values directly, but I do want to showcase some things about form data, and therefore I added these attributes. So if you want to follow along, I suggest you do the same. So like I said, I'll right away set up the reference. Let me go here with on submit, and I'm going to set it equal to handle submit, a function I don't have yet. So let me go with handle submit. And what is typically the first thing we want to do? That's correct. We want to prevent the default. So for now, again, I just pass in the event. And since TypeScript has no idea what I'm talking about, it's going to complain. And it's going to say that the parameter is any. So first, let me just set up the logic, prevent default. And if we want to get the type again, we can always use the editor as our best friend. So notice, essentially, we have over here the HTML form element, and then we're looking for form event. Or you can pass in the inline and you'll get the exact event type. So in here where we have the event, we want to go again with React, or we just import this type, then we're looking for form event. It's a generic, and in here we simply pass in HTML, form, and element. And now we have the correct type. So now we can use all the properties and methods, and TypeScript is going to be happy and not going to complain. Now, as far as form data, it's a nice interface to handle a case if you have a bunch of form inputs and you don't want to deal with controlled inputs. So you don't want to set up the state variables. You don't want to set up the on change as well as the value. Then it's pretty straightforward. Just set up the form, add those name attributes, and you're good to go. Once you submit the form, you'll have access to it by creating a new instance of form data. So in here, we want to go with const form data. We want to set it equal to new form data. So this is right away available to us. We don't need to do anything. And then if you don't work with TypeScript, essentially we have two options. We can either go with event.currentTarget, and notice how with TypeScript we can do the same. TypeScript is not going to complain. However, if we're going to go with event.target, which again we can do without TypeScript, actually it's not going to work if we use TypeScript. So let me just comment this one out for your reference. And actually, I'll use this one later on anyway. But if we go here with event.target, it's not going to fly. So TypeScript is going to complain. Now, a way around that is to basically go with HTML and then provide form element. So we just add this type assertion where, yeah, we're looking for event.target, but we say that, hey, listen, this is going to be actually a form element. Now, if we go with current target, TypeScript is smart and it can see that we already have this element over here. So let me, like I said, comment this one out and actually use the current target. And then one more gotcha about form data. Potentially the values could be null as well, and we need to handle that. So how does that look like? Well, for starters, let me just showcase how we can nicely access all of the values. So if we go here with object dot, then from entries. So now we just need to provide the form data and we'll get access to all of the values. So if I go with data, then let me refresh and provide some values. So some name and email at email.com. Let's see what we get back. Once we click on submit, notice we'll have this object. And even if we have 15 inputs, we'll have an object with 15 properties with all of the values over here. And as far as the gotcha, well, let me first create a type just so we can clearly see that. So let's say we have over here type person is equal to, and then name, and that will be equal to string. So pretty straightforward type. And then let's go here with const person. Let's set it equal to our person type. And we're going to go here with name. And now let's get the value. Now it's going to be the same for the object over here, for the text property inside of this object. But first, I'll just showcase what happens if we use the formData.get method, which is available to us. So let's say I only want to get the text value. I can always go here with text equals to form data, then dot get. Then we need to provide the name, and the names need to match. So let's say in this case, I want to access the text. Notice the value that I'm getting back. Either it's going to be form data entry value type, or it's going to be null. Now, why do we care about that? Well, if I'm going to set my name equal to a text, TypeScript is not going to be happy about that. It says, hey, listen, potentially it can also be a null, and you cannot assign this value to a string. So the way around that is to, again, use the type assertion, where essentially we go with as, and then we set it equal to a string. And here, again, I'm telling TypeScript that I know more about the project, where, yeah, maybe this can be null, but in this case, I know for sure that value is going to be correct because I know that these two values match. And now notice how everything works. And the same is going to be over here. Let's say if we go with data.text, remember that was the property name. Again, it's not going to fly. So in that case, we again need to go with as and then string. And now TypeScript doesn't complain. So just to recap, whenever we set up events in React, if we provide the inline function, everything is inferred as far as the event type. So there's really not that much difference between TypeScript or no TypeScript. However, if we set up functions as references, then we'll need to provide the correct type for the event. And there are two things that we're looking for. We first need to grab the correct event type, and also we'll need to provide the correct HTML element since most of these events are actually generic. Now, if we want to get the quick suggestion, we simply can set up the prop on the element and then provide the inline function. And the moment we do that, we'll get a nice suggestion with the correct event type and the correct HTML element. Okay, and up next, let's work on a small challenge. And I think it's going to be easier for me to showcase the requirements. So first, let's set up the import, but in this case, we're looking for the final folder. So all this time we have been importing from the star. This is the case where we will import from the final one. So let's go with import. Let's come up with a name. In my case, it's going to be component from. Then we're going to go in the final one, more specifically challenge, and then we'll set up two instances. So first we're going to go with component. We'll need to provide the type. As far as the values, notice we have two options. We can either go with advanced or basic. So let's start with basic. Then if we have basic, we'll also need to provide the name. In my case, I'm going to go with Susan. Let's close this component and let's set up another instance where we're going to go with component, then type. Now, if we go with advanced, now we'll need to provide more values. Not only we'll need to provide the name, which is going to be Anna, also we'll need to provide the email. And let's go with anna@gmail.com. And if we take a look at the browser, you'll see something like this. So this is going to be the look for the basic one. And this is going to be the look for, I believe the name was advanced. So here's the challenge. Create a component that has following features. If we provide type basic, we only look for name. However, if we provide type advanced, we also need to provide email. So for example, if I'll try to set up advanced without the email, TypeScript is going to complain. And also based on a type, notice how we have different looks. So for the basic one, we have this one. And then for the advanced one, we have a different look. Now, a tiny hint as far as the classes in here in the CSS, you're looking for alert and alert danger and success. So this CSS part is totally irrelevant. Technically, you can skip it. For example, you can just add a red text or something along those lines for one of the classes. The general idea is to create a component where based on that type, we are first providing different sets of props. And if we don't, then we get the error. And also we get a different look. So try to work on this challenge. And in the upcoming videos, I'll show you my solution. Okay, and first let me show you a typical React solution prior to TypeScript. We'll also take a look at the potential issues. Essentially, we won't be able to complete the challenge. And in the following video, I'll show you a proper TypeScript solution. So first, let me comment some things out. First one, the import, and then these two. So I still want these for your reference because they will help me to showcase the potential issues. And now let me grab the import component from, and now we're looking for the starter and same folder. So we're looking for the challenge and we want to render that component somewhere. So let's render the component. Let's take a look at the browser. So now we have React and TypeScript challenge. And initially our approach could look something like this, where we know that we need this type prop. We also know that we need name and email. And we know that based on that type, we'll display one set of classes. And if it's the opposite, then we'll display a different set. So let's navigate first to starter and then index. I guess we can right away set up the type over here or interface. That is totally up to you. I'm going to go with type, profile, card, props, 3 properties. So we start here with type. Just because I enjoy it so much, I'm just going to go with the literal type. So I'm going to say, yeah, the possible values here are basic or they're going to be advanced. Then there's going to be a name, which is a string. And also we'll set up the email, which also will be a string. Cool. An awesome start. Then in the component, I'll say, yeah, there's a props object. And actually, it's going to have this type. So profile, card, props. Okay, cool. Then let's gather all of these things. So we're looking for type, name, and email, and that is equal to our props. TypeScript is complaining because we're not using these elements. And you know what? Before we set up the return, let me just set up the logic for the class. So essentially, if the type is basic, I want to use the success one. And if not, I'm going to use the danger. Again, just to go back, notice in the index, we have this class for alert. So this is just going to add the padding and for radius and all that. And then based on this class, so either alert danger or alert success, we'll just have the background color and color. And yes, of course, we can set it up over here in the return, but I'll do it above, since in my opinion, it's going to be easier to see what we're doing. So alert type is going to be equal to type, then either basic or advanced. That is totally up to you. And I'm going to go with success, since that's the class name. And yes, they do need to match. And then based on this one, I'll set up my class name. So I'm going to go with const class name, and we'll set it equal to alert. So that's my main class, and then alert hyphen. And now let's access the alert type. So hopefully it's clear that if it's going to be equal to advanced, essentially not basic, then the value is going to be danger. If it's going to be equal to basic, then essentially the value will be success. And as a result, our card is going to look different. So in here, we want to go with article. And then let's add a class name. So let's access our variable over here, or constant, I guess more properly. And then let's just access both of the props. So the first heading 2 is going to be user. So we're going to go with user is equal to our name prop. Now, when it comes to email, it's going to be a little bit different, simply because we only want to display the email if the type is equal to advanced, correct? So in my case, I will only display the email if it's provided. Now we can set up the ternary operator, or we can use the good old AND operator. And I think I'll stick with that one because in my opinion, in this case, it doesn't really make a difference. So let's look for heading 2. Then let's set it equal to email. And now we just want to access the email prop. Okay, good. We have everything in place. Now let's navigate back and let's provide these values. And you'll notice something interesting. We will only be able to display the advanced component. Let me showcase why. So let me go here with type. We're looking for advanced. Then let's go with name. Again, doesn't really matter what we provide. So I'm going to go with Susan. And let me also provide the email over here. Let me go with Susan at Susan.com. Let me save it. Everything looks correct. But notice if I'm going to go here with the basic and just omit the email, I'm not going to be successful. Why? Well, let's take a look at our type. TypeScript is expecting this email one. So if I'll copy and paste over here, and if I'll say, yeah, the type is going to be basic, and actually I don't want to provide the email, TypeScript is going to complain. It's going to say, hey, listen, I still need this email. And technically you can make an argument, okay, well, I could provide email over here and just provide empty string. And even though it kind of works, you have to agree that this is somewhat clunky. My goal is to have a component where if I provide this type advanced, I am looking for email. And if it's actually type basic, I'm not even looking for this prop. That's my goal. Now, you could make an argument that we can go back and make this one optional over here. And yeah, technically it works for the basic one right now. But what about the advanced one? So now this technically is optional as well. So if I remove it, TypeScript doesn't complain. But if I navigate back, I'm not showing the email in my advanced user card. As you can see, in both of the cases, we have issues. We don't have the setup that we're looking for. And therefore, in the following video, we will cover a proper TypeScript solution. And since I know that I'm going to get this question a lot, let me just answer it here. No, adding following logic to our component is not going to solve the issue. So yes, definitely. Not only we can check for email, we can also check for type and set up the ternary operator, where if the type is equal to advanced, then we display the heading 2 with an email, and if not, we go with null. But notice our component. So for example, if I have the advanced one, yes, it nicely requires the email, and once I provide, everything is awesome. But it's going to be the same thing with our basic one. So since the prop is present, I need to provide it. And yes, I can still provide the empty string, but remember, that's not my solution. That's not what I'm looking for. I don't want to randomly provide these empty strings. And if we change this one around to optional property, same deal. Now, if I go to app TSX and remove both of these values over here, notice essentially the first card is correct, but the second one has empty email value. So yes, even though this one looks like a better solution, essentially it has the same issues as the one that we used before where we checked for the email. All right, and once we have covered the issues with our initial setup, now let's complete the challenge by constructing a proper TypeScript solution. For starters, I do want to remove these ones. So I want to start from the scratch. And essentially in here, we want to create two types. So our component actually is going to have two types. So the first one is going to be basic one, and the second one will be advanced. So we're not going to use this literal type over here. We're actually going to hard code it equal to a basic. And since there's going to be two types, I'll also name this one basic profile card props. Now let me copy this one. And in here, we want to remove the email. And it's not going to be optional anymore. So if the type is advanced, if we'll have this type, then we'll look for all of these properties. So type is going to be equal to advanced, name is string, and email is string. Now for the basic one, we'll only have type basic, and name type is going to be a string. Now where we have the component, I'll actually create another type. I'll say profile card props, and this will be a union type with basic profile card props and the advanced profile card props. And in here, we're actually gonna set up the return based on a type. So for starters, what two properties we can always access? Well, it's the type as well as the name, correct? Because keep in mind, we only have access to email if the type is equal to advanced profile card props. So therefore, we're going to look for two properties that are always going to be there. So name and type. And now, essentially, we want to set up our return where we're going to go with, well, if type is equal to basic, one of the potential values, then we'll have one set of elements. If not, well, then we'll return pretty much the other card. So let's go here with the return. We're looking for the article. So in this case, we don't need to set up that logic to add classes based on type. We want to go with class name alert, alert success. And then inside of the article, we're just going to go with heading 2, user, and we'll access the name. So let's set it up over here. And then if the type is advanced, basically our second option, you'll see that we have access to props.email. So let's go here with the return. And as a side note, you can actually structure it here as well. So in here, you can go with email, and actually TypeScript is not going to complain. And it sees that email is actually a string. Simply because if the type is basic, okay, we have one return. So it knows that at this point, the email has to be present. Now in my case, I will use the props.email. Again, it doesn't really matter which way you pick. So we want to go over here with article. Then let's add the classes. Now we just want to provide the different values. So it's not going to be success. It's actually going to be a danger one. And then inside of the article, we're going to go with heading 2. We're looking for user. Then we want to access the name, just like before. And we'll also add the heading 2 with email. And then we'll grab the props.email. So now let's navigate to app. And if everything is correct, if we type basic, we only need to provide the name and we'll get the correct look. However, if we go with advanced, we'll need to provide both of those values. So if we go with component type, notice we have basic or advanced. So those are our two options. If we go with basic, we only need to provide the name. So notice now we have property name is missing. Okay, good. Provide it. And notice how we don't need to provide an email here with an empty value. No, TypeScript is happy. Everything's fine. We have correctly a basic user card. Now, if we're going to go here with component type and we'll set up the advanced, now it's looking for name and email. So one by one, let's set it up. We have name. Again, let's go with our Anna and email. And let's just provide the value. Yep, looks about right. Hopefully everyone enjoyed the challenge and we can move on to the next topic. All right, and up next, let's see how we can use TypeScript with Context API. Before we begin, please keep in mind that we will write a bunch of deep boilerplate code, meaning don't get overwhelmed by the amount of code, since you'll be able to take it from project to project. And second, at this point in time, Context API is not as popular anymore. So if you don't find these examples useful, don't stress about it. In fact, if you don't use the Context API at all in your apps, feel free to skip the following videos. For Context API, I did prepare 2 examples, the very basic one with just one state value and a more complex one with more bells and whistles, just so we can cover all the topics step by step. So let's start just like with the previous examples where we want to import from the starter. In this case, we're looking for the context one. And in this case, we'll create 2 files. So one is going to be for context. And essentially in the index one, we'll access the context. Now, if you work with Context API before, you know that technically we can wrap the app component in context. We can also set it up in the main DSX. So there's tons of options, but in this case, I just decided to set up everything in the context, just so it's easier. Add it to the final one and leave it for your reference. So don't be surprised if in this example, we'll have two files. So for starters, we're looking for component. So this is coming from, we're going to final, and then we want to look for context. Again, let's render it somewhere here on the screen. The component one, and let's navigate to our 06 context one. Let's create a new one, and the name is going to be context DSX. In here, we need two imports, and you know what? Actually, I'll set up the third one as well, since we'll use it in the following example. So we're looking for two functions, create context one, and also use context, since we'll set up the hook as well. And then lastly, in the following example, we'll use the use state. So I'll add that import here as well right away. And for now, let's just create a new context. Now, as far as the naming, you'll notice that I keep using this theme, and it's simply because the following example is going to be for the theme, and I pretty much want to use the same names. So we'll just build on this example. That way we don't need to type too much. So theme, provider, and let's call this context. Let's invoke create context. Now this is going to be generic, and the difference between normal React and React with TypeScript is that we'll have to provide the default value. So in this case, I'm just going to go with undefined. Let's imagine that we don't know what the context is going to be. Then we want to set up a component, which is actually going to wrap all of our components and provide the context. So we're going to go here with theme provider. And if you're familiar with the context API, you know that this component normally is looking for children. So it's looking for the component since it's a context provider. So in here, we'll definitely need children. And we know already that as far as the type, we can either use the type provided by React, or we can just go with React and then dot and React node somewhere here. Now, as far as the logic, here's where we want to go with return, and we'll just set up one value. So we're looking for theme provider context. It has the provider component. So we go here with the provider, and then we want to wrap the children. So we'll go here with the children, and notice how TypeScript is complaining because we do need to provide the value. Now, once we provide a value, you'll notice that TypeScript is not going to be happy with create context setup. So for now, let me just showcase the basic example. Let's say I provide over here the hello. And the moment we do that, notice we right away get the red squiggly line. And the error message says, well, you cannot assign string to undefined. So this was okay initially when we were creating the context. We could say, all right, so it's going to be undefined. But now TypeScript is complaining. And in order to fix it, create context is a generic. And in here, we'll use the type union. First, we'll provide what is the eventual value, which will be a string here. And we'll also go here and say that it can be undefined. So this will be our initial value. And then this will be our eventual value. So eventually, we'll have this value equal to string. And that's why we have over here this type. I'm purposely keeping still this undefined because it's going to be super useful once we set up our custom hook. So even before we wrap any of our components, I also want to set up a hook called use theme. Again, I'm just going to keep these names since we will use them in our following example as well. And in here, we want to invoke use context, which is looking for the theme provider context, essentially any context. So let's set up this one. Context is equal to use context, and we're going to go with theme provider context. And now if the context is undefined, I actually want to throw the error. Now, when the context is going to be undefined, because at the moment we can clearly see that actually we do have a string. Well, this context could be undefined if, let's say, we're trying to access this use theme, but the component where we're using the hook is not wrapped in the theme provider context. And in my opinion, it's a good setup because that way we immediately can see that there is an error. And you'll see what I'm talking about in a second if this is confusing. So I'm going to go here with context. And if it's actually equal to define, I'm going to throw the error. And if everything is correct, then we'll return the context. So say here, return context. But before that, we'll go with throw new and error. And let's just provide some kind of error message. In my case, I'm going to go with use theme must be used within the theme provider. Let me save it over here. And now let's navigate to our index one. Let's import both things, the hook as well as the theme provider. And now let's set up the parent component. So we're not going to export this one as default. Actually, there's going to be a parent component where we'll have our theme provider. So first, let's start here with use theme. Okay, yeah, that's coming from the context. And I also want to grab the theme provider. And then let's set up the parent component. Again, this is just to demonstrate how we can wrap components. Please keep in mind that typically you'll do that in the app or in the main DSX. So we go here with parent component. That's our function, basically our component. And as far as default one, I actually want to export the parent component, not the component. And then in here, let's go with theme provider. And then inside of it, we want to place the component, essentially this one. And once we nicely wrap the component, we can actually go over here and I can go with context, go with use theme. So that's my hook. This is how I can access the values. And basically, if we log over here and provide the context, if everything is correct, we should see that value hello in the console. So now let's navigate to the browser and this looks interesting. So it looks like I'm grabbing the file from the final one. So let me navigate back. Yeah, we're not looking for final, my bad. So we're looking for the star in this case. And once we do that, notice the value is hello. And essentially it matches whatever we pass over here in the value prop. Now, of course, normally this is going to be more complex. For example, you could have here an object and name is going to be equal to something. Let's go with hello. Same deal. Now I'll just need to go back over here where we create the context and just provide that eventual value. So again, this is undefined. This is the default one. And in here I can say that, yeah, there's going to be an object and the property is actually going to be string. So notice now if we navigate to the console, we'll see this value instead. And the reason why this line of code is so useful is because if we navigate back and, for example, we forget to wrap everything in our theme provider. Basically, let's say that we are trying to access our theme context without wrapping the theme provider. And I'm just going to simulate that by returning a component. Notice how immediately I'm going to have the error in the console. And not only that, it's going to be super helpful where it's going to say, hey, use theme must be used within the theme provider. So this is going to give me a super good clue what is wrong with my current code. And of course, now I just need to go back and wrap everything nicely in the theme provider. So let me remove this one. And now again, we're good to go. The main deal over here, when we use TypeScript, we will need to provide what is the eventual type for our value prop over here. And we can simply say that, yeah, initially it's going to be undefined. And then eventually, whatever we set up in the value, we'll need to provide the type over here. And since the theme provider is always going to be looking for children, it's always going to be looking for components. Therefore, we'll need to provide a type for a children prop as well. All right, and now let's work on more complex example. Please keep in mind that this code is going to be available in the README, just in case you ever want to reference. And also in the final one, you'll find this basic context and basic index TSX. And essentially, this is the code that we set up in the previous video, because in my case, I will modify my existing code right now. So for starters, I'm going to go here with type and theme, and I'm going to go with literal types. So we'll provide light. We'll also provide dark, and we're going to go with system. And essentially, we're building here a theme context provider. So let's say in our application, we want to toggle between the light and a dark theme, and we want to do it globally. Therefore, we're going to set up the context provider. Now, let me navigate to theme provider, and essentially, I'll set up over here a use state. So I'm going to go with use state, and we know that it's a generic, and I'll say, yeah, the value is going to be string, but actually it's going to be type of theme. And eventually we will provide the default value. Let's not worry about it right now. And let's just go with theme. And as a side note, I do need to provide the square brackets. And we're looking for a theme and also a set theme. So we have these values over here. And as far as what I want to pass down, instead of this name, hello, we'll actually go with theme and also a set theme. So now, of course, TypeScript is going to complain because this doesn't match whatever I have here in the create context. So let's fix that. Let's set up a type for our state, which actually matches whatever I have in the values. So we're going to go here with type, theme, provider, and let's say state props or state. That's totally up to you. I'm going to go with theme, and that is equal to a theme over here. So theme type, and also a set theme. And essentially, we'll just say that it's a function, which is looking for a theme, and type will be equal to a theme, and it doesn't return anything. So we simply provide void over here. And instead of hard coding the object with the name property, which is a type string, we're going to go with theme provider state. Now, in this case, it's complaining because it says, well, theme can also be undefined. And we have multiple ways how we can fix that. Either we can provide the value like so. So I can just say, yeah, the default value is going to be dark, light, or whatever. Or in my scenario, I'm actually going to add one more property in the props. And therefore, I will set up a separate type. So I'm going to go with type, theme, provider, and let's call this props. And we'll look for two things. First one is going to be children. So this one is the same. So React dot, and we're looking for React node. And also, I want to set up the default theme. So let me add over here a property, default theme. I will set it optional, and I'll actually set it equal to type theme. So it's going to be optional, but it needs to match one of these values. So light, dark, or system one. And where I have the theme provider, I'll actually remove the hard-coded one and add theme provider props. And in here, let's go with default theme. And I will add some default value, which is actually going to be a system. And now at the very end, I'll go over here and provide default theme. And pretty much this concludes our theme setup. So as you can see, once we understand how we can set up a basic context with just one value, it's pretty easy to set up a more complex one. So now we just want to navigate to index TSX, and we want to change our component around. So this one will stay the same. And of course, if you want to test it out, you can provide over here the default value and all that. That's definitely an option. But in my case, I just want to grab the context with a theme, And I also want to set up a button, which I'll use to change the theme. So in here, right after this React and TypeScript, so I guess I'm going to leave that. I want to set up a button. And remember, now in our context, we have multiple things. Not only we have theme system, but we also have this set theme function. So I want to try to invoke the set theme on a button click, just so I can see whether my functionality works. So let's add over here a value. I guess I'm going to go with toggle theme. And then also let's add the onClick. So we're going to go over here with onClick. Let's provide the arrow function. And I'm just going to check what is the value. If the value is equal to dark, then I'll set it back to system. And if it's actually a system one, then I'm going to go with theme dark. So let's go here with context dot, and we're looking for theme. Then we want to check the value. Notice how we right away get our nice suggestions. I'm going to say if it's equal to dark, then I want to set it to system. So context, then set theme, and we provide the system one. Then we return like so. Now, if it's already a system one, then we just want to go with context, set theme, and we provide over here the value of dark. And you know what? I also want to add some classes here. So let's go with btn and btn center. Let's save it. Now I have my button, and pretty much every time I'll click on it, I'll change this value. Now we haven't set up any CSS, so nothing is going to change as far as the background. But notice as I'm clicking, I'm actually changing the value in the state. So that's how we can set up context API with TypeScript. Okay, and up next, let's see how we can use TypeScript with use reducer hook. And just like context, yes, it's not as popular anymore since we have options like Redux Toolkit and ZooStand, but you still might encounter it from time to time. And therefore, I decided to add it to the course. Just like before, we want to start in app DSX. Hopefully this time I'm importing from the correct folder. So let me go with star, and now I want to go to reducers. Okay, let's save it. Let's see. Okay, at the moment I have React and TypeScript reducers. Looks about right. And this is the case where I do suggest navigating to a README, and basically we want to get some star code because I really don't think that it's going to be beneficial to type this together. So essentially go to 07 reducers, and you're looking for this function. So this is what you want to set up in your component, not the app DSX. Make sure you navigate to the star 07, and we're looking for the index one. This is what you want to paste it over here. And essentially this is what you'll see in the browser. So we'll have increment, decrement, and reset. So at the moment, nothing is happening. We just have some console logs over here. And also we have this set status to active and inactive. So basically our state is going to consist of two things. So there's going to be some counter value, and also we'll change the string value of active and inactive, just to showcase how it works. And our goal essentially is to set up the use reducer hook and also set up the reducer, initial state, and all that cool stuff. So now let's navigate back to the component. We want to go with const, and this is returning two things, state and also a dispatch, and we set it equal to use reducer. So we import that, and it's going to look for counter reducer, so some kind of reducer function, and also initial state. So first, let me just provide these values. Please don't import them from the final one. We'll just go here with counter reducer and initial state. So I'll set up both of these values. Now, of course, we don't have them in this file. This is why we want to go to the folder and we want to create a new one. So in this case, I'm going to call this reducer TS. Again, if we have a component file, yes, we go with TSX, but if it's just going to be a JavaScript file, then we just go with TS. So let's set up reducer TS, and let's start with the initial state. So this is something we're going to export. We're going to go with initial state, In a second, we'll set up the type. For now, let's just go with count, which is equal to a 0, and then status, the initial value, will be pending. But this is where we'll change it to active and inactive. So now let's set up the type for this one. So export type counter state. And in here, we have two values. We have count, which is type number. And also we have a status, which is equal to a string. So now we just want to go here where we have the initial state and set up our type. So counter state. Okay, awesome. So we're exporting that. I guess we can now go over here with import, and we're looking for our initial state. And this is coming from the same folder. So we just look for reducer. So now we just need to set up the counter reducer. And for now, it's simply going to be a function. And if you know with a reducer, so it's looking for the state as well as the action. So what is the state and what are we going to do with that state? And for now, we're just going to return that state. So we're going to go here with export, then const counter reducer. So that will be the same name. And we'll set it equal to our function, our arrow function. As far as the parameters, this is what we're looking for. The state, which is actually equal to a counter state and action. And for now, let's just set it equal to any. Of course, as we're working on a functionality, we're going to fix that. And as far as what we want to return from the function, we're going to go with counter state. And then inside, we're going to go with a return and state. So pretty much for now, we're just going to grab the state and we'll return state as it is. So then back in the index DSX, not only we have initial state, but we also have the counter reducer. So in the upcoming videos, we can start working on the functionality. And once we have the setup in place, I guess let's start by displaying the value from the state. So at the moment, we're hard coding the count as well as the status, but keep in mind that in here we already have some initial values. So let's just access those. Count is going to be equal to the state that we're getting back. And notice how we have these two properties. And in this case, I'm looking for the count. And the same is going to be for the active one. Instead of active, actually it's going to be equal to a state and then the status. Let's save it. Notice now we have count, and also we have the pending one since that's my default value. And I think I'm going to start with these ones. So we want to set up a few types, one for increment, decrement, as well as the reset one. And we're going to start by setting up a type, and I'm going to call this update count action. So that will be my type over here. So let's set it up. So type update count action. And in here, I'm going to go with the literal one. So either it's going to be increment, decrement, or reset. So type increment, then union. We also can have decrement, and also we can reset the value over here. And now I'm going to create another type since there will be one for the status one. But technically, I mean, if I would only have the count over here, so if I wouldn't have functionality to change the status, I can simply go with update count action and set it equal to my action. So that will be my type. But since there's going to be more logic, I'm going to go with type and then counter action. And that one will be for now equal to update count action. So now where we have the action in the counter reducer, we want to go with counter action. And now let's set up our logic where inside of the counter reducer, instead of returning the state, we're going to go with the switch statement. And we want to go with action and type. Notice again, we have these potential three values, and then based on the actual value, we'll do some logic over here. So first, let's set up the default one. And let's say that by default, we'll just return a state. We'll say state over here. And then as far as the cases, let's go with increment first. So that's going to be our first case. And then we want to go with return. And we want to pretty much spread out the current state. So we only want to update and then count is going to be equal to state dot and count plus 1. And pretty much we want to do the same thing for the rest of them. So the second one will be decrement, case, decrement. As you can see, we only have two options at the moment. So decrement, and we just want to change this around where instead of +1, we're going to go with -1. And then lastly, we also have the reset. So case, reset. And if that's the case, we just want to grab this state and basically set the count equal to 0. Now, in order to invoke, we need to use the dispatch, and we need to pass in the correct type. So instead of just logging it over here, we want to go with dispatch, and then we need to provide what is going to be the type. And as far as the increment one, it's over here. And we want to repeat for decrement the same dispatch type, and then decrement. And then at the very end, we also have the reset one. So as you can see, the biggest difference is that now we have a clear control over the action type. So usually this was the biggest pain points where you could provide some random value. Once we use the TypeScript, it's actually not the case anymore. We clearly have a list of values that we can provide, and we're not going to provide anything random. So notice now I navigate over here to the browser, and I have these 3 working buttons. Okay, and let's also see how we can handle the action where we have the payload. So with our counter, pretty much we're only handling the type, correct? And then based on that, we control the state value. But we can also pass in the payload. And for starters, let's set up a type for that. So we're going to go with set status, and let's call this action as well. In here, there's also going to be a type. So this property we definitely need to provide. And as far as the value, I'm going to go with set status. And then when it comes to payload, I'm just going to go with few options. And again, I'm going to use my literal type. So I'm going to go with active. And also it's going to be equal to inactive. Then we want to navigate to our reducer. And let's set up the case where we're going to go with set and status. And as a side note, before we do that, actually we need to add this set status action to our counter action, type, because this is how we're checking actually in the reducer. So let's go with set status action. And now notice how we're going to get some nice suggestions. So if I go over here with case and then set status, now we just need to decide what are we going to do. And in my case, I'm going to return the state, so that doesn't change. And as a note, there is a error over here, and now we just need to update the, I believe what was the value, the status one, correct? So in the state, there is a status one, and we're just going to set it equal to action and payload. So we'll set it equal to one of these strings over here. So now we want to navigate to index DSX, and where we have the console logs to active and inactive. Same deal. We just want to dispatch it. Type going to be equal to, and we want to go with set status, and then we will need to provide the payload as well. So in here, let's go with payload, and this will be equal to active one, I guess. That's going to be the first button. And now we want to copy and paste and just change these values around. So instead of active, we're going to go with inactive. Yep. If I provide the correct value, everything's awesome. So now let's just navigate to the browser, and not only we can control the counter, but we can also change these values. So we can also pass the payload. And at the very end, let's also not forget about the type never. So let me navigate back to the reducer. And we can see over here that by default, we return the state, which technically is okay, but just keep in mind, we can add some kind of type over here, and this is going to fail silently. So for example, if I'm going to add another type over here, I'm going to go with something random. If I'm going to dispatch it, I mean, it's going to go through my cases, and essentially I'll just get back the state. So the problem with this one is that it's very hard to catch this error. And therefore, in here where we have the default, actually we want to add some logic where I'm going to go with const on handled action type. Remember, type is never, and we're going to set it equal to an action. And now notice how immediately it complains, because effectively there is another type. The moment actually it's a random one over here. And unless we handle it, so unless I go over here, case, and then random, and then decide what I want to do, for example, return, and then dot state. Unless I do that, there will be a error. And what's really cool that it's actually at build time, so not at runtime. So now let me remove this example over here, and let's just complete by throwing a error. So let me go with throw new error, and let's provide some error message. And once we have this one in place, now we can remove it. And not only will be able to catch the error, but also if for some reason we add a type and we dispatch it, there's going to be a super helpful error in the console, which right away will lead back to the counter reducer. All right, and up next, let's see how I can fetch data in React with TypeScript. And we'll actually look at two options, the good old use effect and fetch API, and my current favorite one, the React query with Axios. Please keep in mind that this section will only make sense if you watch the fetch data fundamentals part, since I'm not going to repeat things like ZOD setup and the actual need for types. Just like in the previous examples, we're going to start in the app TSX, where we're looking for component and more specifically the star and then 08 fetch data. And then if we take a look at the browser, this is what we should see. We'll also use the same URL like in fundamentals. So basically we'll fetch the same tours from my server. And therefore I suggest just navigating to README. You're looking for 08 fetch data and just grab these two lines of code. So we'll utilize these hooks in a second. And then also here's the URL we're going to use. So grab it over here. Then we're going to navigate back. And I guess let's just start setting up these state values. Now, eventually we'll set up the tours, but at the end of this video, I'll show you why we're not doing that right now. Why essentially we need a type first. And then let's set up two more state values. We're going to have one for is loading, and then also set is loading. So this is going to be true while we're fetching. We're going to go with use state, and we can provide angle brackets here. It's definitely an option. Or we can just type over here the default value, and then TypeScript is going to be super smart and is going to figure out that essentially this will be a Boolean. So I guess let's just go with that one. And as far as my default value, it will be set equal to false. Then we also want to go with is error, and we're going to set it to set is error. So that will be our set function. And here we're going to provide the angle brackets, and there's going to be a union type. So either it's going to be a string. So if there's error, I'm actually going to use the error message, or it will be null. And null will be my default value. So I'll just provide null over here. Then the good old use effect, and we want to set up the fetch function inside of it. So let's go with our use effect. Let's provide the callback function. We're just going to invoke it when the component mounts. And inside of it, let's set up our fetch data, which will be my async function. So fetch data, and let's set it equal to async. And as far as the functionality, since it's async, we want to nicely wrap everything in the try and catch. And also we want to start by setting is loading is true. So while we're fetching, we'll set it equal to true. And then at the end, we'll set it essentially equal to false. And you know what? Actually in here, let's go with finally. So in here, we'll just set it, set is loading and equal to false. So whether we're getting the error or we're successful, it doesn't really matter. At the end of the day, we'll always set it back to false. Now in the try block, this is where we want to construct our fetch, which again, we can right away start using because we have access to it. So we're going to go here with await fetch. Then we provide the URL. Then fetch API has that quirk where effectively we do want to catch the 404 errors as well. So I'm just going to check for that OK property. So if I have some kind of error, I actually want to throw it over here. So throw new error, which of course will right away lead to a catch block. And then as far as the message, I'm just going to say failed to fetch doors. And after this condition, I want to set up my raw data, since eventually we'll set up Zod as well. And for now, let's just go with response.json. And then let's log this data. So we're not going to set anything in the state. And when it comes to a catch, let's again construct that message. So we're going to go with message. And this one is equal to error. And we're going to check whether error is the instance of an error. And if that's the case, then we're going to go with error and message, or there was an error, so something generic. And we also want to go here with set is error, and we want to provide our message. So that should do it. We just want to invoke it over here. And we want to set up 3 returns. So at the moment we have 1. So basically this is our standard return. And now let's check for loading. Let's check for is error. And then let's see whether we actually are getting data. And then we'll discuss why we want to set up the tours in the following video. So let's start over here. We're going to go with if, and then is loading. Okay, good. And then we're going to go with heading 3, loading, and then ... Okay, good. Then we also want to do the same thing pretty much for error. So now we're checking for this value, and we're going to go with error, and actually we can display the message as well, just in case there is any. So I'm going to go with error, and let's access the error message. Is error, and then I'll just leave this one for now. So eventually we'll iterate over the doors. So now let me navigate to the browser. Again, if everything is correct, we should see those doors, and I can see the array of 5 doors. So that works. We should also have that loading for a split second. And let's say if we're going to mess with the URL, if I'm going to provide the wrong URL, notice now I have actually error, failed to fetch doors. And now again, let's reiterate, why do we need a type? So let's try to set up doors state value. At the moment, we don't have the type, so essentially we'll just provide empty array. Then let's try to set it over here in the fetch data, and then let's iterate over and see where the issue is going to be. So for starters, we want to go over here with const doors set doors. Okay, beautiful. Then we want to go with use state, and remember, if we're just going to provide over here empty array, which will be default value, notice now doors is actually set equal to a never, which means that, yeah, I can go over here and I can go with set doors. I can provide raw data. Okay, beautiful. Everything is awesome. And then let's say right after the React TypeScript, we're going to go with doors, then map. So we're iterating over. And then as far as the function, well, let's access the door, correct? Okay, good. And then we're going to go with some kind of heading 2. We provide hello. We can even see those hellos in the browser. Okay, beautiful. But what if we're going to try something like this? Let's say I want to access one of the properties. I'm going to go with the name one. So now if we go here and say tour and that dot name, this is not going to fly. TypeScript is going to say, well, you cannot access the name property on type never. And this is why we do, again, need to set up the type. And in our case, since we already know how to work with Zod, and since we're going to use Zod to evaluate our data at runtime anyway, this is going to be our approach. Okay, so now let's set up our type, and we'll do that with the help of Zod library, since that way we can also check the data at runtime. And this is totally up to you. You can set up the file name utils.ts or something along those lines. I think in my case, I'm just going to go with types. Now, as a side note, also in this file, we will set up a fetch function with the Axios. So that is coming up. So basically, we'll just jam a bunch of the things. Normally, in the bigger project, you would separate them, but I don't think there is any need. So we're looking for Zod library, which again is already installed. If you're using the starter, if not, then just please install the library. Then let's construct that tour schema, which will also then infer to be our tour. So let's export that since we also want to use that one in the index. So we'll go with export, then const tour, and then we're looking for schema over here. So this one will be equal to z.object. So this is what we're constructing. And I believe I had 5 properties in there. So all of them were string. That's for sure. So we're going to go over here. Then let's copy and paste. And I believe it's one too many, by the way. So let me remove this one. And then we have one for name. Also, we want to set up over here image. Then same deal, info. And at the very end, we'll have the price one. I'm missing commas, so let me do that as well. And now let's construct our type. This is something also we're going to export. So let's go here with export type and then tour, and that is equal to z infer. So now we just infer the type, which is a generic, and we're just going to go with type of and then tour schema. So now we have both. We have our schema and we also have our type. So now let's navigate back over here and we want to import both of those things. We want to grab the tour as well as the tour schema. So let me set it up. I think I'm going to type over here type tour just to make it more explicit what we're doing. So we want to grab the schema as well. And then this one is coming from the types. Let's save this. And now let's just start using the type. And I guess right away also the tour schema. So here, where I have the use state for tours, I actually want to go with tour and the array. So essentially, I'm telling TypeScript that, yeah, this is an array, but eventually it will be an array of tours. Then we're going to keep on moving. And where we have the raw data, same deal. I'm going to go with tour and I'll set it as an array. Then we actually want to run right now our tour schema. Remember, there is an array method. And again, I want to save parse it. So essentially, I want to throw the error myself and it's going to be nicely caught over here. So for now, I think I can remove both of these ones over here. We won't use them. And essentially, we want to get that result. So let's go to the result. Then tour schema array. Let's invoke this. And then we're going to go with save parse. And we're looking for raw data. And then as far as the result, remember, we're checking for the success property. And essentially, if the data is not present, then we're just going to throw the error. So we're going to go with if and result success. If that's not the case, then, I mean, you know what? We can actually log it. So let's go with the result, error, and message over here. And also, we want to throw our own error. So let's go with throw new error. And again, let's do the same thing. We'll go with failed to parse and tours. And then at the very, very end, we want to go here with set tours and we want to pass in result.data. So if we're successful, if we bypass this condition, pretty much we're good to go. And I think at this point, essentially, we can just navigate to our return and we can just set up the proper return. So in here, let's go with the heading 2. I'm going to add some class. So I'm going to go with margin bottom and set it equal to 1. Then we're going to go here with tours. Okay. And then let's iterate over. So we have tours over here. We want to call the map. And now once I type the tour, it will nicely be my object. Everything starting with ID all the way to a price. And again, this is something that doesn't stop to amaze me. So we're going to go here with return. Then we want to set up the paragraph. Again, we're not going to really work on amazing result in the browser. For now, we just want to grab the tour ID. We want to add some classes over here. So class name, and let's go with another margin bottom one. And then let's access the tour dot, and we're looking for the name. And again, if everything is correct, this is what we should see in the browser. Yep, everything is awesome. And if we go over here to the types, and let's say I'm going to add a property. I'm going to say that I'm looking for something, and that will be a string, and let's invoke that. Check it out. First, I have over here a error message in the console, and we can also see that over here. Now, $1 million question, do you always need to add Zod when you're fetching data? And honestly, most likely that's not something that you're going to see that often. For the most part, you're just going to rely on the fact that, yeah, the API is supposed to return some kind of type. But it does come in handy when you definitely want to check for that particular value. So this is how we can essentially fetch with React and TypeScript with the good old use effect and fetch API. And now let's see how we can accomplish the same thing with less lines of code and essentially no headache. And we're going to do that with the help of Axios and React Query. And if you're not familiar with either of these libraries, please utilize the library docs or some other online resource, since our main focus is going to be on TypeScript. And I actually want to start by constructing fetch tours with Axios. Again, normally you would set this up in a separate file, but in this case, I'm just going to do it right here in the types where I want to install, or you know what, actually, it's already available in the starter. We simply want to import the Axios from Axios library, which is an awesome HTTP library. And effectively, we want to construct right now the fetch tours. And you know what? I also want to grab right away this URL, and I'll actually remove it from this file since we'll set up use query over here. As a side note, as always, you can find the code from previous lessons in the README. So let me go over here. This is going to be my URL. And essentially, we want to go with export const fetch tours. It will be async. And as far as what we're returning, since it's a async function, we want to go with promise. And then we'll set up our tour array. And then when it comes to functionality, we want to use Axios, and we want to stick await in front of it. So let's go with const response, and that is equal to await. Then Axios.get. Remember, this is actually a generic, and therefore in here we pass in tour and array. So an array of tours, and effectively in this response inside of the data property, we'll get back our array, but it will be nicely already set as type array of tours. Hopefully that is clear. And we actually did cover that during the tutorial part. Now let me double check over here. It looks like I have a syntax bug. Yep, now everything's correct. So we have response, beautiful. Then we'll do the same thing like in the previous video, where essentially I just want to check using Zod. And since it's pretty much the same code, let me again just take it out and set it up over here. So we still use the result or schema. In this case, we're not passing in raw data. We actually go with response.data. Again, that's where the array is going to be located. And then from this function, we want to return. And we're looking for result.data. So since we have multiple libraries, yes, we're pretty much passing this array from one to another. So first, we use Axios, and again, just to demonstrate that, basically, if we go over here with type definition, you'll notice somewhere here, get, see over here, it's a generic, and essentially it has this Axios response. And then if you take a look at the Axios response one, notice this data, it's a generic type, correct? So whatever we pass in, this is what we're going to get back. And once we have this function in place, now let's navigate, I guess, actually to the main DSX, because we want to wrap everything in the query client provider. So we want to install React Query Library. You can also install DevTools. They have awesome DevTools, but in this case, we're not going to do that. And in here, we want to import the query client as well as query client provider. First, we want to set up a new instance like so. And as a side note, something I want to mention, React Query is actually very good at inferring the types. So as far as TypeScript is concerned, we actually don't need to do much. As long as we set up a proper return type here in the function, basically what we are returning, pretty much we're good to go. So in here, we want to go with new query client. Let's invoke this. And then we want to wrap our app inside of the render. So let me set up my query client provider. We're looking for client. That's the prop. And we'll set it equal to a query client. Then let's wrap the app. And now let's navigate to index.tsx. And like I said, I'll pretty much start everything from scratch. And if you want the code from the previous lesson, please just utilize the README. In here, we're looking for fetch stores, a function we just set up. It's actually located in the types, okay? And we also want to grab this hook, which we get from React Query, called use query. Again, this is coming from, and in this case, we have this stand stack and React Query. So we have both of these imports. Now let's set up our component. And let's also set up the export, since I know that I'm going to forget to do that. Let's export the component as default. And for starters, let's invoke use query. So we're going to get a bunch of the things back, and we want to set it equal to use query. So notice we don't need to set up our loading error or any of that stuff. And I'm not even talking about the use effect. Essentially, we just invoke the use query, and we're good to go. It's looking for two things. It's looking for a query key, since we'll nicely be able to invalidate those queries later. Something we're not going to do, but just telling you, it is an option. So essentially, you just provide some kind of string over here. So now this query, we will reference with the name of doors, just in case we ever want to do something with the query, like, for example, invalidate. And also, we want to set up a query function. Now, this query function has one rule and one rule only. It needs to return a promise. That's it. That's all we need to do. Now, if we navigate to types, what is this function doing? It's async. What does that return? It returns a promise. And like I said, React Query is awesome at inferring the type. So if we set up properly over here that I'm going to be returning an array of doors, React Query is going to figure that out. So in here, since I'm not passing anything in fetch doors, any kind of argument, I simply can set up the reference. Now, what are we getting back over here? We get back is pending. So this is while we're loading. We get back is error, if there is any. We also get the actual error object, just in case we want to get the message. And just like Axios, in here we have this data one. And inside of that data, we'll have that array of doors. Now, since I want to use pretty much the same name, I'm just going to give it an alias of doors. Okay, good. And with this in place, now let's set up our return. So one by one. First, we're going to go with is pending. So check that one. If that's the case, again, same deal. We're going to go with heading 2 or heading 3, and we'll go with loading. Then we're going to go with is error. So if we have the error, actually, I do want to access the error message. So let's go here with error, and we'll set it equal to error object. And in there we have a message property. And now let's iterate over the doors. Same deal. Essentially, we just want to showcase the tour name in some kind of paragraph. So let me set up the return. We're looking for div. Inside of the div, we're going to go with heading 2. Let's add a class name. Margin bottom, set it equal to 1. That will be equal to tours. And then we want to iterate over. So let's call map. Then each and every tour. Okay, good. And then we want to return from the function. And I'm going to go with my paragraph. Let's add a class name of margin bottom 1. And also let's add a key, and we'll set it equal to tour and then ID. And then inside of it, let's render the tour.name. And if everything is correct, again, the result is going to be the same. But like I said, way less headache, way less state values, and pretty much everything is already inferred. So we only need to set up a use query. We only need to set up fetch tours, and pretty much we're good to go. Okay, now let's cover Redux Toolkit setup, which is a good option if you have a global state. As a side note, if you're not a fan of Redux Toolkit, a nifty alternative is a library called ZooStand. I believe that's how it's pronounced, which offers pretty much the same functionality, but with less overhead. And the code is also less clunky, I have to admit. But since at least at this point in time, you'll encounter Redux Toolkit more often, I settled on RTK. As far as TypeScript, Redux Toolkit, just like React Query, also nicely infers a bunch of the things. So it's actually less work than, for example, use reducer. But I'm not going to lie. The setup, so the initial setup to add Redux Toolkit to our application with TypeScript is somewhat of a pain. Now, the good news, it's a boilerplate setup, so we can take it from project to project. So most likely, you'll only need to write it once. And in fact, we will do a setup in the following video. So for now, we'll just prepare everything. We'll actually create our first slice. And then in the following video, we'll complete the boilerplate setup. For starters, we want to go to app DSX. We're looking for starter, RTK, the component. If everything is correct, this is what we should see on the screen. And since we're shooting for the same functionality as in use reducer, I suggest navigating to README and just grab this code. So again, this is just going to set up some buttons, which we'll use later to control our state values. So grab everything in here. As far as the component is concerned, you want to navigate back over here, paste it, and again, you should have 5 buttons, and pretty much every time you click on a button, there's going to be some kind of console log. And then we want to set up a slice. Now, slice in the Redux Toolkit essentially is just a piece of functionality. So let's say in your application, you're handling the user. So the logout, login, whatever, all kinds of things. Well, you'll set that one up in a slice. Let's say you have a theme. You'll create a slice for that. And hopefully you see where I'm going with this. Now, in our case, we'll just dump everything in one. So I'll say counter slice. And we're looking for TS, since we're not creating a React component. Then we want to import 2 things. So create slice is going to create that slice for us. It's a function coming from Redux Toolkit. And second one will be payload action, which actually is a type. And this is something we're going to use towards the end of the video. So now let's go with create and slice. Okay, that's what we want to import over here. Good. Then let's also grab that payload, but this is actually a type. So payload action, and yep, it's coming from Redux Toolkit. Beautiful. Now we will set up some types in a second. Let's start by creating that slice. So counter slice, and this will be equal to create slice. And second, we'll provide some values. Before I forget, I do right away want to export. And actually, we export the reducer function. So we go here with default counter slice and then dot reducer. So this is something we're going to use when we set up the store. So think of store as pretty much your entire state. And then this slice, well, this will be that one functionality. Again, in our case, pretty much that will be the only functionality, but in bigger applications, this is where you'll set this one thing. And as far as the create slice, it's looking for a few things. It needs to have the initial state. And we'll also right away set up those reducers. So you know what? Let's just start setting everything up. If you remember, when it comes to the state, we have count and status over there. And then it will be our initial state. And this is something that we're going to provide over here in the create slice. So let's start here. Const initial state. For now, I'm not going to set the type. I'm just going to say that count is equal to 0, and then status will be pending. And remember, we'll just control it from active to inactive, I believe. Then inside of the create slice, we want to come up with a name. And essentially, I'm going to call this counter. And then also we want to go with our initial state. In a second, we'll set up the reducers, which control it. But before we do that, well, why don't we just knock out those types over here? So first, let's set up a type for the counter state. So type, counter, and state. And in here, count will be equal to a number. And then when it comes to status, I'll actually set up the literal type, because we'll use it later to provide a proper type to payload action. So we might as well set it up separately. So let's set up a status, but instead of setting up as a string, I'll actually create another type. I'll call this counter status. So this is essentially something we control when we add that payload over here. Now, when it comes to a counter, we'll press these buttons over here without the payload. And as far as the literal values, well, we're going to go over here with active, inactive, and let's also add the pending one. And once I have this one in place, status actually is going to be equal to a counter status. So now where I have the initial state, I'm going to go with my counter state. And then we want to set up those reducers. So reducers are going to be functions which essentially control the state. And then in order to invoke those functions, we'll need to dispatch them. And again, remember, when it comes to actual count, the number, the only thing we need is whether we want to increase, decrease, or reset. But when it comes to set status, this is where we actually pass in the payload. Now, the good news with the Redux toolkit, effectively, if we're just controlling this one value, we don't even need to provide the type. And you'll see what I'm talking about in a second. So we want to go with reducers. It's an object, and then one by one, let's set them up. And pretty much, I just come up with a function name. So for example, in this case, increment. I right away have access to a state. And as a side note, yes, Redux toolkit nicely infers all of the values that we need over here. And then, yes, we can essentially just overwrite. So I can just go with count plus and equals to 1. So notice I don't need to provide my type. Since I'm not providing any payload, that's it. I only want to set up this function over here, and we'll export it in a second, and eventually we will dispatch it. Hopefully that is clear. Then we want to go with decrement, I guess. Let's go with state. Same deal. We want to go with state count, and in this case, we'll subtract. And then when it comes to reset, we just want to access the state. Okay, good. And then set the state count equals to 0. As a side note, if you're wondering why we can just modify the state like that, why don't we need to return state from this function? It's because under the hood, essentially, Redux is using a library which does that for us. So that's why we can actually kind of modify the state directly in here. Under the hood, yeah, we're still getting the latest value. Don't worry. And then we have this set status, which essentially is going to have two things. Not only we'll need access to a state, but this is the case where we will provide the payload. So effectively, when we dispatch set status, we will provide that string value. And the string value is actually one of these ones. So either active, inactive, or it's going to be pending. And when we use a Redux toolkit, we do have this special type which we need to use. So it's called payload. And for some reason, it's not using. So payload action. I'm not sure why I'm not able to access that. So payload action. And it is a generic over here. And then inside of the generic, we want to pass in our own type. So basically, we need to provide over here this counter state. Now I do have over here a syntax error. And now, as you can see, everything works. So if you have the action, yes, you'll need to provide this payload action, which again is a generic. And then in here, you'll provide the type. So in this case, it's somewhat straightforward. We just have a string, but keep in mind, yes, if you have, let's say, an object with a bunch of properties, you'll have to set up the type and provide it over here. So TypeScript knows what do you want to do essentially when you pass in that payload. And same deal, we want to go with state.status, and that will be equal to action payload, since that's where we have the string. Now it looks like I have a bug. My apologies. By mistake, I provided the counter state. It should be counter status. My apologies. Now everything's correct. I don't have any bugs. And also, we want to export the increment, decrement all the way to set status. So we won't need to provide in our component, let's say, a type when we dispatch. We simply can pass in our action and we'll be good to go. So we go here with export const, and then we should have access to all of our functions. So increment, decrement, reset, and then set status. And that one will be equal to counter slice. And then we're looking for actions. This should do it for the slice setup. And in the following video, we'll do that somewhat annoying boilerplate setup where we'll add the Redux toolkit to our application. Okay, and now let's take a look at that boilerplate setup, where effectively we want to create two files. We want to create store.ts as well as the hooks.ts. And as a side note, if you're using the starter, you should have already those files. Now, there shouldn't be any code in them, but you should have the files. And store is where we set up all our slices. So we create that global store, and hooks is a special one because we're using TypeScript. And you'll see what we need to do over there in a second. So first, let's start with the store. We want to import configure store. This is coming from Redux Toolkit. And also, we want to grab counter reducer. Now, this one is coming from our slice, the counter slice. And I need to make sure that it's coming from the starter. So let me go over here with reducer from, and let me look for starter and the RTK. And then I want to get the counter slice. Let me just double check. Yep, I'm exporting, so everything is correct. And then back in the store, we want to invoke configure store. So we want to go here with export const store, since we'll wrap our entire application in the store. And inside of this function, we have a reducer property. And essentially, this is where we set up our slices. So in our case, again, we have only one. So I'm going to go with counter is equal to counter reducer. Since we're using TypeScript, we need to set up two more types. So export type. And again, in the docs, they use this root state. They set it equal to return type. And inside of this one, they go with type of and then store and get state. So this is what they pass into this generic. And the second type we want to set up over here is export type app and dispatch. And this one will be equal to type of and store dispatch. So once we have these two types in place, we want to navigate to the hooks one. And essentially, we want to grab use dispatch and use selector. So those are the two hooks we use with Redux Toolkit. One is to access the store, and the second one is to dispatch an action. And we want to create our own. And you'll see what that entails in a second. So let's first grab use dispatch. Again, this is coming from React Redux. So this is what I was talking about, the annoying boilerplate setup. But again, you only need to realistically do it once. So then import, this is actually a type, and we're looking for typed use selector hook. So this is coming from React Redux. And also, we want to grab that root state and app dispatch, the types we just set up. So let's go here with root and state somewhere. Yep, that's the one. And I also want to grab the dispatch. Okay, we have both of these. So now let's set up both of those hooks. So we're looking for export const use. And the name is totally up to you. Just make sure that it starts with use. That's just a rule for React hooks. And in this case, we'll actually go with the function. And we're going to go with app dispatch. And we'll set it equal to use dispatch. So it's going to suggest this use app dispatch. That's not what you want to use. You want to go with use dispatch, which is actually the second one. And then let's also set up the use app selector, which also we're going to export. So we go here with use app selector. And in this case, we just go with type selector hook. We provide the root state or type that we have in a store, and we'll set it equal to use selector here. Let's save it. And now the last step is going to be in the main DSX, where we want to import the entire store from store file. And we want to wrap it in the provider component, which is coming from React Redux library. Now this provider component is looking for store prop. And as far as the value, we'll pass in our store. So let's go here with provider, then store, set it equal to our store. Then let's wrap it. And with this in place, we have successfully added Redux toolkit to our application. And in the following video, we'll complete the functionality. Okay, so now let's navigate to 09 RTK index DSX. And we want to import a few things. First, we'll grab those hooks. So instead of use dispatch and use selector, we're going to go with use app selector. Use app selector, and we also want to grab use app dispatch. And then also let's grab those actions from our slice. So I'm talking about decrement, increment, reset, and set status. So let's grab also this one. This is coming from the counter slice. Okay, good. Then we have increment, then we have reset, and then we also have set status. All of that is coming from the counter slice. Now, in order to access the state values, we want to go with the use app selector. So that's the hook. And essentially by default, it right away has access to the entire state. So I'm talking about this one over here. More specifically, we're looking for the counter. So we're going to go over here and we're going to say state. And as I said, I do need to pass here the function. And then from the state, we want to access the counter. So this will be our tiny slice for the counter. And we can nicely right away the structure two things. What do we have in a state? We have the count as well as the status. So those are the two things that I want to access. So now where I have the count, I'll actually change it around and I'll set it equal to count. And as far as the status, same deal over here. Now, just to keep it more interesting, I'll actually navigate back to my counter slice and let's say set up my initial value to be equal to 15. So now I can clearly see that I have access to the counter as well as my status one. So now we just want to navigate back. And we also want to invoke the use app dispatch, which is going to return a dispatch function we can invoke. So let's go here with const dispatch, set it equal to use app dispatch. And then where we increment, decrement, and reset, we'll just invoke these functions. And then when it comes to set status, remember, we also need to pass in the payload. So it's going to be a little bit more code. So we want to go here with dispatch and we just want to invoke the increment. Same deal is going to be for decrement and reset. So I'm pretty sure I can just copy and paste. So we're looking for decrement over here. And then lastly, we have one for reset as well. So let me override this one. This should do it. Notice now we're actually changing the count value. And when it comes to set status, it's pretty much the same. We just want to actually pass in the string value, whether that's active, inactive, or pending. So let's go here with dispatch, set status. And again, we'll get a nice suggestion. So these are the values that we can pass in. So it's kind of hard to mess up. So let me copy this, set it up over here. And instead of active, we're going to pass in inactive. So now let me navigate quickly to the browser, and it looks like everything is working as expected. And with this in place, we have successfully added Redux Toolkit to our application. All right. And up next, let's build a small tasks application. Before we start coding away, let me just mention that if you enjoy the challenge and want to build this project independently, in the README, you will find a list of steps to build such app. So if this is something you're interested in, pause the video, complete the steps independently, and resume once you're ready to compare the results. As far as the app, it's actually very similar to the app we already built at the end of the fundamentals section. Essentially, we will create a form and a list of tasks, and if the user provides a valid input, we'll add a task to the list, and with the help of the checkbox, user will be able to toggle whether the task is completed or not. Now we'll start just like the other examples where we want to navigate to app DSX, and we want to grab our component. So in this case, we're looking for folder number 10, I believe, right? So we're looking for starter, then / and tasks. So let me replace whatever I have in here. Let me set up the component. Yep, I have task list. So that is good. And just like before, since we're working with TypeScript, one of the first things we'll do is to set up a type. And since we'll use this type in multiple files, it definitely makes sense to set up types. Yes. And in this case, there's going to be only one type, which will be a task. So we want to go with export type task. And in here, we have 3 properties: ID, which will be actually a string, then a description, which will also be a string, and then is completed, which will be a Boolean. Let's set it up. And then we want to create 2 more components, which we will render in the index DSX. So we have a form component. We set it up. And also there's going to be a list one, new file, and we're looking for a list. And then we want to create our component. And with this in place, now we want to navigate back to index, and we want to import use effect use state, as well as form and list, and also the type. So one by one, let's set it up. So use state, then let's also grab use effect, and then let's grab the form one, list one, and at the very end, let's also grab that type. So import explicitly, I'm going to type task, and then this is coming from the types. Now, inside of this component, essentially, we want to start by setting up the state value. So in here, let's go with tasks, set tasks, and this one will be equal to use state. Let's invoke this one, and by default, it's going to be an empty array, but we do want to provide the generic over here, and we'll say that it's going to be an array of tasks. And when it comes to our return, I think I'm going to replace the div with a section. And in here, let's type the form component first. And we also want to display the list. Let's save it over here. Now, for some reason, I don't see anything. Looks like there's a bug. So it complains that form doesn't provide the import. This is strange. Oh, yeah, probably because I didn't save it. My bad. Let me try one more time. If everything is correct, this is what we should see in a browser. And with this in place, now we can start working on the form functionality. Okay, and when it comes to form, essentially we want to set up the form element. Inside of it, there's going to be an input, and it's going to be a controlled input. So there will be a state value as well. And once we submit the form, we want to prevent the default. we want to check whether there's a value provided in the input. If not, then we'll trigger the alert. And if everything's correct, we'll add task to the list, something that's coming up. And also we'll set text back to empty value. I guess I'm going to start by setting up 2 imports over here. So we're looking for use state. And also we want to grab that type because eventually we'll use it, not for now. So let's go with type and task, which is coming from our types. And then let's start, I guess, by setting up that state value. So we have text and set text. And that one is equal to use state. And we want to start with empty string. Eventually, we'll set up the handle submit. For now, I just want to work on the return. So we're going to return a form element. We'll add some classes just so it looks a bit more representable. And we're going to go with task form. So again, on submit is coming up. Let's not worry about it right now. Inside of the form, we want to go with input. Type will be equal to a text. Class name is going to be form input. And also we want to set up the value since this will be a controlled input. And let's also set up the onChange. I'm going to provide the inline function since I don't want to bother with the event type. And we're just going to go with set text and we'll go with event.target and value. Okay, good. And then we also want to set up the submit button. So button, then type is equal to submit, and class name will be equal to a button. And we're going to go with add task. Let's save it. This is what we should see in the browser. So now let's just navigate back and set up that handle submit. So first, let me, I guess, set up the function. This is going to be essentially a repetition pretty much for stuff that we already covered during tutorials. So we're going to go here with handle submit. Remember, we do want to access the event, but we do need to provide the type ourselves in this case. So we're going to go with form event, and we're looking for HTML and form element. This is what we want to pass in. And as far as the functionality, first, we're going to prevent a default. So prevent default, let's invoke that. Then we'll check for text. So if no text provided, then we'll go with alert. And let's just go with please enter a task. Then we're going to return. So we're not going to do anything. And if everything is correct, basically if we bypass this condition, then we're going to go with add task and we'll go with set text and we'll set it equal to an empty string. So now let's just look for the form. We're looking for on submit and we'll set it equal to handle submit. So let's see. I think we can just log. So instead of adding the task, for now, let's just see what is the text value, whether we are successful. Let me type some nonsense here and looks like everything's correct. So I get the value in the console and I also end up with an empty input. Now, if I'll try to submit without providing any value, then we'll get back the alert. And with this in place, now we can start working on the add task functionality. All right, and up next, let's set up the functionality to add task to the list. Now, we can take multiple approaches. Essentially, we can pass down set tasks to a form. And let's say if the value is provided, we can invoke set tasks. It's definitely an option. But in my case, it's just a preference to set up everything in the parent component. And therefore, I will create another function and I'll call this add task. Now, this function is looking for one thing and one thing only, which is a task. But remember, we have a specific type for that. So we want to go over here with the task. Now, it doesn't return anything, so we can just call here void. And as far as the functionality inside of the function body, we just want to go with set tasks. We want to spread out all the existing tasks. And then we want to add the new one. So we'll go over here with tasks, comma, and then we'll add the task, which was provided to add task. We do want to pass this down. So add task is equal to add task. And if everything is correct, we should get a bunch of red squiggly lines somewhere. In this case, it's in the index DSX, simply because we haven't set up form to accept any props. So let's work on that. We already have the type task. So now let's set up our type here for the props. I'm going to call this form props. And in here, I'm looking for add task function. Same deal. It's looking for this argument, the task one, and it's actually type task. And then when it comes to the return, we're just going to go with void. And then right after our condition, I think I can remove that console log. I don't think there's a point anymore. We can just go with add task, and essentially one by one, let's provide those properties. We have ID over here. Remember, it has to be a string. So I'm just going to go with date. Then I'm going to invoke a get time method, and eventually I'm just going to turn this into a string. Then I still have a red squiggly line because, I actually haven't set up the props properly. My bad. What am I doing? Let me go here with add task, and this is actually going to be equal to a form props. And now we get the correct red squiggly lines, where essentially we can see that few properties are missing. So let's provide them. We're going to go with description. So this one will be equal to a text. And also, let's go with is completed, which we will hard code and set it equal to false. Now I don't have any red squiggly lines. And once we navigate to the browser, I'm actually going to open up the components just so I can see what we have as far as the state. And now let me go with first task. Let me invoke this, and yep, notice over here, we are successfully adding this task to our list. All right, so we're pretty much done with the form. I don't think we're going to work on that component anymore. Now we just want to render the list and also toggle the task. Remember, it has that is completed property, which is Boolean. And just like in the fundamentals project, we just want to display some checkbox, and then every time we will click on that checkbox, then we'll toggle that value. And actually, before we render the list, I do want to right away set up this function, since we'll pass it down to a list component. The functionality is super straightforward, where we want to go toggle task. Now this function is looking for the ID. So therefore, let's right away set up the inline type annotation, and let's say that ID is actually going to be type string. Now, as far as the actual functionality, we want to go with set tasks. And then remember, when we invoke map, we get back a new array. So now I just want to iterate over the array. And if the ID matches the task ID, I want to set the task is completed to the opposite value. Now, if it's not the case, if they don't match, then we just return task as it is. So let's go with tasks map. And yes, as a side note, there are a million ways how we can write this functionality. I just went with this approach. So we're going to go here with task. Then we'll check if task ID is equal to ID we're passing in. Then we want to return this task with a new is completed value. So we want to spread out the existing task, and we want to go with is completed and set it equal to the opposite. So we're going to look for task and then is completed. Now, if it's not the case, then we'll simply return the task. And with this in place, now we can pass this toggle task down, as well as our entire tasks list. So first prop will be tasks, and the second one actually is going to be toggle task. Now, we haven't set up, of course, anything in the list, so all of that is coming up. Let me just pass this down. We're looking for toggle task. Then let's navigate to our list. And first, let's grab our task. We will need our type. So import type task, and that is coming from my types. Yep, that's the one. And let's set up right away the list props. So type list props. And in here we have tasks, which is actually an array of tasks. And also we want to set up that toggle task. So toggle task, same deal. It's gonna have the ID, and actually that ID will be a string. But notice how essentially we're providing an object, correct? So make sure you have the same syntax. Okay, good. And in here we wanna destructure both of them. So tasks and toggle task, and we'll set it equal to list props. Beautiful. And now we wanna iterate over the list, display all the items, and also let's right away set up the toggle task functionality. So we're gonna go over here with unordered list. Let's add a class name of list. Then inside of the unordered list, let's go with tasks.map. Let's invoke this. And over here, we're gonna have a task. And then for every task, we want to set up the return. It's going to be a list item. And also we'll provide a key. That's a must. So we're gonna go here with task ID. Also, let's set up the paragraph. This is where we'll display the task description. As far as the classes, we're looking for task and text. And over here, let's set up task and description. So we have access to that. And now let's set up our input. So at the very end over here, we're going to go with input. Now it's not going to be a text. Actually, we'll go with checkbox. We're going to go with checked. So it has this prop, and we're going to set it equal to task and then dot is completed. So if it's true, then the checkbox is going to be checked. If not, then it's not going to be the case. And we'll right away add this on change. I will pass over here the inline function. We don't need actually the event. I simply want to go with toggle task. And then I want to provide the object with the ID property where I'm looking for task ID. Now, before you ask, can you essentially set up this ID as a straight up argument? So essentially without that object, yes, absolutely. It's just my preference to set it up as an object in this case. And with this in place, we're done with the list as well as toggle task functionality. So if I add a second one, I can nicely toggle over here this value as well. Now, if I'm going to refresh the page, of course, I'm going to lose all of the values since we haven't set up the local storage yet. In fact, this is something we're going to do in the following video. Okay, so now let's just add local storage to our application. And I want to start by navigating to the browser, to the application, and I want to remove the previous ones. I believe I still have values from the fundamental section. Then we want to create two functions. One is going to be load tasks. So we want to load the tasks when the application starts up. And we'll also have one to update the storage. And since it's a React project, we can use useEffect, and then pretty much every time there's going to be some change in a tasks list, we will invoke the update storage. Let's start with the load tasks function. So this function is going to return an array of tasks. As far as the functionality, we want to go with stored tasks. So that is equal to local storage. Then we're looking for get item tasks, something we don't have yet. And then we want to return. And then based on what we have in the local storage, either we're going to return those tasks or we're going to return an empty array. So let's set up ternary operator. We're going to go with JSON parse, and we'll pass in stored tasks. If that's not the case, we'll return empty array. And then in here, I'm just going to provide a function, and then I'm going to invoke load tasks. And then, like I said, we also want to set up one to update storage. So every time we'll change something about the list, be it add the task to the list or toggle the is completed, we'll update the storage. So update storage. Now this one is looking for the tasks, and actually it's going to be an array of tasks. Now it's not going to return anything, so we're just going to go with void, and then we want to go with local storage, then dot. We're looking for a set item. The name is going to be tasks. and we're going to go with JSON stringify since we can only store strings over there, and we'll provide the tasks. So this is how we're going to create those items, and then when the project loads, this is how we're going to access them. And like I mentioned, since this is a React project, we can go with use effect, and then pretty much every time there's going to be some change in our dependency array, which contains the tasks, we will also invoke the update storage and we'll grab the tasks value. So now let me navigate back to the browser. Notice over here, everything is empty. I have no tasks, but I can go with first task. Okay, good. Second task. Notice how they are actually saved in local storage. I can also toggle the is completed, and then once I refresh, I still preserve the values. That should do it for TypeScript with React section. Hopefully everyone enjoyed it. And up next, we're going to start working on a big TypeScript project where we're going to implement most of the things that we have learned in fundamentals and React with TypeScript sections.